Hello everyone, welcome to the R Masterclass course. My name is Abhijeet Singh and a little introduction about myself. I am currently working at Visuariate as a software developer. Previously I was working in Fire, which is India's fastest unicorn company. I have cleared Google Summer of Code, I have been into Summer of Bitcoin, and by the end of this lecture I want you to get excited why you should learn R. In this lecture we are going to learn why you should learn R, why R is still holding the strong position in data science, even though there are many programming languages that have been growing in outpace rapid speed, such as Python and Julia, but still R holds the strong position in data science and why a company still uses R. We are going to look at what are the job opportunities, job markets in R are, and in the end we are going to look at what are we are going to learn in this course. With this, by the end of this lecture, I want you to get very excited what you are going to learn in this course. With this, let's get started. So starting off with the first thing, we are going to look at the first meme, that is in other programming languages such as C, C++, Rust. All they have in this programming syntax, they need semicolon at the end. If you forgot, the compiler would complain, such as in C# also. If you forgot to add semicolon, the compiler would complain, hey, you have forgotten the semicolon. Whereas in R, the compiler is very much smart. It would automatically handle those in compilation. Also, if you are handling wrong data type, it automatically converts into the right data type that needs to be there, and our compiler is much more mature while doing this. So you could see how R standouts from other programming languages. So why you should learn R? Basically, if you are working, if you have to create statistical model such as linear model or polynomial model, R is the best model to go with. And if you are working on data analysis tools and you have visualization tool, even though you are in Python, you have matplot and others Seaborn libraries to visualize. And R, we have ggplot2, which is more robust. You could do much more interactive R plotting, and in many pharma industry, R is the standard way for data analysis and data science. So if you are doing statistical thing, R is the fastest way, and after in few minutes after we are going to look at compare the speed of R versus Julia versus Python in terms of statistical comparison, how fast R is. So you could see R was specifically designed for statistical analysis, where it's still holds the strong ground in that area, and it's used for data visualization plot. So it already comes with pre-installed library, that is ggplot2, which is more robust than matplot and Seaborn libraries. You could create a very interactive dashboard with ggplot2. So that's why R still holds the strong ground. It has vast array of packages and function for statistical technique, and such as ddplot and dd calculation to do your statistical analysis, and that's why it is excellent tool for scientists and statisticians. Now let's look at the comprehension package does R contain. So R have ggplot2. As we have discussed earlier, ggplot2 is for data visualization, which is more robust than matplotlib and Seaborn libraries in Python. And then we have dplyr, that is used for data manipulation. In Python we have similarly tools such as pandas and numpy. In R we have dplyr, and in we have tidyr, that is used for visualizing the row and column of the your data set. So this we have tidyr guy. In CSV we have numpy, and then we use show table columns, that is top 10 it shows table columns. In R we have tidyr, and then we have caret, which is used for classification and regression training, which is full form of caret, which is used for training model, for classification model and regression model if you are building, which are very powerful tool in data manipulation and visualization and modeling. Data visualization. So R holds a strong ground in data visualization. Many companies such as Pharma, Lupin company use R as a base standard for data visualization because you have very much interactive plots as compared to Matplotlib. We have ggplot2 and Shiny, which are data visualization libraries package that used to create highly customizable and interactive graphics very easily. And you could here see mentioned that are used for explanatory data and analysis. Next reason why R still holds strong ground is integration with other tools. If you are working with big data such as Hadoop, Spark, and SQL, you could easily connect R with it, and you could have it could easily work with your Excel sheet or other database you are working with. So if you are building some statistical model, R is the best way to go till now. Now let us look at the community and support from R. So R is open source and it have a large number of community active, and still many scientists and research users R for their work for data science basically, and R still holds it's a great beginner tool. Like if you are building a statistical model, what do I mean by statistical model? That is a linear model in which is in form of ax plus bx, 2 plus cx, and so on. If you have same model, then R is optimized for that, and it's have strong community and support from the team. So it is very easy to learn, although R have some weird syntax you might encounter with, but you might in this course you will get familiar that it is nothing new. You will be using a lot of that syntax, so it will be a second nature to use. It is used highly in academic. So if you are in doing your bachelor's or master's, and if you have specialization course in AI or in information technology or computer science, R might be the important course you have in those. So R is widely used in academic. R is widely used in academic and research purposes. So if you are enrolled in BTech or in masters, or you are doing your research, you might probably have course in R because it's a basic foundation for statistic analysis. So if you have a linear algebra model, R is the best way. So, and because R is much more robust and versatile, it have much more community and have integration tool to connect with other big data. So that's why R plays a basic role in data science. Next we have learning curve. So other languages such as Rust and have a very stale learning curve. So if you are learning R, at some point that curve becomes like a straight line, so you might not able to gain too much. But our learning curve is very much simple. So if you are learning R, it's very much exponential, so it's very easy. It have some odd syntax, but it once you try to use it, you will get an intuition behind it. It will be a second nature to you, and in this course, by the end of this course, you would be very much comfortable in R. Next, why is R is used is you could use it with Python and R. So in data science, you could have stronghold set in your tool list. So if you are applying to a job, companies have position which include R and Python. So you could have different models and tools to get analysis using R and Python. Job market, so R is very native, and since there is no too much competition in R, so there is a lot of open position in R. So if you learn R, you could easily able to get the data science job in R. And if you look at the demand for our jobs, you could see here that our jobs have been statically increasing, and while other are there might be fluctuation, but in R there is a sudden growth since LLM, and you could see that it is still growing. And here you could see that R is still growing compared to other statistical tools such as COBOL, SAS tools. And here you could see that the R market is still gaining their traction, and while this is gaining, the competition is very less. So the people who are applying in our jobs have very good chance to be get that high paying jobs. So now let's look at the Glassdoor our basic salary. So if you look here, you could see that our basic salary is about 62K, which is way higher than the Python and other statistical tools such as Julia. With this, I hope this make you excited. Now let's look at the comparison of speed in statistical analysis, which we will create a statistical formula and compare the speed of R, Julia and Python, and let's see which comes to the top. So if you are in data science and have statistical calculation, let's see which tool you should use. Obviously it should be you know that should be the R, because R is optimized for statistical calculation. Let's look at how much it's efficient in calculating all those. With this, let's get started. Now it's time to calculate the R statistical speed. So what we are going to do is we are going to create some random number. Here you don't need to get too intimidated. We are going to learn this whole R structure, and this is a script that what it does, it generate random data, and we print few data, and then we calculate the mean of those data. So you could see here we are taking million of data randomly, and then we calculate the mean. So R is very statistically optimized, so it should be better performing than Python and Julia. If you take matrices and multiply it, maybe that won't be the case for this, because R is not better optimized for machine learning matrices in which you train models, but it is for statistical data which have linear algebra equation. So R would outperform Julia and Python. So here we have taken random number of million data set here in line number 6, and then we calculated the mean, and here you could see or time taken for R is 0.1017 seconds. So we could here we could write those time down. So it takes 0.017 second for R. Now let's test for Julia. Let me change my code console. Now I have created the script in Julia and Python. Now it's time to benchmark those speed. So if we run on Python, if we take, let's see how much time it takes. It takes 0.07. So let us write those down. 0.07, and let's see what's the speed for Julia for the similar thing. And if we run this for Julia, we could see it's 0.04. And here I want to add few things, that I am running machine or this test on machine i5 1340F. So here's my 13th generation, I am F version, and I have 24 gigs of RAM. So if you are running on your machine, it would be taking some other times speed, because on the process the processor could handle it. So clearly here we could see the fastest one is R, then we have Julia, and then we have Python as expected. So for statistical analysis, R is very much optimized. So R, then we have Julia, and then we have Python. Now you have realized that how fast is R in statistical analysis. Now it's time to look at what we are going to learn in this course. So here is the mind map that we are going to follow. So in this course, we are typically going to have 5 lectures. In this, we are going to learn that first one we have already covered, why learn R versus Python Julia, and we have calculated the speed, statistical speed in terms of calculating algebraic mean, and we have found that R was way ahead in terms of comparison. As you can see, it was 0.17 as compared to 0.04 and 0.07 than Python. So it's almost taking 1/7 speed of Python and 1/4 of speed of Julia. And then we are going to learn about our basic data types. Then we are going to look at the condition statement and loops. Then we are going to look at some methods for visualizing our some plots we are going to visualize. And then we have project building 1, in which we are going to import some data and have some visualization plot on it. And similarly, we have project building 2. We are going to do similar thing with different data set and different visualization tools. With this, I hope you are very much excited about R. And with this, I am going to see you on to the next lecture. Thank you, everyone. Hello, everyone. Welcome to the R Masterclass Lecture 1. In today's lecture, we are going to look at what are the design principles used in R, what is the history of R language, how R language is different from other programming language in terms of design principles. We are going to look at why scientific researchers who do scientific calculation or have some data visualization prefer R against Python. We are going to look at what is the difference between R language and RStudio. Many of the students get confused between these. We are then going to look at how you could install R language and RStudio onto your machine. Then once that's done, we are going to look at your first programming language in R. We are going to look at how you could run your R directly from the interactive console. Then once that's done, we are going to look how you could run your R script file through RStudio. Once that's done, we are then going to discuss about one of the most challenging issue in the research, that is reproducibility crisis. So what does it mean is, if someone researcher wants to reproduce their research, they might not find the data values same as that in original papers. And we are then going to look at how R is able to resolve this challenge. With this, I'm very much excited at what are you going to learn in this lecture, and let's get started. So now let's look at the introduction to R. So R is highly optimized for statistical data. So what do I mean by statistical data? So if your model or data is in the form of AX1 plus BX2 or so on, then R is the way to go to train your model. R is also much more preferable for data visualization. Why? Because R has a library known as ggplot2, which makes your data visualization much more interactive. Now, so here we could look at that R is specially designed for data analysis and visualization. Next, why R is much preferred, because it's a language which is mostly complete. So you don't find any fundamental data types missing in R, any operation that is missing in R. It's whole balanced. It's very simple. It's not like Rust, so where you have a steep learning curve. It's easy. You could learn it very much easily, and you could master it very easily. Whether in Python, it's easy to learn, hard to master. That's not the case in the R. That's why R is one of the most standing ground in data analysis and data visualization because of its simplicity, clarity, and generality. So here you could see that our success was basically because of simplicity, clarity, and generality. It is highly extensible, so R supports object-oriented programming as well as functional programming. So if you use C++, you know what object-oriented programming is, basically following uh, OOPS concepts, that is polymorphism, inheritance. Then we have reusability, wherein function programming approaches that you consider function as a first level priority approach, in which you could pass function as a value. You could store the variable in functions. That's how functional programming approaches work. But you don't need to worry about those. What is a functional programming approach is because it's generally used in Haskell programming languages, and basically, and R supports both programming languages. So one other thing of uh, why R is most successful in analysis and data visualization, because it's of open source. There are a lot of community out there, and they have huge support of open source packages. So it's about 20k plus libraries open source. You could use any of them. So that's why here is the one of the meme that someone asked which programming has the most awesome and inclusive community of them. It's R. Let's look how R is in comparison with other programming languages such as C++, Fortran, and C. So the main reason why R stands out from other programming languages is because of its single implementation. So what do I mean by single implementation, and what do I mean by multiple implementation? So basically what single implementation means is, if you have used programming language such as C++, you might come across that to compile the programming language you need compiler. Yes, we need a compiler to compile language. So what does it have to do with multiple implementation? So here it comes. So to compile your program, we need a compiler, and basically for C++, the famous ones are GNU. This is open source program compiler for your. You might have seen this. To compile your program, you might be using GNU, or if you are in Microsoft Windows Studio, you might VS Studio already provides C++ compiler to compile your code. So here we have two compiler, and the implementation of these codes are separate. So basically they are optimized basically for their own purposes, these both compilers. So that's one of the reason that if the reproducibility crisis happen in research, because you might not get the same value. Similarly, this is for C, Pascal, Fortran in previous year, and which leads to leading in different values in researchable in your research, which leads to your reproducibility crisis, that you could not reproduce papers, leading to difference in behavior. So if you create a program in C++ and compile it with GNU, it basically converts into machine-able code that is understand by machine, which is bytecode. And similarly, this Visual Studio will also convert, but the implementation is separate. This bytecode is not might be similar to the or if you compiled it with Visual Studio C++, might be that some GNU code would be faster, or might be Visual Studio code would be faster. However, this is not the case for the R. It has single implementation, which ensures that your code is consistent across all machines. So that's why R is very popular among researchers, scientists, and you could easily reproduce your you could easily reproduce others' papers. Now you might be saying that, okay, what about Python? So Python stands here worse here, and you might be saying why I'm saying that, because in Python you have to handle a lot of things. If you think you created a program, let's say you created a program and you install a lot of libraries into it. So the one of the case you might do is you might create a requirement txt file, but that might not be the case because you might forgot some packages, and that could lead to the failure. And one of the other thing is some packages have dependency issues, like you have installed latest package, and whatever, suppose you the other student who's working on your code might having Python version separate, and then this caused a consistent issue, which is worse. So if you want to have uh, doing research in uh, doing research papers, or you doing any statistical model, uh, R is highly optimized, and you could easily reproduce scientific papers if the code is written in R. You have consistency across all the devices. Now let's look at the historical context of R. So basically, R language was developed by Bell Labs, and you might be wondering, I have heard thing about Bell Labs. So Bell Lab have also developed C language. So Bell Lab was Dennis Ritchie was the founder of C language. He founded this in Bell Labs. Particularly, R was also originated from uh, Bell Labs. Basically, it was a partial implementation of the S language. Basically, the context of S language was to be more of a GUI thing. So user could have graphical user interface where they could don't have to write too much code. Basically, it would be a graphical user interface to code out whole thing, and R was a partial implementation for that, and S was converted into S plus, which was a commercial program and was a closed source program, and R become open source program. It have 20k open package library. It have a lot of community out there. So if you have a problem, there are a lot of problem in Stack Overflow. They have whole community out there to help you out, and R has overtaken the S plus priority. Like now, let's look at some unique features that R provide. First, R is highly optimized for statistical analysis, and in the lecture one, you remember that R was 7 times faster than Python and 4 times faster than Julia, and it is creates some nice visualization plot which is interactive. So it's highly optimized for statistical analysis and data visualization. Next, what is the uh, next the feature that stands out in R is that you could add functionality in R such that you could call functions in other languages, such as your favorite one in Python or Java or in C++. So it's now have been much more interoperable. Now you could call functions in C, C++, and Photon. So it's make it stand out. Next, what the reason why I have one of the unique feature is that next, the reason that R stand out from other programming languages, it's because it contains 20,000 plus packages, and it have a CRAN, which basically handles all those, which is a comprehensive archive network, similarly like Node Package Manager and Pip for Python. Now to install R, you need to type R install, and here you could see the first website is the comprehensive R archive network, which creates the have the binaries for the R language. So I'm using R 64 bit machine. So I have already been redirected to Windows binary, which provides me the installer to install into it. So once you need to click it, I have already installed it, but so let's wait for this to complete. Once the R have been installed, you need to double click on 2, and it's just you need to follow OK and next steps. I've already installed R, so I won't be going through whole again, but you just need to click next, and R will be installed. So once it's installed, you need to search R, and here you could see the R console. So I have R version 4.4.1, and you can see here R is a free software. It doesn't come with any absolute warranty. You could type license for distribution detail. So if you need to get some distribution detail about license, you could type license. It shouldn't have any typo. Type here, it's your license. Let's have a GNU library, which is you could use under this. And yeah, now after that you have installed. Now let's look at your first hello world in our console. Now I'm very much excited that for your first program in our language. So the first thing in any language everyone types is hello world that they print. Now let's look how we could print this. So to print any statement, basically you just need to type print. Let me click here, clear the console. And if you are thinking how did I clear the console, the shortcut key is Control L. I repeat, so it would be something about Command L in Apple, but it's Control L in Windows and Linux system. So once you have installed our console, you need to type print double quotes hello world. Let's close the quote, close the bracket, and I type enter. And here you could see this is your hello world first console interaction. Now let's try to print any other thing. So let's try to do hello your name, hello Abhijeet. So one of the tasks in this course would be to print 3 statements of any type. Any statement, one could be your hello name, and other 2 you could literally do it by yourself. Any statement that you could do. Let's look what is RStudio is. Basically, RStudio is integrated development environment. Basically, where you could write your code in. You could connect it with Visual Studio, where you write your code. Basically, it's a user-friendly interface for writing your code and execute our code. It provides you a console. It provides editor tools where you could debug your variable, that what's value it's holding. It's also offers version control with Git, and it's open source, and it's widely used in R. So let's look how you could install RStudio. You need to go to Google and type install. You need to type RStudio desktop or RStudio install. You will get the first link that is based by Post it, and basically they have developed this RStudio IDE, and it's widely used. You need to click on download RStudio desktop for Windows, and basically we have already installed R, so you need to basically download the RStudio binary there. So it's about 262 MB. I have already downloaded it, and once it's downloaded, you could go into RStudio, which is you have to provide the next step. It's going to take 1.1 gig, so I already have space available for it. So next, and it takes some time to install. So I have already installed it. It's going to remove all the previous styles that were there and reinstall it. So now let's wait until it gets installed. Once it's get installed, you need to click RStudio, and here you have got the RStudio installed. So here we have already one script that from the lecture 1 that we remember for benchmarking it. So basically we will remove this script, and to remove clear the console, you know the shortcut that is Control L. It will clear all your consoles. So pressing Control L clears the consoles, and we are going just to look how you could print hello world from the R script file. So first you need to go to file, new file, and click on Control Shift N basically, and then let's save it. So let's save the file name as tutor1, and let's save in the desktop. And once it's saved, now we need to write some code. So first we are going to go with print hello world. So print hello world, and it also provide you a suggestion that what's the code need to be. It also provide you suggestion that what's the code needs to be there. So here you could see print x dash dash dash. Basically it's telling you could print anything. And once that's done, once you have wrote down your code, you need to enter Control Enter, and it will run your script file. Basically we have you could see we have enter print hello world, where you could see the hello world. Basically here you could see global environment. Basically currently it's empty, but what it does, it shows you what variable is storing the value. So basically now let's look if what happened in this global environment. So here we have the history, whatever we have run. Here we have history. So basically we in previous lecture we remember that we run the benchmarking. So here's the history for this, and then we have print hello world. Then in the environment tab we have what it does, it basically saves all the variable that what value it stores. So what do I mean by that? So let's have a demo. So now we assign a value to it x, and to assign it we have a operator and a dash. Basically it's very odd operator you might see, and just now let's assign an integer value to it, and let's press Control Enter, and you could see here in the global environment flag that x have saved 10 value. Now in the coming lectures we are going to go through more onto the data types, loops, condition, and then we are going to look how you could use ggplots and many such libraries for your data visualization. By this I hope you are very much excited, and by the end of this lecture I have 2 assignments for you to make a basic assignment operation, like assign 2 operation to x and y, and print hello world in the R console and through R script file. With this, I will see you on to the next lecture. Hello everyone, welcome to the R Masterclass lecture 3. In this lecture, we are going to look at the mathematical notation and string used in R language. So you might be wondering what mathematical notation we are going to look at. We are going to look at the addition, subtraction, multiplication, division. Then we are going to look at some complex equation which might contain sine, cosine, log, and then we are going to look at how you could do this onto the complex number and what does complex number means. It's basically of the form of a plus ib, where I is the imaginary number. And then we are going to look at how you could define vectors. Then we are going to look at how you could define characters, and then eventually move on to the strings. So what is the aim of this lecture? First aim of this lecture is you to get familiarized how you could use our command console. Next aim of the course is you to get understand how our language and grammar works in R. Basically, by the end of this lecture, you will be having a good grasp how you could read and write in R language. And last one, throughout the lecture, if you don't understand what mathematical equation is you don't need to worry about the mathematical equation. Basically, you need to understand how the code works in R and what is the diagram we are going to use in this lecture. Before moving on to the R console, we should have a mental map that how does our language runs into the machine. So basically we have our source code, it goes into the compiler and it checks for if there is any error or mistake, and if there's any error, the compiler will throw out the error that you have. This error, you might be missing some semicolon or some undefined language, or you might be having some issue on the code, it will throw error. If not, this will convert into the bytecode. Basically, machine understand 1 and 0, and this would be converted into that language, basically low level language, that is into the 1 and 0, which is understandable by machines, and then it could be easily interpreted by Windows or Linux or Mac OS. That's how a compiler or source code is converted into machine code when you compile the code. Now we have got the mental understanding that how does our compiler works. Now let's open our R console. So now let's look at how you could use mathematical notation in R console. So you have to start with the R console, not with the RStudio. Basically, R console is very beginner friendly if you want to start with. So basically, if you want to add two numbers, you need to have a plus operators, and you could add two numbers like 2 plus, get into the console, 2 plus 3, and you will get your answer. Similarly, you could do for subtraction, we could do 5 minus 6, and here we get our answer. We could do similarly for multiplication, 7 into 8, and you get your answer, and you could do division as well. So now we have got an idea how to use simple mathematical calculation. Now let's look at some complex mathematical equation which contains sine, cosine, tangent, log, can be used in our language. So basically we don't need to remember any other syntax. We need to know how to use help function. Basically we are humans and you don't need to learn remember all these commands. Basically you need to know how to use help. So if you need to know how to use sine, so just use help sine, and it will open the documentation where you could go through how to use sine, and below you have examples that how you could run this. So basically if you need a sine to run, so suppose if we want to get sine pi, and we could write sine pi, we could get the value of this. So the value accepted in this trigonometric function is accepted as radian. So suppose if you want to calculate for the degree, we remember in our maths class that if we need to convert any radian into degree, we just need to multiply that number by 2 pi by 360, and we will get our value in degree. So suppose we need to calculate for sine pi, suppose here we get the value for the sine pi, and suppose we need to calculate it for sine 45. So we multiplied it by sine 45 into 2 into pi, and we divided by 360 degree. So here we get the value for the 45 degree angle. So here is a task assignment for you. Basically you need to calculate the value of this equation. You could pause this video right now and try to calculate by yourself, and now we will try to calculate the value of this equation. So first let us look at the equation first. So we have 3 plus e to the power square, then divided by cos pi. So we have some exponential function, and to use an exponential function, let us clear our console first, and then we look at how you could use the exponential function. So to use exponential function, we could basically call help. We look through the documentation first, and we could look at here that we need to provide the parameter x to the exponential function to calculate it. Now we have got the idea how to use the exponential function. Now let us calculate the value. So we have 3 plus addition, and then we have exponential, which we provide we are doing the square, so square, and we then divide this whole thing by cos pi. So we know how to use cos. We just need to provide the value and then pi, and then we get the value minus 10.38906. Now let us clear our console. To clear our console, we remember that Control L is the shortcut key, and now we will look at some miscellaneous examples, such as if you need to calculate log. So currently log is if you calculate log 10, the base is e, so it will it's a natural log, so it will calculate the value of log to the base e. And if you need to calculate log to the base 10, you could calculate easily by log to the base 10 by 10. So here's the value should be the 1. And similarly, you could calculate exponent for value 2.7184. We could also calculate constant value 3.14. And here we could also look at some miscellaneous example of trigonometric function, such as cos pi. Here we get the value minus 1, because cos pi, that is 180, is minus 1. Here we could also look at tan, and here we get the value minus infinity. Here we get the value tan pi is the smallest negative integer, that is minus infinity, that the R language could hold. Now we will look at how you could use assign operator in R. So let us clear our console. So before looking at how you could assign the value to the variable, we should know what variable is. Basically, variables are used to store values. So where it is stored, basically in RAM, it is stored at random position. So here we could know that the variable 1 is stored at something 2000 position at the RAM. And basically we don't need to worry about where it is stored. Basically we need to know what variable are and what is used it for. And now we have understand what variable is and what variable store their value at. We could now look at how to define assign value to the variable. So first let's declare a variable name, let's say vec, and we assign value to it using a backward operator. We assign value to any variable using backward operator, and let's assign any integer value such as 2, and here if we print vec, and here we get the value. Now let's do some addition programming. So let's create another variable, let's say vector 2, and assign its value using a backward operator like 8, and then we do a addition operation. So vec plus vector 2, and you get the value 10. Similarly, you could do multiplication, you could do subtraction, and similarly you could do the division. You could use it with also like other trigonometric function we have learned about, and logarithmic function that we know. So let's say log vec, and we will get some value based on the natural log. Similarly, we could do for sine, and we get the value. Now we have learned about what variable is, how to use assign operator. Now let's look at some miscellaneous examples. So now let's look at some miscellaneous example that we are going to look at. First, we are going to look at how you could declare multiple variables at once. So let's say we want to declare vector 1, we could assign those value, backward operator, vector 2, similarly backward operator, vector 3, and we assign a value to this as a 0. So here, if you look at this expression in the R, you might get confused, but you don't need to. Basically, we are declaring variable 1, vector 1, vec 2, vec 3. We are assigning the value 0. So if you print vec 1, and close the parenthesis, you will get the value. Now, there are multiple ways that you can declare variables in R, but these are highly discouraged and should not be used in R language. And basically, for the knowledge, we are going to look at. So you could directly use assign operator to declare like assign the value. So if you want to do this, the R compiler will not throw error because it's accepted in the R language, but it is highly discouraged in R. We could also do one forward operator and vec. What do you think? Will it throw error? No, it's all okay with our compiler. Basically, we shouldn't use this. It's highly discouraged in R language. So now let's look vectors in R. Basically, vector is collection of similar type. So what does types mean here? Basically, the data types that are integer, float, double, string, character. And now let's look how does vectors are defined. So basically, in R, here is a vector defined and it contains the value. And basically, it's a collection of similar data types. As you can see here, that the data type is moving from 10 to 100, and the index, if you are coming from Python or any other language, you might seem very intimidated that here the index starts from 1 rather than from 0. So you should keep in mind that index in R starts from 1. So here you could see that index for 10, the value is stored in the array of index 1. So if we need to access this array and if we need to get this value, we need to go through the index 1. Similarly, if we need to get the value of 20, we need to get to the index 2. Similarly, for 3, we will get the value 30. Similarly, for 40, we need to access the value 4. So how you could create a vector in R? So now let's open our console and clear our console, and let's define a vector 1 and let's assign a backward operator. And to define the value in vector, there is a C method which is meant for concatenate the variable. So we will use 10, 20, 30 and enter. And if we print vec1, we'll get the value or vector. So what if we need to access the value 1? Access the value 10. So we know that the index starts from 1. So we'll go to the index 1 and here is our value. Let's do for 30 vector 3 is at position 3 and here vector 1 which we have defined and that the position is 3. So here we get the value. We could similarly do addition, subtraction in this vector. So let's declare another vector 2 and add some values 40, 50 and 60. We have added concatenated 3 variables. So here is a typo you need to look at. So you need to declare C, which is used to concatenate the integers. Now we have declared the value. You could print the value when you add. So let's say you need to add vector 1 plus vector 2. So let's see what will be the value would be. It's 50, 70, 90. So basically it's adding the vector based on the index. So 10 is added to 40, which is 50, and then 20 is added to 50, which is at index 2. Both are added, and then the value is 70. And similarly 30 plus 60 is 90. Now we could do similarly subtraction. We could similarly do multiplication, and so on. Now let's look at some miscellaneous examples. So let me open our console, and here let's clear our console. So first thing, what if we need to declare a variable with empty values? So how you could declare it? Basically you could declare it by vector and then backward operator, and then we have a method that is known as numeric, which will initialize the vector with value 0. So if we print vec, we'll get the value numeric value 0. And what if, let's say we have vector 1 of values, let's say 1, 2, 3. We have vector 2, backward operator, value 4, 5, 6. So here is a typo. We forget to concatenate at the C method. So vector 2, 4, 5, 6. Now, so how you could append those vector 1 and vector 2. So one method could be to use directly C method and concatenate vector 1 and vector 2, and here you could get the values. Other method could be used to, if you need a much more manual method, you could use append. And here you have the value appended from vector 1 to vector 2. So you might be wondering why to use append if we could use concatenate. Basically, append provides you much more ability to control the vectors. So here, if we look at the help for the append, you could look at that it accepts 3 parameters, that is x, that which the vector is, then the values, it could be the other vector, and the after which index we need to concatenate. So now let's look at the example. So suppose we need to append vector 1. So we called append, we need to append vector 1 with vector 2 after index is 2. After 2. So here we are appending the vector 1 with vector 2 after index 2. So here after index 2 we are appending the value of vector 2. So vector after vector 1, 1, 2, which we have the index 2, and then we append the vector 2, which is value 4, 5, 6, and then the rest of the value vector 1, that is 3. Okay, so suppose we need to calculate the value, we need to calculate the length of vector 1. So how you could calculate it? So the general method is you need to call length method, and you get the length. Suppose you need to declare vector of length 10 initialized with value 0. So how you could do that? To do that, you could easily use numeric. So numeric, and then we assign a length is equal to 10. So 10, and we get the array initialized with value 0 with length 10. Now let's look at how you could define complex number in R and do mathematical operation in R such as addition, subtraction and multiplication. So before we go on to R, basically we need to know what is a complex number. Basically a complex number is in the form of C is equal to A plus IB, where I is the complex imaginary number. And similarly, you could define another complex number C2 is equal to A1 plus I B1, and here if you need to make an addition, if you want to do like make an addition C1 plus C2, basically you could do A plus A1 and similarly I plus B plus B1. And similarly here you could do the subtraction. So subtraction would be C1 minus C2 would be A minus A1 minus I B minus B1. And now it's time to look at how you could do this in R. First we will open our terminal, clear our console. Let us define a variable. Let's declare our variable 1 with x method complex real is equal to 7, imaginary is equal to 10, and then we similarly define variable 2, and we could do the addition. Here we get the value. Now it's time to look at the strings and characters in R. So if you have come from C, C++ language, the way to define character is like you need to define a data type char and then variable name, and then in single quote you have to define the characters. So in single quote it could be A or any other characters, but the length of the word should be a 1. So basically you could define any word, but any character, and that character length should be the 1. And what if you define AB? The compiler will throw error in C, C++ language that will say that char cannot accept multiple characters. It could accept only one character, so the B needs to be removed from here, making it a single character. Now in R, here we don't have any problem such like that. We can define it in single quote or in multiple quote. So let's open our console. We remove the clear our console. We define a character ABC and character ABC in double quotes, and we so let's find character, and here we have a typo character 2, and then we compare character 1 compared to character 2. What would be the value? Will it return true or it will return false? Let's see. It will return true. As we could see, both values are same. Now let's see what if we need to get the get the number of characters in a strings. So for this we have a method called endChar, and in this we could give any string and it will return the number of character in that letter. Okay, now next task is, so suppose here let us define a variable temp and we assign a value to it to be hello world, and now we need to access only the world word. So now our task is to get the word world from the hello world string. So we know a method that is known as substring, and basically the first parameter it accepts as the string that we need to do the operation on, then it accepts the parameter start, which needs an index to where to start from. So we know the index starts from 1, 1, 2, 3, 4, 5, then space is 6 and world is 7. And from 7 to word 8th, 9th, L would be 10th and D would be the 10th. And then we substring the word. Basically this needs to be the 11th word to the 11th word. So 7th, 8th, 9th, 10th and D is 11th. Basically a typo. And here we get the word. So let us create a new variable. Let us say temp2, and here we assign the word today is Sunday. And now it's your task assignment to get the word today from the string temp2. How would you do this operation? So if you could, now you could pause this and try to attempt your own, and once you are done you could automatically resume the lecture. So to that we could use substring method and we pass the temp2 string. We start from 1 to the word stop. So we start from 1, then O would be second, D would be third, A would be fourth and Y would be the 5th. So till 5th, and we get the value today. So with this we could wrap up this lecture and I will see you on to the next lecture. Thank you everyone. Hello everyone, welcome to the R Masterclass series lecture 4. Today we are going to look at list, data frames and plots. So this is one of the most important lecture in whole R Masterclass series. Why? Because you are going to learn list, data frame and how to make plots that you are going to use throughout your whole data science career. So what is the aim of this lecture? So first, we know that the dataset organization is key to efficient data, and then it's eventually a good way you could do the data analysis on it. So to do the dataset organization, R provides some tools such as lists, such as data frames. So in this lecture, we are going to look at what is lists are, what our data frames are, and then we know we already looked at lecture 3 what is vector R. So then we are going to compare list versus vector, which one to use. And then the last lecture we are going to look at how you could do plots in R. With this, let's get started. Now it's time to look at what is list in R. So basically list in R is basically a collection of heterogeneous data types. So what do I mean of heterogeneous data types? Basically collection of different data types. So suppose here is your list, and here in this one of our data type could be a string in the index 1. Here it could be string. Similarly, here in other index it could be a integer. It could be a In other index it could be a float, and in other it could be a double. Whereas in vector, this needs to be a homogeneous member, means the collection of same data type. So if we define a vector here, then the if we define the vector here, then the index 1 here should be integer, let's say. Then the other index should also be a integer. It should be a homogeneous. So now we have idea, okay, what vector is, what list is. So now it's time to open our console. In lecture 3, we remember that vector is a collection of a homogeneous data types, means it could contain only a single data types element. And now let's define our vector with backward operators and assign a string data type. So let's say hello, and we close our double quote. Now our second index is integer that we have defined 1, and let's say one more index, let's say be a 3. Now you could think and pause this video and think about it. When I press enter, will it throw an error or not? Now here's the answer to it. It won't throw an error. Why? Because if we print, let's print our vector, here you could see that all the elements in the vector have been converted into string. Now to check whether vector vec contains any string or not, we have a method known as is.character, and it checks all the members that are inside the vec is whether in a string or not. So that method is known as is.character, and we pass vec, and here you could see that we know that whole data type inside vec is a string. And to iterate one more again, like what happening here is basically the vector that we have defined is again converted into string. So if we define, let's say vec and c, and here we define 1, 2, and our third data element is hello, will, or let us correct the variable name, will this throw an error or not? Yes, it will not throw an error. So now if we print our vector 1, you could see that whole thing have been converted into string. So once what our compiler does is basically see, okay, there have been a string is defined, let us define all the other element as string. So here we define the integer which is converted into string. Similarly 3 is also converted into string, and similarly here our compiler sees, okay, 3 is an hello is an index 3, that is hello is a string, we need to define other data type of element to be string. Now we have got an idea, okay, how this works in vector. Now it's time to look at list. Now it's time to look at how you could define list in R. So to define list in R, basically we need to call list method, and a list method accepts any data parameters. So whatever you define will be stored in column, and the value will be stored in rows. So suppose we create list with backward operator, and here we define our list, which is A, which is a collection of, let's say, 3 integers, 1, 2, 1, 2, and 3, and we call this method. So what it will do is it will create a column with C, name C, and the values assigned to it in row 1 would be 1, 2, and 3. Now let's look how you could do in R console. So let us see, let us create a variable list container, and we define list which is x. Here x would be our column, and we define x is a collection of integers 1, 2, 3. Now we define y, which is collection of string, and it is valid in list. We know that because list is a collection of heterogeneous data types, so it could accept list, so it could accept list, also it could accept integer, it could accept itself, that is we know list, it could accept vector, it could accept integer, it could accept float, and it could also accept operators, it could also accept functions. Basically it could accept any parameter to it. So here we define ABC, and let's say we define Z, which is our column, and let us assign the values would be our boolean operators, that is true or false. Now we close our brackets, and it's true is not fine, so basically there is a typo. It's all needs to be a cap. Then here a list have been defined. So now let's see how this would look onto the row column. So if we look at the diagram of how list container or variable look like, it will look like this. So basically we have defined here in our R console, if we open it, and we see that our first column is X with row members 1, 2, 3, and Y was ABC and Z was a Boolean operation, that is true or false. So here what our console would, our compiler would do is it creates a X column and have rows as its value. So 1, 2, 3 would be the rows value of column X, Y, Z. Similarly, it will create a Y column and values ABC string as the value assigned to it, and similarly it will create a Z column and values assigned to it would be true or false. So in similarly how in vectors we assign was able to get the values from the list, similarly we could get the values from the uh, similarly how in vector we were able to get the values using square brackets, in vector we could similarly get the values in list using square brackets. So here let's open our console and let's clear our console, and we know the shortcut of this, that is Control L. Now to get let's print our list vector list container. Here we get the values. So to get the value of X column, we could use square brackets list container, and then we pass X to the square brackets, sorry, and this in double quotes we pass this, and we get the value 1, 2, 3. Let's clear our console, and now you could do the same for Y and Z. Let's look out how you could do this. List container, and then we pass in double quote Y, we get the value that we have stored, which is string, and we get the value ABC list container, and then we pass the value Z, then we get the value true or false. And here if you look that in list container it's a string, and in list container Z it's a boolean, and in list container X it's a integer data types. So you could see that how it's able to store heterogeneous data types. Now I have a task for you. So if you need to define a empty list, how you could define? Let's see how you could define in list. So before we look into the list, and lecture 3, we remember that using numerical method, we get the empty list. So let's call C, let's say vector, and then we assign a backward operator numeric. And then we define, we print vec, we get the empty variable vector. Here we could see empty. So to get the list, empty list, we just call a list method without providing any parameter to it, and once we print list 1, then we get the empty list. Now let's print list container and see what element it contains. So list container, and okay, so we have a typo, we remove, or at least we define our list container, and you could see list container contains the elements we defined earlier, that X column contains 1, 2, 3 integer elements, Y contains string ABC, Z contains boolean true or false. Now let's see. Now what would happen? Now what would happen if I define list container and I want to access the element indices from -1. So in here we have defined our list container, and say, let's say list, and we call list -1. So what would be the output of this following command? So here there's just a typo, so it should be list 1. So once we press enter, we could see that the indices of 1 have been removed from the list. Basically in R, if you provide a minus indices, it just removes the row column of that index. So here we have provided -1, it removes the 1 index 1 index. And for this is not a safer method, because it could take any element and also just remove it from the index. What I mean is, suppose here is our list defined, let's say list is defined as 1, 2, 3, and we say let's remove the index -1, and it removes it, and our new index would be 2, 3. And here, what if you passed this index -5? Basically it will go to the minus index of the list 5 index, which does not exist, and try to remove that element. And basically that what makes this command unsafe. To safely remove indices from list, we need to use null method. And basically before we see how to use null method, we need to see what does double square bracket means. So what if I call list 1 and we call double square bracket, let's pass the called X that we have removed, so let's call Y that we have defined and call it. So here it gives the value of that row column. So if we call Z, it will give the value of that row. So we know how to use double square bracket to get the elements. Now let us redefine our list 1 and let's print our list 1. So here is our list 1, and now we need to safely remove the index 1, 1, 2, 3 from it. Let us call list 1. We call the X column, and we say that now your value is null. And now if we print list 1, we get the value hello 2, which is safely we have removed the values from the list. Now it's time to look at some other methods that we are going to look at. Is append and nested list. So let us define our list 1. Earlier we have defined list 1. Let us define our list 2, which is a collection of list. Let's say A is equal to collection of C, and we defined our strings. This is the collection of strings. So let's say this is the collection of string, and now we define one more element. Let us say B, which is collection of element integers. So suppose let it be a integer, and then we call this method. Now let's look how you could make an append. So let us define list 3. We know to make a method append. We call append list 1. Then we call list 2, and then we need to make this appendment after indice 2. So after indice 2, and now if we print list 3, could you guess what would happen? So after indice 2 from the list 1, that is x, y, the concatenation of list 2 would happen, and then the remaining list of 1 would be shown. So let's see what is happening. So here the list 1 index 1 is shown, then 2 is shown, and then after 2 we say to append the list 2. So here we get the A, B, C, D, E, F, that is index 1, then 4, 5, 6 of the column B is added, and then the remaining elements, that is Z, true or false, is shown. Now we have got an idea, okay, how to append the list. Let's say what would happen if we call list 3, we want to append after list 3, and we clear our console first and print list 3. Yes, now it's appending after indice 3. So first concatenation of first 3 element is done, 1, 2, 3, and then no other element is remaining. So after indice 3, the elements of list 2 is shown. Now what if I say you to do this with concatenation method with the C? So basically you could do similarly this method called concatenation, and it will concat list 1 versus list 2. And if you print list 3, here you could see the first index of list 1, list 2, list 3, and then the remaining element of list 3 is shown. Now let us clear our console. Now it's time to learn about nested list. Basically, nested list is a collection of list, or it could be a collection of list and vector. Now let us define, or let's see our list. So let us open our R console, and here we define our list 1, which is we define the backward operator list. Then we define X, which is collection of integers. Then Y, let be a string. C, and then Z is a collection of boolean. And now we define our list 2. Basically similarly to list 1, list 2 is a list collection of, let's say, integer from 4 to 6. Let it be string, and Z it be true or false booleans. Now let us define our list 3, which is a nested list, which is basically a simple collection of list 1 and list 2. Now if we print here list 3, we get our nested list. As you can see here, nested list contains the elements of list 1 and list 2. We could also add vectors in nested list. So let us declare or vector 1, which is basically a collection of integers 1, 2, 3. And now let us define our list 4, which is collection of nested list and vectors. Backward operator C, and then we define list. We need to concatenate list 1, list 2, and then vector 1. So here is just a typo. We need to fix. And now if we print list 4, we get the nested list which contains list and vectors. Now we have got whole idea depth of list. Now it's time to learn about data frame. Now it's time to learn about one of the most important term, that is data frame. And data frame is basically used in data analysis, data manipulation. We will be using heavily this in plotting. And now we need to know what is data frame is. Basically data frame and list are similar. The only thing that data frame differs from list is that data frame have the length of each member in data frame is similarly. So the column here, the length of this data member is similarly to the other column and similarly to the other column, which is not necessarily true for the list. Here the X data member have length 3. It's not necessarily for Y to have the length member 3, but it's necessary that data member here, let's suppose this is X and this is Y, the both have the lengths to be 1, 2, 3, 4 and 5. So the length should be 5, and so similarly the data member of Y should be having length 5. Similarly Z, if we define, should have data member length 5. Now it's time to look how you could define data frame in R. Now let's open our R console and define data frame. And the general rule in to define data frame, the naming convention is df. So let us define our data frame, and it's defined by data.frame. We define the data member, let's say car, and let's say it's having values. Let's say Tata, let's say Ford, and let's say it's Nissan. Let's add Suzuki, and here we have our data member of length 4. Let's close our bracket, and now let us define other data member, that is speed, and let's say the speed is for Tata is, let's say, any arbitrary number, let's say 100. For Ford is, let's say 90. For Nissan, let's say it's 95. Let's for Suzuki, it's let's say 97. Now we define one more arbitrary, let's say quality. We gave the marks out of arbitrary number 5. Let's say for Tata we get 5. For Ford, Nissan, Suzuki we gave, let's say 1, 2, and let's say for Suzuki we give 3. Now let's close our operator, close our brackets, and here we have an error. Basically we have one typo here, and if we so here before we type enter we have a typo. We did not add concatenate in speed and in quality. Let's add concatenate the vectors, and now let's enter it, and now let's print our data frame. Here we get the data frame car, speed, quality. We have Tata, Ford and Nissan, Suzuki, and we have defined their speed, quality and respective arbitrary numbers to it. Now let's check how to get the row names of from the data frame. So to get the row names, we type select row names, pass data frame, we get the row names, that is 1 2 3 4 that we have rows, and to get the column names, that is car, speed, quality, we type call names, then we provide the data frame value, we get the column names. Now as I told you, data frame is a special condition of list in which all the data members have equal length. So if is we check if data dot frame, here we get so so here if we check that is data frame is a data frame or not, df is data frame or not, it's true. What if I do this? Let's say is dot list data frame, what would it return? Will it return true or will it return false? So I hope you have confirmed your answer. Now let's press enter. It will return true. Basically, we know that data frame is a special condition of list. Now let's say if you want to initialize a data frame 1 with value 0, how you could do it? We look at that in vector you could do it by numeric, in list you could do it by list, and in data frame it's similar, just say data dot frame. So df1 we define the data frame method, just initialize it, and we get the data frame with value 0. Now if someone asks you, okay, if I want to add a data frame at the end, how you could do it? So we could easily do it. Let's say data frame, we define another value, let's say price, and here we assign the value to it. So let's say price value, and we need to define the 4 values, that is for Tata, Ford and Nissan. So we concatenate the values, let's say 1000, 1000, 2000 and 3000. And now if we print data frame, basically we get the price data frame 2. So let me go down, and here we get the price data frame. Now if you say, okay, we need to define also the data frame, but it should be at the front. So basically it should be before the car. So how you could do that? So basically for this we have a cbind method. So to define the data frame in the front of car, we could do this, a method called cbind, and then we create the column that we need to add. So let us say we need to add, let's say door column, that how many car, each car have doors in it. So let's say doors, and it's a collection of string integer vector, that is say, let's say 4 2 4, and let's say Suzuki have 4. Then we pass the data frame that we need to cbind with it, and we then pass the data frame that we need to attach to it. So here we get the door data frame attached in front of bar. Now let's look at one more method that is known as subsets. So let's say here is our, let us print out df2, which is data frame 2 that have door, car, speed, quality and price data frames, and price column, sorry. And then what if we need to get the data which have quality greater than 2. So let's say data frame 2, and in this we need to get the subset of data frame 2 in which quality is greater than 2, and here we get the subset of from the data frame 2. Now we have learned how you could do multiple operation in data frames, how you could do multiple operation in list. Now let us look at how you could do some plotting in R. Now it's time to look at what plot is. Basically, plot is a visual representation of a data, and here we are just going to plot the value in x and y. So to use plot in R, we have basically a method known as plot, and let's say to define in console, we first check what our data frame 2 is, and let's say we need to plot speed versus quality. Let's say so we call plot, and this the first method, the first parameter would be your x. So here we call speed, and to access the column speed, we remember we need double square brackets speed. We close the double quote, double square bracket. Here we have typo data frame 2 we need to access from, and we need to access quality, close the brackets, and then we enter. We get the plot for speed versus quality, and here we could see some have speed 92, 95, 94, 91, and then we have the max at 100. Now, so with this, we could wrap up our lecture. We have learned how to plot a simple plot in R. We have looked at data frames, we have looked at vectors, we have looked at list. Now in coming lecture, we are going to look at some more complex plots and how you could plot them. And with this, I will see you on to the next lecture. Hey everyone, welcome to the R lecture 5. In this lecture, we are going to look at how you could define your own scripts. Then we are going to look at how you could define condition statement. Then we are going to move on to the loops. We are going to look at what are for loops, while loops, repeat loops in R. And in last, we are going to look at functions and how you could define your own function. So what is the aim of this chapter? First, aim of this chapter is to introduce that what is script, and then we are going to move on from R console to the RStudios. And next we are going to look at some condition statement, how you could use if else block, switch statement in R. And next, then we are going to look at how you could implement loops in R. And in last, we are going to look at how you could create functions in R. So with this, let's get started. So what is R script? Basically, R script is a simple text file. Instead of running line by line command, here you could execute bunch of a code at once. So why to use R script? Basically, you could save your code in R script and you could reuse your code and edit out, and you could also have reproducibility. So if you want to run your code again, you don't want to write it again in R console. So this is one of the most big advantage in R console. Other advantages like you could have error handling. So in R console you could error handle. So if suppose if you want to check, okay, if some statement is null, do this, else do this. But in R console you won't able to do that error handling. Then you could have reproducibility, documentation. You could document your code. Okay, this part of this code is doing this, and next part is that you could run your code again and again. So now let's look in depth how R console is different from RStudio. So here I have opened my R console, and let us run few commands. Let's say print hello world. Here I have run, let's run few, assign x is equal to 10, let's suppose, then y, let's assign it to 10, then we add these two numbers. So here you could see that I am running the commands line by line and it's compiling line by line. And here I couldn't save this R console. If I need to save it, it would be saved in R script where all the commands would be saved. Here one more issue is that if I need to document this code like what I am doing, I can't document this because if I add comment here, you could see that it is giving me error. Now let's look. Now let us look in RStudio how we could resolve this. So here I have opened my RStudio, and basically to create a new file you could simply use shortcut key Control Shift N and it will create a new file. So let us type Control Shift N. Let us save it. Tutorial 1 dash, let's see. And here we have saved our file, and now let us run bunch of commands. Let's say print hello world. Let's assign x equal 10, y equal 20. Then let's say we need to multiply this, and let's say x into y, and we need to print this value. So print the xy. And now let us run our code. To run our code, the simple shortcut is Control Shift L, and it Control Shift. So to run our code, the simple shortcut is Control Shift Enter, and once you press it, you could see the whole code have been compiled. So in this, you could see that the print xy is 200. Then here, in first, it compiled the first statement. Okay, print hello world, and it outputted hello world. Then the assigned value x is taken, y values 20 is taken, and the value x into y have been printed. So if you might be wondering what is here in the environment tab, you could see for the debug purposes we need to know, okay, what value does x holds, what value does y holds, and the RStudio provide a friendly interface to see, okay, we don't need to print many times to like print x, print y to get the values. Here in the environment tab, I know, okay, x is holding the value 10, y is value holding the value 20. Here in the history, I could have, okay, what are the commands I have run previously. I could see here in the connection tab, and the connection tab shows you what are the database have been connected. So R supports various data types, so you could connect it to with SQL, you could connect it with MySQL, and any SQL language. You could also connect it with big data such as Apache, Hadoop. So from this you could get whole data and you could do data analysis on this, and it's a very friendly tab. From here you could see, okay, which database is already available and you could easily connect it with. And next we have a tutorial tab where it provides you documentation and some packages documentation, so you could look on to. Now let us look at how does condition. Now let us look at how does condition statement work. Basically, we have a program, and in this, when the program runs, it have a condition. So, for example, the condition could be in the weather. Like if it's raining, suppose if it's raining, this could be the condition. So, if it's raining, it's the condition, and if the condition is true, carry the umbrella. Else, run the other block statement, don't carry the umbrella. Don't carry umbrella. So basically we got the idea how does it works. We have the condition. If the condition is true, run this statement 1, else run the statement 2, and we have the block gets end. And now it's time to look at the type of condition statement. Now it's time to look at the type of condition statement that R provides. So first one is if else statement. Then R provides us nested if else, and then the switch statement. Now let us look in depth how you could use this. So now it's time to learn about if else statement. So basically in if else statement, there first we have a condition, and if the condition is true, the if block statement is run. If the condition is not true, the else block statement is run. So how you could do this in R? So first you need to open the RStudio, and here, we could remove this. We could clear our console. and let's say is rain, and here we could assign the value to be true. Let's say it's raining true, and then we have if block statement. We have here the condition. So here we have the condition, and we'll check the condition if it's true or not. So if is rain equal to true, check operator, and then we'll see if it's raining. So we could print it's raining, carry the umbrella. So here we have the else block running, and here we don't we need to print, we could print don't carry the umbrella. So let us save it, let us run it. We know the command to run it, Control Shift Enter. It's raining, carry the umbrella. If we do it, make it false, what will happen? So here the structural flow of the program would be, so the is rain will check is it equal to true, and this is false, is not equal to true, so it will run the else block statement, and we get the output don't carry the umbrella. There could be some typo. You might do something like this in else in new line. This would be a error in R basically. So if you run it, you will get this error that is unexpected else. So basically you need to indentate it perfectly with else block. So after if space else should be there right after the if block. And now let us run it, and here you won't have any error. Now here's a task assignment for you. You need to create a if else block statement to check whether students have passed or not. The condition here is the mark should be greater than 50. So now let us see how you could code this. First we need if state a marks variable, and let us assign value 50 to it. We check if marks greater than 50, we print student have passed, else we print student did not pass. Save it, enter it, and we know that student did not pass because this value should be greater than 50, and here we are using 50, so it's not equal to, so the value is here should be n plus 1. So if it's 51, this should work. Can have passed, or if you want to make it for 50, you need to make it add one more operator that is equal to, let's check the operator is the number are like till 50. If you remove this operator equal to operator, it have to check with the n plus 1. So 50 is not equal to like greater than 50. It should be one more number, so that is n plus 1. Now we will save this. Now let us look at how you could use nested if else. And before that, we need to know what is nested if else. So in if else statement we look at, we have simple one if else, but in nested if else we have multiple if else statements. So basically we have a condition 1, if it's true we run if block, else we run else block statement. Similarly in the if block we could have other conditions, and based on that we could run if block statement, and similarly the else block statement. And similarly in else we could have other if else statement that we could run based on the true or false. We could run the blocks based on this. So this is known as nested if else. And now let us run a program on it. Now here's a question for you. In if else block we looked at a question that we need to program such a program that takes some marks and tells us if student is passed or not. Now here we have a modified version of that. We take the marks, and based on the marks we check okay if student is passed or not, and then we grade the student based on the marks. And here is the grading system. If student is lying between 80 to 100, we should grade A, 60 to 80 to B, and 50 to 60 C. Now let us clear first our console, and now let us first have a variable name marks, and let us assign a variable score arbitrary number 89, and first we will check if student is passing or failing. So we know from our previous code that if it's greater than 50, then the student has been passed, else student is failed. Student did not pass. Now in the if block, when it's true, then when the student score greater than marks 50, we need to grade it. How we could grade it? We read about nested if else. We just need to check the condition. If marks is less than 100 and marks is greater equal to 80, we need to print grade A, else if marks, then we need to do it similarly for other conditions 60 to 80. If it's less than 80 and marks is greater equal to 60, we need to print B. And if marks is third condition, if marks is in between 50 to 60, we need to grade it C. So here is the typo. We need to have one and then we print grade C. And in the else block, we have print. Suppose if student score 101 marks, supposedly this is not a correct score, so we need to handle that case too. Print not a correct score, and then we save it and then we run it. So Ctrl Shift Enter, we get the marks 89. And suppose what if we scored 101, in which block it will go? Not a correct score. What if we score 49? Yeah, student did not pass. And what if we scored 58? Grade C. So it's working fine, perfectly, and we saw that in here that how to use nested if else. Now it's time to learn about switch statement. Now it's time to look at the switch statement. Basically, in switch statement we have expression and then we have cases. Basically, we match these cases with the statement. So if we have a case 1 and this we have a condition, okay, so we check the condition. If it's true, then run this block. If this condition is true for case 2, run this block. If this condition is true for case 3 block, run this condition. And if none of the cases matches, we have a default block which runs. So how will this look in if else statement? So basically in if else it will look like this. If, and we will have some condition, and then we have another condition to check. If that doesn't match this, we have else if, another condition, and similarly on we have other conditions similarly, and then in the last we have else block. Now let's look at the coding, how we could do this. So let us clear this, remove this, and now let us do a one program. In this we will have an integer, and based on the integer we return the day. And let us say we have day of week as integer. We define it to be, let's say, 3, and then we have a switch statement, switch, and basically here we have day of action as a syntax, day of week, sorry, to be precise, and then here is the case and action which we need to check. If it's 1, we return Monday, then comma. If it's 2, we return Tuesday. If it's 3, we return Wednesday. And if it's 4, we return Thursday. If it's 5, we return Friday. And similarly for others. Seventh, we have Sunday. And then in the last we have a default statement. If none of these week matches, suppose user enter 10, in that case what we will do, we will have an valid day of the week, and just we will show that statement. Now let us run this. Control Shift Enter, the shortcut key, and here we have the error that says unexpected equal to. Basically we need to double quote this. And now let us enter, and then we got our solution Wednesday. Let's say we run 5th, we get Friday, and if we run 8th, we will get invalid day of the week. Now we have looked at the if else statement, then we have looked at if else if, and then we have looked onto the nested if else, then we looked at switch statement. Now, if someone asks you whether to use switch statement or whether to use if else statement, a general thumb rule is to use switch statement, and the reason here is because switch statement are more readable, and switch statement are generally fast compared to if else. If you have long if else coding out there, like it's getting big, then you should definitely switch out to switch statement. Now it's time to look at what is iteration is. Basically in iteration we have a condition, and then if the condition gets true, it will run some block of statement code, and then it will rerun this condition and check, okay, if this condition is true, it will rerun, and this will iterate until the condition gets false. So in R, basically we have 3 iteration types, and basically one we have for loop, then we have while loop, and next we have repeat loop. Now let's look in detail how this loop statement works. Now it's time to look at the for loops. Basically in for loops, it's the most commonly used loops in R, and basically if you want to iterate over a vector or a sequence, for loop could do this job. So basically now let's open our RStudio. So I have already opened it, and let us create a new file, and we know the shortcut Control Shift N, and let us save it first with loops, and let us create a vector. Let us create a vector like numbers and assign value to it. Let's say 1, 2, 3, 4, 5, and then basically for num, which will iterate in the number, and then we print num. So basically we save it, and let's run it, and here we get the value. Now let us look at one more example. Suppose we need to calculate the square. So how we could do that for each of this? We know that we need to calculate square. So basically exponential operator and then square. Let us save it and then enter, and we get the values of the square. Now here's a sample challenge for you. Here I have created a list which contains header, hello world, ABC, such as, and it contains string, vectors and booleans. So here's a challenge for you. You need to iterate through this list using for loop. So you could pause this video and try to attempt by yourself. And now let's see the solution. First we will create a for loop, and let us name it, let's say I in list iterate, and we just print the I. Remove the double quote typo, Control S, we clear the console, and then we execute the code. Here you could simply see the iteration through the list. Now it's time to look at the how you could use while loops. Now it's time to look at what is while loop. So basically while loop is more flexible than for loop. Basically you have a condition in here, just similar to like if statement, and it's run until the condition gets false. So here we have a condition, it runs and runs until the condition gets false. So here the end of the loop. So why while loop is more flexible than for loop? So basically for loops you could only iterate through lists, vectors or numbers sequence. So you have, and while basically in while loops you have a condition and you have much more granularity. So now it's time to look at what is while loops. So basically while loops is much more flexible than for loops. Why? Because in for loops you could only iterate through list, vector or numbers, while loop have a logical operation and then you could iterate over it. And how does while loop works? It is similar to like if statement, where we have a condition and we iterate to the block. In this while loop we have different rate. It will iterate through while the whole statement until the statement gets false. So what happening is we have initialize our code, we run the code, it checks the condition and will say okay if it's running or not. If it's running, then the code inside it will run the block statement, and then it will check again if the condition is true or not false. If the condition is true, it will run again, and this loop will continue. So you need to make sure that this loop gets false eventually. If not, it will go into the infinite loop, and basically compiler are smart enough to handle those infinite loops and will throw an error basically. And then if not, we have the once the condition gets false, we get the end of the loop and we run the other statement. So now let us look at how you could run a while loop. So let us open our console, clear our code, we clear our console, and now let us create a program to print numbers till 1 to 50. So let us define our integer a 10, and now we need to iterate till 50. So we'll iterate till 50. So here, let me code it out. We print it. So what we are doing? So basically we initialized a, which will let us initialize it from one number, and it will go through this condition. It will check, okay, a is less than 50, and then the condition is true. Yes, 1 is less than 50. It will print a, and then we need to increase the value of a by 1. So a value have been increased by 1. Now let us save this and then run our code. Here you could see the value have been printed from 1 to 50. Now here's the sample challenge for you. What you need to do is that you are provided with a number, and then you need to return the number that are the smallest power of 2, that is greater than or equal to the input number. What do I mean by that? So for example, you have a number and its value is, suppose we assign the value to it to be 20. Then what you need to do is you need to print the number that are smaller or equal to 20 in the power of 2. So what we need to return? We need to return 0, 2, 4, 8, 16, and we cannot go to 32 because 32 is greater than 20. So in the previous for example, we have already looked onto the square of for a number. Now it's a little bit condition check. I hope you could try to solve it. So you could stop this video now and try to attempt by yourself, else we could start with it. So how will we solve this? We need two variables, basically number and let's say our arbitrary integer I, in which we will compare it against the number. So 2 to the power I, if it's less than the number, then we will print it. One edge condition, we need to look out for the 0. So basically 0 would be always be there in the solution because the number, let's say it's 20, so 0 would always be there. For example 1, 0 would always be there. So that's the one edge condition that we need to take care of, that 0 would always be there. So we need to declare first variable 2, 20, which we assign the value to it, integer arbitrary number variable I, and we assign value to it to be 1. So first what we'll need to do is we need to declare while loop. We'll check the condition if I is less than 2 to the power I is less than number, will print number. 2 to the power I, because we need to get the exponential number that are less than number, and then we increase the value of I by 1. Also, first we also need to print 0. Why? Because this is the edge condition that the answer would be always contain a 0 element. So we could add a comment, edge condition that the answer or output would always contain the 0. So here we have first printed 0 and then we check the value. So we'll save it and shift enter. So first we get the 0 value, then we get our program gets run, and then the output are 2, 4, 8, 16. So what if here is one more mistake that I have add that we need to have a equal to operator. So what if the number is equal to the 2 to the power exponential? It should contain it. So that's why. So if we add 32, let's see what are the output are. We get 0, 2, 4, 8, 16, 32, and hence this runs. We could also add this print statement directly into the while loop. We could say if I is equal to 1, that means that is 1. So for the 0 condition, it could also print the 0. So we will get this value in much more row wise rather than 0, then the program runs and then we get the output. So let's look how does the output look. So here we get the value 0, 2, 4, 8, 16, 32. Now it's time to look at how does repeat block work. So basically in repeat block, it will iterate over the statement again and again until it finds the break method. So repeat block is much more flexible than other blocks such as while loops or for loops. Why? Because you could easily control the iteration. So you just need to add the break statement and it will stop running the continuing the iteration of the block. And you could add this multiple times. So if you need to have this statement block repeat, you could add multiple break statement in those also. So let us see the demo to get much more understanding that how does repeat block works. So now we need to solve this question again, but now using a repeat block. So we already know that we need to have two variables. One is number variable and one is I, which is used for exponential. So we define those two number first. So first number, let us say 20, I, and we already know it would start from 1, and then we define our repeat block. Then in the repeat block, it doesn't have a condition, so it directly have curly braces, and we then have create a condition if 2 to the power I is greater equal to number, we need to stop. So we need to know that we will call break method. Else also we need to print it. So print the 2 to the power I, and then we increase the increment I by 1. And also we remember that we need to handle its condition, that is for 0. So if I equal to 1, save it, let us clear our console and run. So here we get our value. You could play around with any other number, let us say 30, and let us save it, run it, we get the same value. Let us say 32. Now it should contain those value. So here for you, as you could see, that 32 number is not included because in this the condition gets true. So to solve this, we just need to remove the equal to operator and it will solve. And then we get the answer to 32. Now it's time to look onto the functions. So now it's time to look at what is function in R. So basically a function is a block of code and it runs when it is called. So basically here we have a block of code and it will run when this function will be called. Now let us see how you could do this in RStudio. Let us open our code, and let us define our function. Let us name to be function print, that prints whatever we call it. So we have function that takes a value n, basically it's print n, and here we call the function print and we provide the value hello world. Before we run it, let us see what's happening. So basically we have this function print, and its function print takes an argument n, and basically it prints that argument, and we providing the argument to be string, which is hello world, and it will print it. So we will run it, Control Shift Enter, and here we get the hello world. This is a simple program. Now let us take a one step notch and have a exercise for it. So could you create a program to check whether a number is prime or not? You could pause this video now and try to attempt by yourself, else let's get started. So now let us see how you could solve this. So basically we need a algorithm to get the prime number. So we know that a prime number is a number that is not divisible by any other number other than itself. So we have a number, right? So we need to check till in sequence till this number, is it prime or not. So what I mean by that, if its number is 17, so we need to go from the sequence from number 2 to 16 to check whether the number is divisible or not. Okay, so we have got the idea. Okay, we need to iterate through the number until the number n minus 1. But if we do this, like we do 17 by 2, 17 by 3 till 17 by 16, this is a long process, like it will take some time. A better method could be, we could iterate through the number half, like, because after this number we know that it is not going to be get divisible. So but what I mean by that is 7, we know that after 9 it is the twice of 9 would be 18, and it will be, we know that it won't divide this number. So until 8 we could iterate through it. So this is one method that we could iterate to number by 2, which will half the process of the numeric calculation. One more method could be is to take, instead of taking number by 2, we could iterate by the square root. So we know that it won't be divisible. So for like 17, the number could be around 4.3. So till 2 to 4 we could iterate it and we get the number, is it prime or not. So now let us look at one more edge case that I need to talk about. Is we need to take care of one, that one is if the number is less than 1. If a number is less than 1, then the number is not prime. Basically 0, 1 is not prime. So now let us see how you could code this out. So basically we need a function is prime that will return Boolean member, that is either it's true that the number is prime or false that the number is not prime. So we will declare a function, we take a argument n to check whether this number is prime or not. We first check the edge condition. So if less than equal to 1, we need to return false. Basically the number is not prime. Once if it's bigger than 1, we need to check if it's divisible by any other number or not. So we will iterate to the square root from till of the number from 2. So what I mean is we declare I integer, we iterate from 2 till the square root of the number. So we check if n modular I, basically we check if we have any divisibility. If we have, we need to return false, that this number is divisible. Basically, modular returns the remainder, and if the remainder is 0, we know that the number is divisible. If that's not the case, then we know that the number is prime. We return the number prime. So let us run it. Before we need to call this function, let us check for this prime for, let us say, arbitrary number this. Let's check what it will return. So it's not a prime. Now let us check for 12. We know that this is not a prime. 12 is divisible by 6 and 12. Let us check by 7, and we could see that this number is not divisible. So we could check that the 7 is prime number. So with this, we could wrap up our lecture, and here's a 2-task assignment for you. Basically, we need to calculate if the number is palindrome or not. Basically, if the number is same from the backward or forward. So 1 to 1 is a palindrome number because it's similar from front and as well as backward. So 1 to 1. If we backward it, say we could do 1 to 1. We need to do only for the integer, and if you are feeling much more excited, you could do it for string. So for example, dad could be a palindrome because DAD, and if you reverse it, DAD. So basically, I will also give you the hint what you need to do. And with this, I hope you could solve this. And in the next lecture, we could see how you could solve this exercise. And in the next lecture, we are also going to see how you could do the visualization. And with this, I will see you on to the next lecture. Hey everyone, welcome back to the R Masterclass course. Today we will be looking at our visualization, and this is one of the most important topic in this course. This lecture and the upcoming 2 lecture would be one of the most important lecture in this course. And with this, let's get started. So you might be wondering why our visualization is one of the most important topic. So let's get our hand dirty. So if I show you this graph, you could start automatically interpreting things, and basically this is the visualization from a data set from the salaries of a college professors. And here you could see, if I show you this, you could automatically interpreting lot of things, such as that professors are in university there are much count of professor, then we have the count of assistant professor is more, than we have associate professor whose count is third. From this graph you could also interpret things that male professor is greater than female professor, because you could see that this bar plot have more count of male professor. So male professor count is greater than female professor. And if we look at this plot, you could see that the most salaries are in the range of 50k to 100k, and the max that goes around is around maybe 300k. This could be 300k range, who are in the profession about 40 to 30 years in this profession. You could see that their age is around like 30 to 40 years age, and they are earning about, the highest one they are earning about is 300k. And I don't need to learn any new thing, just I am interpreting things from this graph. And here is a box plot graph, basically a plot with having a box plot, and this line shows you the median, the black line, and this is the highest and this is the lowest range, and this is the most of the part lies in. Similarly for the female, this is the most part that lies in, and you could see that the male average is greater than the female average. So you could say that from this graph we could also interpret that males professor earn more than female professor. Here we have the highest in the range of, you could see that the max was the around 300k, but the max highest in this line is around 200k. Then the lowest is at 50, above 50k somewhat, it's around something 50 to 53k, and most in lies in the region about around 70 to 140k. That's the average that male professor and female professor earns, and basically female professors earns little less. And basically you could interpret lot of things just by looking at this graph. So you know that pictures speak 1,000 words, and by using our visualization you could do this. So now let us see what we are going to learn in this course. So what are the outcome of this course? First, data visualization is a crucial part of data analysis that will allow you to better understand and interpret data. So if you are into ML engineering, or are you into data science, or are you a researcher, or are you into any kind of AI ML or into deep learning, data visualization will help you a lot, because once you need to create a model, you need to know about data sets, and if you know how what are the trends in the data sets, you could create a better model. Other, if you don't use data visualization, interpreting data from directly from numerical is a very challenging task, and it's none too impossible. Now, if humans are way better in recognizing pattern in visual data than in numerical data. So if you have a visual data, it will help allow other people to discover the relationship, identify errors, and understanding the trends in your data set that you are using for visualization. Next, I cannot emphasize on this part, but there is always a saying that a picture says 1,000 words. So visualization have a stronger impact than a text or a numerical. So if you, which have a better effective way for storytelling and persuasion. So if you want to tell someone uh, your about your findings, a data visualization would make it very easier for other person to get it understand. Now let us know about the last point. Due to this point, persuasive power of visualization, researchers, data scientists, ML engineer, deep learning, and in almost all pharma industries, I have seen that they prefer R language for visualization. With this, let's get started. So before we move on to the R visualization, we should know what are the general steps for the R visualization. So first, we would have some data, some kind of data sets, and this data set could be data set of, for example, the car. The data set of the car may contain number of doors, mileage, uh, safety, and so on. And then we apply data transformation. What does data transformation means? We clean the data set. We clean the data set. We check if there is any null values, or is there any values which will affect the whole data transformation, or if there is a null value, we might remove it, or we change it with any other random values or mean average values. And then we visualize the model, visualize the data sets, we get the trends, we get to know okay what's happening, and then we got to know the what data set is representing. Then we go on to the model part. So here is the whole general overview. Now with this, let's get started directly with the RStudio. So first you need to open RStudio. So the first thing we need to do is, for our visualization, is we need to install some packages. And to install packages, we know that install.packages and the package name would install it. So here are the general packages that we required, and we are going to import this from CRAN, that is maintained by R, and the full form of CRAN is Comprehensive R Archive Network, which is maintained by our open source community. So basically, these are the packages we are going to use, and don't get overwhelmed. We are going to check each visualization library package one by one when we are going to import the data set and use the visualization tool. So first, now let us run this, and I will paste this code into the comment section, and I will post this code GitHub repo, and this way you could copy this code and run into your machine. So the shortcut key we know, Control Shift Enter. Trying to it's downloaded, content type, and it will take some few minutes. Once it's get downloaded, so what basically it does is it's try to fetch to that R package. It downloads it into their R repository, which is in our local machine. We have this packages installed, so when we mention this packages, that is fetched from there. So basically, let us see if it's have been installed or not. It's taking time, so I will pause this video and will join back once this gets installed. So once these packages have been installed, we need to add few more packages. So let me comment this out, Control Shift C, and this will comment whole lines that we have selected. Then this is the packages that we need from GitHub, and basically what this code is doing is concatenate all this repos link, and then from the remotes we call the public method install GitHub, and it install all this dependency. So we know what we need to. We know the shortcut to compile, Control Shift Enter. Packages mode required but is not installed. We could install it from here. Once it's installed, we could install all the GitHub repos. And here in the background console, you could see all this GitHub packages is getting installed. So now let us wait for a few seconds and let us see how much time it will take to install all this. Now it's time to look at how you could import the dataset in R. So to import dataset in R, basically we need to have a CSV file, text file, or Excel file. We need to have some data. So to have some data, I already have the salary data set that we are going to use. So here's I have already downloaded it, the data set, and I will provide you the link. You could download it from the given link, or you could went out to the GitHub channel and you could copy the link and download the data set from there. So let me copy this, and then you need to copy this to your working directory. What do I mean by working directory? So when the file where you have saved this R script. So suppose you created this file and you saved in this R visualization. So this is your working directory. So you need to save those file there. So why? Because you could easily import that file from there, that particular path. So because it will be very easy, you don't have to mess around and add an attribute that where the file is. Basically it will be the same folder in which the code is. So you could just say demo, and here I already created a R file, and I'm going to save this to my working directory where I have saved the code. So I will go to 02 Masterclass, coding, and here is my data set. So once you have pasted it, you need to make it your working directory. So how to make this your working directory? So suppose I am here. First you need to go to your to the path where the file you have stored. So I have stored in desktop folder 0 to hero in masterclass, R masterclass, and in R coding I have saved this file. So the first thing I have to do is I have to make it a working directory. To make it my working directory, you need to go to this gear icon, which is known as setting, and here in this you could see set as working directory, and here you could set this as working directory, or you could go to console and type this set working directory and the path to your uh, file where you have saved this. So we'll remove this, and now to import this file we need to have a library. So first library we need to have is read R, and you could see here it's already providing some suggestion. The goal of read R is to provide a fast and friendly logo. This is logo which is breaking way to read rectangular data like CSV, TSV and FWF. It is designed to flexibly parse many types of data found in the wild while still cleanly handling when data unexpected changes. So it helps you to read the data from CSV, and if your CSV is messed up, it also fails, and through their function you could handle those failures. Let us declare our variable in which we need to save the values. So salary, in which we will save values, read CSV, and you could see that it is importing this method from read R, and it requires file, and mostly it will have all the default values, so we don't need to change anything. We just passed our file name that we need to import salaries .csv. Let me check if there is any typo in the file name. So there is no typo. Let us save it. We know the shortcut key to clear the console, that is Control L. Once that's done, save the file, Control L. We could see our variable salary have 397 observation in the environment tab once you came, and here you could see it has rank, discipline, year since PhD, year of service, sex and salary. Now we know how to read CSV file, and what does CSV file mean? Basically comma separated values. And if we need to read TSV files, what do you mean by TSV? Basically a tab separated values. And what does TSV is for stands for the .txt extension, basically your text file. So here in this URL I will provide you in the link. It have those same CSV values in text format. Basically you could copy, and in your working directory here you could create a new file with name text file. Here new file, and in the text document you could create those new files and basically paste those values. And once you come to your editor, you could see all those files have been already imported. So here you could see that there is some typo in this, that is salaries.txt.txt. This is not a good thing because it's will confuse the editor that what it is. So in the naming part we need to remove .txt, basically a normal convention, basically capital S and a capital name of the file. In first letter should be the camel case, and all the other things should be in small, and if it's another word, it should be a in caps. So basically if it's new text document, basically you should avoid all the time space because it would mess in the data set when you import, and it should be camel case. So first letter N should be capital, then the text words in this, the T should be capital, and in the document D should be capital. Because of the camel casing, the first letter should be capital. Once we did this, we know what we need to do. So from the read T, let us create a new variable. Let us say salary TSV, and what it does is basically import from tables separated values. So, and here you could see that we are getting a hint suggestion that you need to do same thing that you did for salary. So salary dot txt, control S. Let me remove all the environment variables so it is easy for to get the environment values, and here you could see the same values have been getted in salary tsv. Now it's time to learn about dplyr package. So what do I mean by dplyr package? So if you come to Google and search for dplyr, it will open a website that is dplyr.tideverse.org. Basically, dplyr package provides us data manipulation techniques to manipulate your data. So we have looked how to import data. Now it's time to look at how you could transform data. So this is where dplyr came. So it provide us basically 5 functions, and we are going to look each one in much detail. So first one is mutate, and we are going to look at some overview, and then we are going to apply it. So mutate basically help you create a new variable and you want to change some values into it. So basically, if there is a salary and you need to create a new column with salary doubled into it, you could use mutate. And then we have select, basically to select the columns. And then we have filter, which we need to filter out data. If the salary is greater or 50, then particular salary bar, we need to get only that person, so we could use filter. Then we have summarize, that give us the summary value, basically a mean value of all the data set. And then we have arrange, if we need to change the rows or columns of the data. So first, let us start with the select one. What does select do? Basically selects any column, row, column of the data set. And for this, we are going to use already imported data from that dplyr. It already provides star work character. It have name, date, which contains the name of the character, height, which provide the height of the character, mass, weight, hair, color, skin, birth year, sex, gender, home world, species, films. And now let us first save it and create our new file. We know the shortcut what it is, Control Shift N, and first let us save it with the file name our Visualisation dplyr. Now first we need to import dplyr package. We know how to import it, library dplyr, which it imports it, the library. We define new data, in which we need to first see what does Star Wars data contains, then we will select it. So first what we'll do is we create Star Wars data, what it particular does, it does just Star Wars data. You could see it imports from the dplyr package. So let us clear the environment tab that we need to import. We remove clear or console and then run our program. You could see we have Star Wars, and we could open this data set by clicking on the column tab. It gives us the name, height, mass, hair color, and you could see here are some NA values. We will see how we could handle those. And then we have all the films that it contains, vehicle it has, starships that it contains. So I haven't watched Star Wars films, so forgive me if I skipping some main parts of the Star Wars data. So now what we need to do is we need to select the data, only the, let's say we need to select only name, height, mass. So what we need to do, we create new data and then we call select. We could see it's from dplyr, and then we need to pass the column that we need to, first we need to pass the data set that we need to do this. So we pass the data set that we need to do this. Either you pass the Star Wars or you could pass Star Wars data. Basically both contain same data columns. And now from this we need name, height, mass. So we will import name, height, mass, and then save it, and we will see the values in the uh, environment tab. So let us clear our data, run it. You could see here 3 variables, 87 observation, and it contains all the value. Now it's time to learn about filter function. What if we need only mass in which the mass is greater than 77? Now it's time to learn about what does mutate does. So basically mutate is basically you need to transform your current data set, or you want to add new values to data set. You could do this with mutate. So let's suppose we create new data too. Basically what we did here is we going to mutate or current new data that we have extracted from Star Wars, and what we are going to do is basically transform that current variable. So we call height is equal to height into 2. We basically increased by 2, for example, and we did similarly for mass. We increase it by 2. We save it, enter it, and we see the new data 2. Let us add new data 2 variable to it. So why did you add 2? Basically to find the difference. So I will run it, Control Shift Enter. You could see new data 2. 3 values. Here we have height doubled, and if you see new data, you could see the height has been doubled in new data 2. So now let us go back to where we were, our data visualization. Now let us look onto the filter. Basically, if we need to extract the data values from your data set, we use filter based on a certain condition. So let's suppose we want to extract new data 3 from filter. You could see that it requires data and some condition. So, and basically preserve is that the condition of the row data column needs to be changed or not. So we are not changing, it's by default it's fault. So new data 2, let's take new data, basically the original values, and we say we take height where it should be greater than 172. We run it. Basically let me add new data 3 so we could find the difference between new data 3, and here we will get all the values greater than 172. Now it's time to learn about the other two, that was summarize and arrange. Now let's look at how you could use summarize. So let us create a new variable, new data 4, and we call summarize. You could see that it is called from deployer package. If you need more help, you could run basically call more help like summarize, and if you press additional help, you get the documentation open in your help tab, which you could use to find to know okay what is happening. So here basically you could see what are the data parameter it accepts. All this thing it accepts mean, all this thing we are going to use one of these example. So what we are going to do is basically let us go back to the tab, summarize, and then we pass new data, and then we summarize mean height is equal to mean of height that we have selected, and in this we pass na dot rm is equal to true. What it basically does is it says if the values in the height is null, it will remove it. We do for similarly for mean mass, or mean mass na dot rm is equal to true. Then we save it, control shift enter, we get new data 4. Let us open it, we get the value summarized into single line. That is what summarize does. Here we could see that mean height is around 174 and mean mass is about 97 kilos. Now let us look at how you could use arrange. Basically, arrange is used to sort your data into particular format. So you want to, if you want to show your data by ascending height of mass, you could use arrange. So let's suppose we call new data file and we want to arrange this data set based on the mass. Suppose we want to arrange it by, suppose, descending order of mass. So we call new data and then we call dsec, basically by dissect, and we pass height. We save it and you see new data file in the tab, and here you could see all the values based on the descending value of height. So you could see the height 264 is highest, and then in the last we get the lowest. So with this we could wrap up the data format section, and now in the next part we will look on to how you could use ggplot library to visualize data set. Now it's time to learn about ggplot2. So ggplot2 is one of the most used library for data visualization in R, and we are going to look this in very depth. So here is ggplot2 documentation, and here in the overview you could see ggplot2 is a system for declarative graphics. Based on grammar of graphics, you will provide the data to tell ggplot how to map variable to their aesthetics. So in starting of this lecture, we have already seen install this package. If you have not, you could just directly install by install.packages ggplot2. So you could do this by opening RStudio, and once you are done, and then install dot packages ggplot2. What it will do, it will go to that package directory and download it. And we already have this package, so we don't need to, it will take time. So once it's downloaded, they also provide cheat sheet, and here you could see what they basically do is let it load. So here's the documentation how you could use it. So basically you need to use geom, which we are going to look this in shortly in very much details. And basically you need to provide the data set and then the aesthetic how the data should look like, and then you should call geom point. So now it's time to use the ggplot2. So here we'll be using this documentation, and here now I will give you one technique to use directly dataset from online. So here let us define the URL, and this URL is a string of the location of the file, and then we'll call, basically this data set is of insurance, like, and this data set contains male, female, age, BMI, children, smoker, region, and expenses. So basically we need to read this data set. So let us declare a variable that hold this data set. So we know how to read CSV file, read slash CSV. It should be, let me include dplyr package. library, and then we import ggplot library 2. Once this done, so let us read CSV, and then we pass URL, Control Shift Enter. We get the data set values. Here we could see all the values have been imported in R. Let us save this. Once this done, let us create one more data set. Let us call it obese. So here we have insurance data set, and we know if BMI is, there is a standard rule that if BMI is greater than 30, it will be considered obese. So we will create a new column known as obese, and to do that we are going to use column method. That means to create, if there is no column, then create one obese, and we have a obese column, then we call if else, and here you could see if else condition. Let us take this from deployer package, and what we need to do is we will pass our insurance, and from this we will fetch the column. We know we need to use dollar method, and then from this we need to get the BMI. So we'll get the BMI, and then if this greater than 30, this should be inside obese, else not obese. So basically we will put in double tag, and here we have a typo error, unexpected token. So to do this, so to remove this unexpected token, we just need to remove this brackets, and it should be fine. And then we'll clear our console, Control Shift Enter, insurance undefined. We have a typo here because it's saying that insurance, which is a typo. We have again a typo. Let me just copy paste it. Let us copy paste. We get the so here in this we also have a typo. And then once it's run, we could see our data set, and it have an obese column which contains if BMI is greater than 30, it's obese or not. Now it's time to use our ggplot library. So now let us try to use our ggplot library. So now we have looked how to create a new column and fetch detail from the column using dollar method. Now it's time, let us plot something. So let us try to plot age versus expense and see if age increase, does expenses also increases. Let's try to see that. And to do that, we need to have a library called ggplot2, and we already in the starting point we looked at what is ggplot library does. So we will call ggplot from ggplot2 function library. So we will call ggplot. Okay, let's just see why it's ggplot. Here we could see the documentation. Basically you need to provide data mapping. Aesthetic, basically you need to provide an aesthetic is x and y, and then that will create your plot. Now let us create your plot. Data we will provide insurance, will on mapping, we provide our aesthetic, to be X will be our insurance, age, insurance, dollar, and then here we will provide expense. Let us see, save it. Now you will be surprised. Okay, nothing have been plot. Yes, nothing have been plot. We need to use one more method, that is geom. Basically, geom provides lot of function methods that uh, what to show to the user. Basically, if we need to show the points, we will call geom/point. So we need to add geom method inside this. So basically, it provides bunch of function geom/underlines, and then you have lot of methods to create graphs. Basically, from this, like they provide the error plot, dot plot, histogram, and from this they will provide also you the line, but we need only point. So we'll see, and here we got our plot. So now in this plot we could see that expenses generally tend to increase over the ages. So and mostly it's yeah, it's does increases generally over the time, uh, and it is maximum here we could see in this, but we are not able to interpret this from this point plot. Let's see what we can do this for. Now let's see what we can do this. Now looking at this graph, you were saying that our graphs needs to be very beautiful, but this doesn't look like some that. So let us see what are the option does geom points take to make it much better. We'll go on to the beautification much later, but let's see how we could beautify this. So in very simple method. So geom point takes color point alpha and shape as a parameter. So color, let us provide it to be, let's say, blue, and let's say alpha, which is like how concrete the color is. Basically, if you make it less, it will be transparent. If you make it 1, it will be much more like solid color. So it values range from 1 to 0. So 0.7, let's say. And shape, it takes integer value. So let us define a integer which is multiple of 2. Let us save, Control Shift Enter, and here instead in the shape we should give it a size. So it's taking the value of the shape. So we had a typo. Size is basically the size of this point. Now let us see if we want to have a line which determines the average value that which is moving towards this. So for this we could have smooth, which basically it sees and pattern presence over the overplotting. You will see the documentation aids the eye in seeing pattern in the presence of overplotting and stat smooth and effective analysis. The both uses the same argument. Use stat smooth if you want to display the result in a non-state geom. Basically, it will give us the smooth line that which follow all the data points. So basically, we will call smooth, and here we need to provide a. Let us see what will happen. Here we didn't get any line. To use the line, we need to call a method that is equal to LM. And here, if we look, let us change our line color. let us say make it red. And here we need to add addition that we missed in typo. Basically, a method we provided lm, and it points the smoothing line throughout the data, and we could see it's clearly increasing in the expenses as age increases. Now, if you are wondering what does lm means, here in the lm, basically it's a linear model to use to generalify the data set. So here the line is used by using linear model to get this line. We have one more term that is GLM, which is generalized linear model. So in linear model we have a error term, that is a linear model equation is always a1x plus b2x plus c2x 3 plus so on, and in the end we have a error, like if the data set is not getting exact the same. So in this error we could use different error function methods, and that is generalized linear model. So you don't need to go deep into it, just you need to have an idea, okay, what lm and glm basically looks like. So if we enter, it basically will look like same. Yeah, just a little much more tangent it have in this line. You could see that it's much more above. But now let us keep it lm, and now let us define one more column. Let us say we want to get the color based on the smoker. So let us say color, and in this color, sorry, and in this we provide insurance and then smoker. We need to remove this method color because it will keep all the red method. So we will see, could see based on the color. So here generally the smoker is in the blue, and they have much more expense. You could see that if the person is a smoker, it generally have more expenses compared to the age. Like, yeah, age is also increasing, but with the age you could also see that those which are smoker have much more expenses. You could see that above this 20-40K how much their expense it is. Now let's see how to use facets. Facet is a type of method that could replicate your plot once again with different variables. So to use facet, we just add one more method, facets, and this time we'll call wrap, which will just replicate the graph, and we just need to provide the variable that we want to look into. So we'll provide tilde, and in this we provide insurance and obese. And here we could see that one more observation, that the person who is obese have much more high expense rate, and they are also like smokers, fit into smoker categories, which is one of this kind of fact you could see. Now let us see how you could provide title, subtitle, plot, x-axis name, because this is not a convention name to it. So basically to use this, we could have a labs method in which we could provide title, subtitle, caption, tag to it. So we'll provide title, which is text. So we'll say insurance plot and plots. And then in the subtitle, we could say plot for the graph from age 20 to 60, just a text that explain this graph. We could also name our x-axis to be age and or y. So here's one typo. We have double equal to, that we need to fix, and then y is equal to expense. With this, I think this is cool. Could run this, and here we get our title, subtitle, expense, age, and all this. Now it's time to learn about theme. Before learning about theme, we should know about what we need to do if we need to change this. So basically, we need to provide one more parameter, that is color is smoker. This needs to be a string. We'll enter this. We could see this is running exactly that we need to run. Now let us see how you could use theme. So theme, you could have different themes you could play with. Let's say theme classic, and it already have some basic predefined methods. So you could see that graph have gray text, and the text font already have been changed. So let us do with different methods. So let's say theme black and white. So let's check what does black and white shows. It's also same, nothing different. Theme, let's play one more time. Let's say minimal, and see it provides you the predefined method family that they are going to use. So this is pretty much same all this, because we don't have too much graphical notation in it. So that's why pretty much all the graphs were same. So with this, we could wrap up our lecture, and here's a task assignment for you. Here is our Star Wars data set, and you need to plot similar things for height versus mass, and you need to create one more column which is twice the height of the current height, and you need to plot the similar plots that we have plot for the insurance data set. With this, I will see you on to the next lecture with the another plotting methods, that is univariant, bivariant, and multivariant. See you on to the next lecture. Thank you everyone. Hey everyone, welcome to the R Masterclass lecture 7, and this would be the lecture 2nd of our data visualization series, and in this we are going to look at some different graphs. Basically, we are going to look at how you could plot categorical data, and we are going to look at some cool graphs, and here you could see some of these images. And with this, I hope you are excited, and let's get started. So now let us look at how you could do data visualization. But before we jump onto the data visualization, we need data, and this data could be further divided into two parts, that is categorical data and quantitative data. So first, let us look at what is categorical data. Basically, the data which could be divided into groups. So these groups could be race, sex, and education level. So for example, the education level could be some student, their highest education level could be bachelor's degree, some could be PhD, some could have masters, some could have a degree in BSc, and similarly, let's take another example. We could divide this sex into two parts, that is male and female. So you got the idea that categorical data are the data which could be divided into groups. Now let us look at what is quantitative data. Basically, the data which represents data represented by numerical. And for to take any example of this, you could take example weight, height. Yes, we could take also age. So these are the data represented by numerical values. For example, this could be age, height, and weight. So let us look once more what is quantitative data. Quantitative data are the data represented by numerically, including anything that can be counted, measured, or given a numerical value. And for example of this could be age, height, and weight, because these are numerically represented. Now we have got an idea of what kind of data we are going to deal with. Basically, it could be categorical data or quantitative data. And based on this, our graph could be divided into three parts, that is univariate graphs, bivariate graphs, and multivariate graphs. And the name suggests their definition itself. So in univariate graphs, we plot against single categorical data or quantitative data. It could be a single categorical data or single quantitative data. Similarly, for bivariate, we plot against two categorical data or quantitative data. And multivariate, we plot against three, or we could have more. So three categorical data or quantitative data. Now let's deep dive into the univariate graphs. So for data visualization, we need data, and I am currently on the website of our documentation. And if you remember, in lecture 1 we have installed a lot of packages, and one of the packages was Mosaic data. And in what does this Mosaic data packages does is it basically installs lot of datas, and basically it contains lot of data regarding health, marriage, health protection, helpful, weather, snow GR, utilities, riders, and lot of data. But basically we are going to deal with the marriage data records, and it is containing categorical data. You could see that it have categorical data such as race, age could be a quantitative data, date of birth could be quantitative data. We could see the college, this could be categorical data, and you could divide this data variables parameters into categorical data or quantitative data. So first we are going to look at the bar chart. So for this we need to open our RStudio. I have already opened it. So for the bar chart we need to create a new file. We are going to create a new file, and basically we know the shortcut, that is Control Shift N, and it creates a file for us. Let us save it. We are going to name it bar chart plot. I have already created one, so I'm going to replace it. Yes, and the first thing we need to do is need to import ggplot2 library. ggplot2, we imported it successfully. Let me see. And here we need to get our data. So we need to call data marriage, and then you could see that we need to call a package. So we are going to call package, and we are going to call our Mosaic data, and then we are going to, let's say, import the data marriage data set into some kind of variable. So marriage data, let us for our sake purposes to look at what kind of data we are going to deal with. So we have saved it. Let us run this, and in the environment you could see the marriage data, and here we could see booking page ID, app date, ceremony date, delay, official title, person, DOB, trace, pref count, and pref pref cons, HS, college. I don't know what pref cons does, so let us look at what does pref cons indicate. The way the last marriage ended, so we don't need to do anything of that. Basically, what we are going to do is we are going to plot a univariate graph, single plot against the data race. So we know the ggplot2, and in this we are going to import our data from the marriage, and we need to call the aesthetic. In this we going to pass our x-axis as race, so let us say race, and then we need to plot a geom, and here we have lot of option. We are going to plot a bar chart, and then we are going to save it and run it. Here we have our plot, and let me zoom it. In this plot you could see that the number of marriages in this data set was this data set basically is from Alabama, USA. So white marriages is greater, then we have black, then we have kind of Hispanic, and then American Indian. Now once we have plotted it, let us look at how you could make this more visualized appealing. To make the bar plot more appealing, we could add labels, and we remember to add labels we need to call the function labs. And to make this plot more appealing, we could fill the color and add a color bar color also. Now let us make our plot more appealing and add our labels into it. So basically we could fill the color, let's say corn blue, and cornflower blue actually the correct name, and let us call our color basically the border color to be black, and let us add into double quote. This is good. Now let us add labs into it. So let us name our x-axis to be race, y could be count, y is count, title could be, let's say, participants by race. And now we have our graph, which is much more beautiful. Now the general method to plot a bar plot is to have a percentage, and to change the count to percentage we need to use after stat method. Basically what it does, it provides the count specifically in particular group, for example in black, the number of count in black, and we could divide it by some, we will get our percentage. So we will call y is equal to after stat, and then we'll provide count, and then in this we could call some data, and we'll save it. We could change the y parameter in labs to %, and let us save and run. Okay, so we have gotten a typo. We need to provide a count here. So Basically, the issue was that we have a typo in some we provided the data, which is and a variable does not exist, and our compiler throws an error. So here we get the data. We could see the percentage, and here we could see that around 20% is about black. We have 1% about American Indian, Hispanic, and about 90% about participant white. Now let us convert these into the percentage. Now you might be getting the values in not in percent. To get the values in percent, we need to call scales, and basically we need to scale y and y continuous. Uh, Universe, and in from this we pass labels, and we call scales, and from in this we call percentage method. Let us save, run it, Ctrl Shift Enter. We get an error that we could not find scales. Why? So why? Because it's a typo, basically scales y, and we its s was extra, so we get the scale by continuous y percentage, and here we could see around 1% is about American Indian, Hispanic, then we have black about 22 percentage, and then we have almost 90% about 80 to 90% about white. Now let us look at some miscellaneous example. So first we could look at, now let us look at overlapping issue. So there might be cases in which your coordinate, that categorical label, will be overlapping with each other. So now let's see that case. Overlapping labels, and in this we'll basically plot or ggplot2 marriage data, and then let's say aesthetic, and then in this we want to plot against official title. Let us save it. We plot geom bar, and let us add plus, and let us save it. And here you could see now the plot have overlapping labels. So how you could solve this? Basically, one method you could do is call a method that is known as coordinate flip, and you could do this by coordinate flip, and what it does, it basically flips the coordinates. So basically your x-axis become y and y become x. So you will understand much more easily when I run this code. You could see now the official title is here. You could get all the details, and if you see this you might think you need to add also the labels. So now let us add labels method, because the y-axis is not showing the correct thing. So we call label, we say x is or official title, we say y is participant count, basically we could say count also in short, and then we give the title participants by official title. And now let us add 2, fix it, let us save it, run it. We get our labels correctly. So instead of using coordinate flip, we could have one more method That is, what we could do is basically get the text from the x-axis and just rotate it by 45 degrees. And sounds overwhelming, but it is not that tough. So we call plus, basically add theme, and this from this axis dot x dot text we call element text, and we just rotate angle by 45 degree and then adjust it by 1. And here it says theme element is not defined, so there's a it should be element text dot x, and then we run it. It runs perfectly. We get our count, and in x-axis we see that overlapping is not happening in the x labels. Now we have learned how to plot a bar chart. It's time to look at how you could do this in PyPlot, and it's very simple. So first we will need to import our GG Py library where we could do our PyPlot, and from this what we need to do is we need to call our data and we pass marriage. We need to import from the package exact data, and then we just need to call PyPlot ggpy, and here we could see we need to pass a group data, group key, and count type, which could be and a fill color. Yep. So we could do it very simply. So we pass data to be or marriage, and then we need to pass count type, which could be either count or full. So we say full, we say fill color, let's say null, and yeah, then we are good to go. So press enter. We are missing group key, so basically we need group key is which variable you need to map with. So here this is a univariate graph, so we could map it with say race. Race is not found, and here we have a typo that we need to add it in double quote. So once we're done with it, you could see 74% are white, we have 22% black, 1% American Indian and Hispanic. Now now it's time to look at one more type of a graph that is known as tree map, and you might be wondering what a tree map is. So basically here it is a tree map, and the graphs are shown in rectangular form, and here you could see these plots are in nested rectangular format, and basically the more the area, the more the count is. And here you could see this is the, you have seen this graph a lot in stock market, and basically you could see the usage of these types of graphs, and basically the more the area is, the more the market cap it is. So at the time of this graph, the Apple was having much more market cap than Microsoft, than Google, than Meta, than Amazon and Tesla. And here the more the area is, the more the market cap is, and basically you could see it's more than Nvidia. But if you see latest one, might be it have been changed because Nvidia might have much more market cap than any other company now because of artificial intelligence. Now let us see how you could do this plot in tree map. So basically first we need to import our library or ggplot2. Then we need to import a library tree amplify for our tree plot. Then once this is done, we need to create a count, marriage count, that basically gives us the count for our marriage. So marriage count, basically it will give us the count for our official marriage titles. So we create table, we get our marriage, and then from this we import an official title, and then names, marriage count, we get as count, make the column as concatenate or official title as count. As count. Let's enter, we get our marriage count, and here you could see the official title and count of it. Now it's very easy to plot it. Basically what we do is ggplot2 marriage count, and from this we need to call aesthetics, and in this we call fill for our official title. Then we say area is based on the count. Then our label should be official title. We save it, and then we just need to create a tree map. So and then we run it, and here we get our tree map. And basically you could see that marriage official lies here, ministry lies here, pastor lies here, and bishop lies here. But we need suppose text on our graph, so we'll add this, say geom tree map text, and then we say grow is equal to true, basically to fit our text into the plot, and reflow is equal to true, basically for fitting our data. We save our code, re-enter, and here you can see that this is for pastor, marriage official, minister, circuit judge, and etc. Now it's time to look at the waveform plot or chart. Basically in this, the plot is represented by a grid or a square box, and each square box contains the particular area of the percentage that it contains. So now it's time to look at how you could use waffle plot in R. To plot this, we need to first import our library, that is waffle, and then we call ggplot, and then in this we call pass or marriage count, we say aesthetics, in this we say fill or official title or value would be count, and then we need to call geom waffle, and basically if we need to also pass a parameter that if it contains any null values, remove it. We save it, we run it, and here is our waffle plot. It looks prettier than, I think, bar plot and or tree map. Basically we could see that the marriage official have high count, then we have ministers, and similarly in the same count we have pastor. Then the least we have is for circuit judge, elder, and Catholic priest and bishop. So you could start to deduce many facts from this graph. Now it's time to look onto the quantitative graph. Now it's time to look at the quantitative data. So previously we have discussed what is quantitative data and what is categorical data. In categorical data we have seen different types of plots. Now it's time to look at what is quantitative data and what are the charts you could use for data visualization. For basically quantitative data is the data representation in numerical form. So the data which contains numerical value is called quantitative data. So this could be the age, weight, and so on. And basically this could be represented in histogram, kernel density, or dot plot. And if you wonder what, and we are going to look each plot in detail. So for the first part we are going to look at what is histogram. So basically histogram is a type of a bar chart that represents the distribution of a data set, and we could group this data into ranges, which is known as bins, and we could see how many categorical falls into that range, and the height of the each bar plot represents the frequency. So here is a histogram, and here we could see the range, it lies here. By default in R the bins value is 30, and here the vertical height, if I show you this vertical height is representing the frequency. So you could imagine it's lying about 70k around here. So this is representing its frequency. There are two terminology in histogram that we need to get crystal clear. In histogram, there are two important concepts that we need to know about is bins, and second one is bandwidth. Now let us look in detail what is bins and bandwidth. So suppose you have a score of 20 students of their examination. So this is the scores of students out of 100. So what would be the bins for this? So bins are basically the ranges into which the data is grouped. So we could group this into 50 to 59. Basically minimum range would be that 50, because after 50 we don't have a below score than 50, and we could take a size of 10, and the size is known as bandwidth. So basically bins are the ranges into which data is grouped, and the size of the bins is known as bandwidth. And here we could look, if we bin this and like group this data into of size of 10, we could get first bin 50 to 59, then second or 60 to 69, and so on we get till bin 590 to 99. And if we want to look into detail, what is bandwidth is basically the size of bin, and here the size of bin is 10, so or bin is bandwidth is 10. And if we want to look into detail how much student scoring the score in bin is basically one student have score base in 50 to 59 range, and 60 to 69 we have two students, basically 60 to 65. Similarly for bin 3 we have 7 students, basically the maximum we have students scoring range in the bin 3, and so on we could do for the other category of bins. Now it's time to open our RStudio. Now first what will we do is create a new file, and to create a new file, Control Shift N, and let us save it first in our directory. So I will save it into my R Masterclass and name it as histogram. So first we need to import our library. We import the library and we will name it ggplot2 basically for our histogram, and then we will import our data marriage, and basically we will import it from our mosaic data. And in this we have already looked onto the what data is. What we will do is we will start plotting it. So we will say ggplot, and then we will pass marriage, and then we will, for aesthetics, we will plot against, suppose, quantitative data, so we will plot against the age. So or aesthetics, and then we say x will be our range, and sorry, age, and then what we will do is basically say we need a geom slash histogram, and we get the histogram. We will add some title also into it, labs, and then we will say x is equal to or show or age, and then we could give it a title that is participants by age. We will save it, we'll run it, and here we get our histogram. We could see that here there is no data value available for our participants from the range 58 to 70. We don't have any values. What we could do is we could also prettify it. We could say fill we could say it fill, let's say we want it to be a color blue, and one of the favorite color is cornflower blue. Uh, it's have very aesthetic color, and then in the color of the border we could say it black. Save it, run it, we get our histogram in a much prettified way. Also, now we have learned about bins and width. We could define our bins and width in geohistogram plot. So basically what we could do is we could say basically the default value of bins and width, bins is 30. We could change it and say bins is equal to, let's say we say 5, and let's run it. We get much more depth value, and basically it's if we reduce our bin value we get oversimplified data, and 30 is in okayish range. If we increase it we get exemplified data, like over amplified data. So if we increase value to 60 you would see over amplified data. So we should have a range in between. So 30 is a good way. We could also set bin width. Let's say bin width, let's enter it, and we get the size of our bins set it to be 60. Let's say we increase it, let's say 160, we get similar value that we have. So now we have seen how you could plot histogram. It's time to look at how you could plot kernel density plot. Before we look onto the kernel density plot, we should know what is kernel density plot is. So let's jump into it. Now it's time to look at what is kernel density plot is. Basically, kernel density plot is smooth out histograms that creates a continuous curve of the underlying data distribution. So once we get the histogram, if we smooth out the histogram, we get a continuous curve that is known as kernel density plot. We need to know about one more thing into this is basically the smoothing parameter. And what is smoothing parameter is basically it's the bandwidth in kernel density. So basically it represents the size of the bins in the kernel density. So if we want to plot this in R, let's see how we could do this plotting in R. Now it's time to look at how you could plot kernel density plot in R. So first thing, we will import our favorite library, that is ggplot. Then we will import our data, marriage. We need package. Import mosaic data. Then we will say ggplot. We need to import from the data package, or aesthetics would be X, in which we will plot the age, and we need to plot a geom kernel density plot. So density plot, we will import it. We'll say labs, and our title would be participants by age. We save it, we run it, we get our kernel density plot. Now we have got our kernel density plot. We could also fill this color to make it much more beautiful. So cornflower blue, we get our participants by age. Now in this we could also add one more parameter, that is known as smoothing parameter. We have looked at that is represented by BW. Basically it's bandwidth, and if we could smooth out this, change this, and we get much more width, like much more size. If we reduce this size, we get exemplified data, and if we increase this data, we get oversimplified data. So if we say 10, we get oversimplified data. Now it's time to look at onto the dot plot. Now it's time to look at what is dot plot. So in dot plot, each observation is represented by a dot, and the width of the dot represents the bin width, and dots are basically stacked one upon each other, and it is similar to histogram basically, and it is represented by, basically each observation is represented by a dot, and it is well for a graph which have small number of data set. And if we look onto dot plot, here's our dot plot is basically each data points are represented by a dot, that is a point. Now let's see how you could do this in R. So we have opened our ggplot2. Now what we are going to call is geom. Let us remove everything and do again by scratch. So let's say library, we import our favorite library ggplot2. We will say we need to import our data. So first thing what we're going to do is import our data. We know how to import our data. Marriage, we say package is equal to mosaic data, and we'll say ggplot. In this we need to get our marriage data. We in this aesthetics would be our x-axis, in which we show the age, and let's add geom, and we need to represent the dot plot. So for this we need called dot plot, and we will add title to it, labs, and then in the y we could say it's the count, and in x we could say age, title is equal to participants by age. We need to add this whole thing in double quotes, else our compiler will throw a error. Now let us save it, run it, we get our dot plot. We could beautify this by adding a fill. Fill is equal to, our favorite color is cornflower blue, and we could also add a background color, border color, that is black, which we already have by default. Let us revise for a moment. We have looked onto the histogram. What is histogram is? We have looked, kernel density is basically a histogram, that is smoothified version of it. We have looked, dot plot is basically also a histogram, where each observation is represented by dot. We have looked how you could do this quantitative plot. We have looked how you could do categorical plot, and in this we have looked onto how you could plot for univariate graphs. And in the next lecture we are going to look for the bivariant graphs. With this, I will see you on to the next lecture. Thank you everyone. Hello everyone, welcome to the R Masterclass series, and in today's lecture we are going to look at the bivariant graphs. So previously in previous lecture we have looked at the univariant graph, how you could plot quantitative data and categorical data. Now we are going to look at the bivariant graph. So basically in bivariant graph we plot two variables, and these two variables we know could be categorical or quantitative. So what's the need for bivariant graph? Basically in research, or you are in data scientist, or you are working on a data visualization of any data, you need to find any relationship between two variables, suppose A and B, and this is where bivariant graph came. So where you could find the relationship between two variables, and this is very helpful in predicting the pattern in data visualization. So if you have two variable, so the number of combination you could make is either the first data could be categorical and then other data could be categorical also. Similarly, the first variable is quantitative and the second data is also quantitative. And in the next categorical, it could be the first data is could be categorical and the next data could be also could be quantitative. So we could have three combinations. So now let's look at the first one, that is how you could plot categorical versus categorical. Now let us look at what is categorical versus categorical. So here we have in bivariant we have two variable, and one variable is categorical and other variable is also categorical. So the first thing we could plot categorical data is, that is categorical and categorical charts. We could plot a stack plot, we could do a group data visualization, or we could do a segmented bar chart. So now let's first look at what is stacked bar charts. In this we have multiple variables stacked upon one upon each other. And now let us look at R, how we could do this. So before we jump into the R, I want to show you that what data set we are going to use. So ggplot provide us MPG data, which is data of fuel economy data from 1999 to 2008 for 38 popular models of car. So in this we have manufacturer, model, display, and we have years, cylinders, transmission, type of transmission, city miles per gallon, and highway miles of the gallon, fuel type, and class type of the car. Now let us plot this in R. Now once you have opened your RStudio, you might have lot of environment variables open. You could clear this, you could get the size, that what is the environment variable size from here. And what to clear it, we could use this broom button. What it does, it removes all the environment variable. And what we could do is, one more thing, we could clear our console. And clear it, we just need to press Ctrl L and it will clear our console. Now once it's have clear our console, we need to get our data, and for this we already know that we are going to use the MPG data, and it have following columns into it, that is manufacturer, displacement, engine displacement, year, number of cylinder, transmission, the type of drive, that is front wheel, back wheel, then city mileage per gallon, highway mileage per gallon, fuel type, and type of car. So to get this data, we know first we need to import our first main important library, that is ggplot2. Yes, and we import it and we say ggplot2, and then we say data is mpg data and it's inside the package ggplot2. So we'll import this data and say ggplot2. Now once we have input our data, let us see what data shows us. So we enter it, and here we could, on clicking, we get the manufacturers, and here you could see some are already some model and their model that is A4. Then we could look at the year, cylinder, transmission, then drive, whether it's front wheel, back wheel, city, mileage, highway mileage, and FL. And what FL stand for is basically fuel type, petrol. Then it is having class, which shows what is compact uh, type of car is, basically if it's compact car, mid-size, SUV. So what we could do is, what we going to do is, we are going to plot the class versus drive, and let's see if whether we could find any relationship in it. So first what we need to do is, we remember that we need to call ggplot, and we import ggplot and we say mpg, and then we say aesthetics, and in our x we pass that to be our class, x is our class, and by fill, that which needs to be stacked upon, is our drive, basically front wheel or back wheel. And then what we could do is, we could say geom bar plot, because it's a bar plot, and in this we need to provide position to be stack. If you open the documentation, you could find that a position adjustment to use on the data of this layer, and we are going to provide a stack method. What it does, it basically stack all the uh, fill level onto the bar gram. So basically all the driveway we are going to get stacked upon. So it will be more clear when I run the command. So stack, and we say stack, and then we press enter. We get say aesthetic is not defined, so basically aesthetics. So, and if you getting this error, basically what it's saying is that you need to provide position, and that we have directly called stack. Basically we need to provide a parameter in the position. So that's what it is. So basically then we could enter it and we could see our plot, and by looking at this plot you could directly imagine what it is. So for SUV, you could see that four-wheel drive is dominating in SUV and in pickup, and you could imagine that is correct. Why? Because it's need a lot of power. And then in low size, like in compact and mid size, front wheel is dominating, and also in minivan it's completely dominating in minivan, whereas in pickup four-wheel drive is highly dominating, and in two-seater we are seeing that it's a rear wheel drive, because sometimes it needs to be a faster. So rear wheel drive provides a lot of torque in it, and we could see rear wheel drive is dominating in two-seater. Now it's time to look at the group bar chart, and basically in group bar chart what it is basically the data are put not on stacked one upon each other, it's placed by side. And here you could see that the data are side by side instead of on top of each other, it's on side by side the data are. So that's basically the difference between stacked bar chart and group bar chart. And now let us see how you could do this in R. So now I will open my RStudio, and here what I'm going to do is, I'm gonna remove the position stacked by dodge. And here what it basically does is, dodge is basically put all the layer side by side, and if we run, we get our group bar chart. Basically you could see that if the count is 0, you could see that the position is removed. So basically, if the in minivan, you could see that it's only front wheel drive, and the four wheel drive and rear wheel drive, the count is 0 and their spacing have been removed. To preserve this spacing, we have position dodge. Basically, that what it does is it preserves the spacings for the count zeros. So now let us use that to make our data visualization much more cleaner. So what we just need to do is we just need to call, where is my cursor? Yeah. In position, we need to call a method that is known as position dodge, and what it will does is it will preserve our variable that have count 0. So position dodge, and here in this we need to call preserve, we need to call single, and that will preserve all the variable which have count 0. We save it, we run it, we get all the plot. Here we could see if they have minivan, but the spacing have still been there. And in this we could also clearly see that four-wheel drive is dominating in pickup, and SUV minivan is dominating in compact, and front wheel drive is dominating in compact, mid-size and minivan, and two-seater is dominating in rear wheel drive. Now let us see what is segmented bar chart. Now let us look at segmented bar chart, and segmented bar chart is similar to bar plot, but in this each bar plot is 100%. So this bar plot is shown as 100%, and in this the division is made. So basically it's stacked bar plot, and each bar plot is considered to be 100%. Yes, and now let us see how you could plot this. So here is our group bar plot, and to plot a segmented bar chart, what we could do is we basically provide position to be filled, and once we run it we get our stacked bar plot. But this count is incorrect, so we need to correct our labels. So for this we remember that we need to provide labs, and we provide labs is equal to y is equal to proportion title. So proportion, and then we could run it and we get our proportion. Now we have looked how you could plot categorical data versus categorical data. Now it's time to look at how you could plot quantitative data versus quantitative data. Basically in this we have scatter plot and a line graph. Basically you could plot this by two methods. One is scatter plot and second is line method. So first we are going to look at how you could do this by scatter plot, and in the next we going to look at how you could do this by line plot. Now let us look at what happens in scatter plot. So basically in scatter plot we have a plot, and we plot basically two variables, and in this the benefit is we could easily find the trend. And what happen is basically once you plot a scatter plot, a best fitted line is passed to it. What is best fitted line? The line which tries to capture all the data. So basically some line is drawn onto this plot. Basically it's look like this. Let me do it again, and take me a line. Yeah. So basically a line is plot onto the scatter plot to basically give you a general idea of what trend is about. And scatter plot is basically used for this only, to find the trends, patterns in the data set. Now let us look at how you could plot this. For the scatter plot, we are going to use salary for professor data, and basically it's already installed in your machine. When in the first lecture, if you remember, we have installed all this package. So basically it provides us the following columns: rank, discipline, years, salary, and then we are going to plot scatter plot into it. So for this, let's open our R console. Now let us see what is scatter plot and how you could plot this. So basically you could clear your environment variable tab, you could clear your console, Control L, and then what we first need to do is call library and you know that we need to import ggplot2. Then we need to import our data. So data is our salaries, please, and inside the package card data. How do I know that it's inside the card data? Because I have checked the documentation. So inside card data, now let us look at how data looks like. We enter, we getting promise, let it fetch the data. It will take few seconds. What does promise is said? It is, I'm bringing the data I promised you, basically. So it's take few time to load the data. It's fetching the data, and let's wait for few seconds. So I have got my data, and if I open this data in tab, I got rank, discipline, years since PhD, years service, and sex salary. So now what we could do is we could do a scatter plot. Let us say in our X we could plot the experience years in PhD, and in Y we could plot the salary. So now let us say ggplot ggplot we call salaries. What we say aesthetics, how the mapping should work for X and Y. So in our X we plot years since PhD, and then what we need to do in for Y is basically is our salary. So we say salary, and then we say geom, and since this is our scatter plot, we say geom point, and then we close the parenthesis, we enter it, we get our geometry point. And in this, if you want to plot, you could see in starting of the lecture we also see that if you remember the introduction, their salary is the highest, and like it's about 38 years, and we could see general trend that since as years of experience increases, the salary is also increases. So what we could do is we could enhance this plot. So let us improvise this plot. So to improvise this plot, what we could do is we could provide parameters inside geometry points. So we could say color is equal to cornflower view, and we could say our size is 2. We could say our alpha, let us say, what does alpha indicate? Transparency. So if I, for example, this is I have added, if I reduce it to 0, 1, the transparency of the point data is have been decreased. So we say it is okayish, and we could get our plot. What other things we could do? We could add the title to it. So let us add that, and to add the title we need labs, and we could say in the title we need to provide string. So we could say years since PhD, and we could say Y is our salary. We could provide title to it. We have already provided subtitle to it, basically salary, and this data is, if you know, is from 2008 to 2009. We could save it, we could run it, we get our plot. You could also improvise the X title, so we could remove X and say X is our years since PhD, and we get a better plot. Now let us pass a best fit line. What does best fit line is? Basically it passes the line which is most accurate to the data set. So if you want to know what further we could do this, we could try to predict if at age 60 what would be the salary. And to use best fit line, we have to use a method we previously known as geom smooth, and in this we pass or method to be linear model to or be or method. So what we could do is we could add plus here, basically continuation of a model, and we could say geom smooth, and in this we could say method is equal to lm. We save it, we pass it, and here we get our best fitted model, and here we could predict it's generally increasing as years of experience increases. Now using linear model fit, we could find out that it is the salary is increasing as years of experience increase. But if you look at towards the end of this plot, here in the end in the 40s area, you could see there is slightly decrease in the salary. And the issue with the linear model is that it's a linear model, it doesn't capture those curves, and to have those curves we have other types of model that is known as polynomial regression model. And now let us see what does linear model and polynomial model is. So now let me open my Excel draw. Now let us look at a quick glance what is linear regression and polynomial regression is. And in a model section we are going to deep dive into this regression model, but basically we are going to look at the overview of what is linear regression is. In linear regression what we have is a simple equation. So in this what we do is basically, let me get my pen, and in linear regression we have y is equal to model or b naught plus b1 x, and what it does is basically when we call our model to train, we get our y value, and in this data set you could see we have a lot of y values and we have a lot of x value, and through this our model trains and try to get this b1 and b1 x1 value, and then it draws a line. Similarly, if we have polynomial regression, what it does is it's of the form of y is equal to b naught plus b1 x1 plus b2 x2, and this is quadratic equation because its degree is 2. This could go till n, so bn till xn, till the x regression. And generally most of the time the quadratic works, and more than bend than quadratic equation is like trying to underfit the model, so it generally does not fit in the model. So we could do this. So what we need to do is basically in the geom smooth we say our model is linear model, and we use a formula to use y, and then we call tilde, and then we say poly x2, which is basically a quadratic equation, and then we say the color, let us say we call it Indian red 3, and here you could see it is able to capture those curves. Now if you increase the model regression model to cubic, let's say from quadratic to, you could see it's going to overfit the data, underfit the data, and it's not what you want to like. Now you could see what's happening as I increase, it's trying to underfit the data and the equation won't fit in this model. So basically quadratic is max that you could fit, and more than this is just the model won't fit in it. You could see the model is trying to fit, and most of the curves are right in here, And if we, let's say we go to 100, it will take some time and it won't cover it. We could say 50. Let's see what happened. So we get till 12. Let's see if it could do 20. And here you could see it's have overfitted the data. Now, if let's say 30, we didn't get, let's say 25, we don't have. Let's try to find the max, how much we could do. Till 22 we get the data, let's say 23. So our largest scale that it could do is till 22. And we know that quadratic is better fit model because it's able to capture those low level data that our linear model was not able to capture it. Now we have look how you could plot scatter plot. And if you are wondering what this gray cover area in which this plot inside it, the red plot, quadratic plot model is inside it, is called band, and the upper band, that this upper band is known as higher confidence, and the lower band is known as lower confidence, and you don't need to deep dive into it. Basically, the red line, it needs to be there under this band, and that's the general idea. So now let us look at what is line plot. Basically, in line plot, we basically plot the data by line. We have the data and we plot it by line, and it's very beneficial if one of the variable represents time. So line plot is a very effective method to uh, display a relationship between data if one of the variable is time. So you could see, like here in this wildlife population, we are using line plot, and you could see that the general increase in the population of bears, slightly decrease in population of dolphins, and average in of whales, population in whales. So line plot is very beneficial if you want to do a relationship of like plot a relationship with the time. And for this we are going to use our data gapminder, and in this basically it provides country, continent, years, life expectancy. So what we are going to do is we are going to plot. So this is our time, like how much life expectancy at birth in years. This is our time, and we could use our country India to plot. Let us see what the plot look like for us. So let us open our plot, and let us clear our code. We're going to clear our console, Control L, remove all the environment variable, and now let us plot. So what first thing what we need to do is we need to import our library, favorite library, that is ggplot2, and then we say data is equal to gapminder, and we are importing this package from gapminder. We enter it, Control Shift Enter. We get a promise that the data will be provided, and data have been provided to us. So basically, you could see continent Asia, country, and basically they have the life expectancy, and it have lot of data. So you could see that total number of observation is 1704, and what we going to do is basically plot each of this. For India, we are going to plot the life expectancy. So to get the data of India, we need to use dplyr package. What it does, it basically used to manipulate the data, if you remember in our first picture. And what we are going to use is plot data. We create a new variable, plot data, and in this we filter our data and say get me the gapminder data, and in this which the country is India. So basically we get the Indian data set. Let us see if what other data we have got. So we have got about 12 observation of the Asia, and let us plot the life expectancy. So what we are going to say is ggplot our data is plot data, and then we say in aesthetics mapping, or X is years, and in or Y is or life expectancy, and then we say geometry line, that we need to plot a through line. We save it, we enter it, we get an error, years not found, maybe it would be years. So it is, and we could see there is general increase in the life expectancy of Indian, and mostly you could see uh, the life expectancy is till 65. Let's see for our neighbor Pakistan. Let us see if we have any data set for this. You could see there is also general increase, there is slight dip in it, but almost same. Let us do for United States. You could see there is general increase, but there is dip inside 1970s, 1980. We need to get the point basically. So to do that, we call our best method geometry points, and basically in geometry points we need to pass geometry points, and we say our size to be 2, and let us say color is equal to our favorite color, cornflower blue. Let us save it, run it. Could not find geometry points. So basically we have a typo, it's geometry points, and we enter it in compatible method. So in this end we need to pass a plus. Okay, so here's our typo, we need to add this below. So basically I have added the code above in the plot data, which is wrong. In the ggplot2 we need to provide this data. We enter, it's saying that you cannot use plus plus, so we will remove the extra plus, and we get our third data. So we could see the points, and we could better visualize the data where the dip is, and here we get our data observation. And for United States we already have 12 observation points, so total count of this point would be 12. So now we have looked at the categorical data versus categorical data. We have looked quantitative data versus quantitative data. Now we have plotted the quantitative data versus quantitative data, and now it's time to move on to the categorical versus quantitative data. Now it's time to plot our categorical data, and other variable would be your quantitative data. So one of our data could be a categorical. If one is categorical, the other could be quantitative. Similarly, vice versa. And to plot this relationship, we have large number of graph types are available. We could plot a bar chart, we could plot a grouped kernel density plot, we could plot a box plot, we could plot a violin plot, we could plot a ridgeline plot, mean SCM plot, and basically we are going to look at the bar chart. And what does bar chart means? Basically we are going to plot a bars in this plot. So with this, let's get started. And before we move on, we are going to use our salary data set, and in this lecture you have already seen it, what is salary data set. What we are going to do is we are going to plot a rank versus the average salary of the professor. So let us see how we could plot this. So first we could do is clear our code editor, then we could clear our console, then we could remove our environment variables, we then could remove our current plot. Let us clear all at once. So once we have clear everything, let us import our favorite library that we know that we are going to use is library ggplot, and then we are going to use data set is, or we are going to use our data to be salary that we are going to import from card data. Let us see if it's imported correctly. So it's salaries, not salary. a typo, and then we could get our data. We could see there is 397 observation, and we have already looked onto this plot. What we are going to do is now is we are going to calculate the average of the salary. Basically, in this we are going to take the salaries and calculate the average salary according to the rank. And to do this, we have a method that is known as aggregate. And in this, if you see, you need to provide some data variable into it, and in this we are going to provide our salaries as a data variable in it. And then with taking this, we need to call our rank, and then data is equal to salaries that we have used above, and calculate the mean. And it's saying aggregate could not be found, so it's a typo. And here you could see the plot data with 3 observation and 2 variables. We get the aggregate, and now we could easily calculate our plot using this data set plot data. So what we are going to see, ggplot, and we say plot data, and then we say aesthetics x is equal to our rank, and then we say y is our salary. So y is our salary, and let us plot it using our geometric bar plot. So we call bar plot, and then we could say that our stats should be identity, so it should be same identity, and then we double quote it, save it, and run it. We get our salary data set. Here you could see that mostly the salaries is in oddly represented. Let us see how we could fix this. Now let us see how you could fix this, the y numerical method. So basically what we need to do is we need to import scales first to fix the scaling. So we import the scales. Let us see if the scales have been imported. So I have scales pre-installed. So now what we need to do is we need to call scale y continuous, and in this let us add this into new line, scale y continuous, and in this labels we need to provide our data to be separated by comma, and then let us name it to be mean salary, and the y would be named as y axis would be named as mean salary. Once you enter it, you could fix this. So we could also fix the x label. So to fix this, we could add labs, and we could call x is equal to rank. It should be string, so we add a double quote, and we have fixed into the, or we have fixed our graph. Now let us see, if you need to, suppose you need to beautify this, you could provide more parameters in geometry bar, and basically you need to call stat, we need to call our color, that is fill, and color to be our cornflower blue. So cornflower blue would be our color, which will fix this color, and we'll save it. We get our color of geometry bar. Now let us see what this data represents. So we could see that professor are most highly paid, then associate professor, then the assistant professor is highly third highest paid. Now let us look at how you could plot grouped kernel density plots. Before plotting it, we should know what is grouped kernel density plot. So now let us see what it is. In lecture 1, we looked at what is kernel density plot is. Basically, in kernel density plot, we visualize the distribution of a continuous variable, and we smooth out this to show how values are distributed along a range. Instead of showing them data points or bar plot, we represent them by a smooth curve, that represents the density or concentration of data points. So if we look at this, we could see that the most of the density lies here for the group C. And what does group kernel density plot is? Basically, it's a extension of kernel density plot, and we compare the different distribution plot across different groups. So that what it is. So in this, we could see that we are comparing different density plots against different kernel density plot. Yeah. So here for B, then for C, we could see the different density plot. Now, now let us see how you could plot this. So now first we will clear all history plots. We will remove all variables. We clear our console, and let us remove everything and code from scratch. So we will import library ggplot. We will say we need to have ggplot, and then first we need to import our data. So to import our data, we know how to get our data. Then we need salaries, and then from the salaries we need from packages or our card data. So we have got our data. Let us see if we have got our data or not. So we'll go and see we have got our data 397 observation, and then we say ggplot, we say salaries, we say aesthetics to map the data x is equal to or salary, we say fill by rank, and then what we're going to do is we need a geometrical density. So we are going to use density plot for this, and we could say let's use alpha transparency is equal to, let's say, 0.8. The values range light from 0.0 to 1, and let us see here is our density plots. We could see that most of the salary lies in the range of we could say 50,000 to 100K, and max salary lies at like highest salary is around 200K something. Now what we could do is we could add title to it. So we could say labs, and there is one more challenge you could try to do is you could fix this scale by scale. So for this you need to import the scales library, and you need to add those variable into it, and the scale would be fixed. So you could try it out yourself and try to fix this. What we could do is basically we could add title to it. So we could add title salary distribution by rank, and now we have got our title. And now we could, what you could do is try to fix the y-axis by yourself, and let pause this video and try to fix it by yourself. Now I will try to fix this values. Now to fix this, remember we need to use import our scales library, and then once we have imported it, we need to call scales y continuous scales. Here we have a typo, scale y continuous, and then we could say that our labels could use comma as a method, and then we could enter it, and we get our density for this, and our y-axis scale is fixed. Now we have look how you could plot group kernel density plot, grouped kernel density plot, which is here we have grouped different different kernel density plot for associate professor, associate professor, assistant professor, and we could see that the density, like most of the professor are assistant professor, then we have associate professor, and then in the minimum we have professors. Now let us see that how you could plot a box plot. Now it's time to look at what is box plot. So in box plot, it display us the 25 percentile, 75 percentile, and the median of a distribution. So here in the box plot we could get, or the the single straight line in the box represents the median. If it's dotted line, it represents the mean. And the below this line we get our 25 percentile, like the 50% of the data, and in the below median line we get the 25 percentile of that data, and above that line we get the 75 percentile data. And basically this data consists of 50% data of whole data set, and this line is known as whiskers, and this line known as outliners, which could not fall in this plot. And this represent whole 99% of the data, and remaining 1% could be the outliners. So now let us see how you could plot this in R. So what we are going to do is first remove all the environment variable. We going to remove all the plots, clear our console, clear our coding environment, and now first we need to import our favorite library, that is ggplot2. Then we're gonna say that we need data, that is salaries, from package card data, and then we're gonna say ggplot from salaries or aesthetics. X is our rank, Y is our salary that we are going to plot. And then once we plot this, we need to plot this in box plot. And now let us see what the plot is. And here we could get a plot. We could add title to it. To add title, we could add a tag title. We need to provide box plot, and we could save it. We could run it. We get our box plot. Here we could get our uh, basically box plot. We could see the median for this lies about 125. This slides around 90K, and this slides around 75K for assistant professor. We could see that the highest could range up to more than 200K, and most of the 50% of data lies in this plot. And here below the 125K salary we get our 25 percentile data, and above this we get our 75 percentile data. Now we have got to know how to plot box plot. Now it's time to look at how you could plot the violin plot. Now it's time to look at what is violin plot. So basically in violin plot we have it's similar to density plot. We plot density plot, and what does happen in violin plot, it is mirrored. And if you draw a straight line, let me take a straight line. Yep. Now it's time to learn about violin plot. So in kernel density plot we have, look how what it is. Basically a density plot is mapped and smooth out function is used, and in violin plot we do the similar thing. We plot a kernel density plot. We get a plot something like this. If we plot our kernel density plot, we will get a plot. Now it's time to learn about what is violin plot. So violin plot is similar to kernel density plot. So basically if we have a or plot of or kernel density plot, basically it would look like something like this. And let me draw it, and we have here something smooth out function is used, and this is how our kernel density plot would look like. What happen here, it is maybe much more smoother. So let me draw again. So what happen in violin plot is it is mirrored. This part and this part look similar, and it is rotated 90 degrees. So this is how it will look like. So if you take a line and if you halfway it, basically if you half, you could see that this part and this part of plot are similar, and what it does, we rotate it by 90 degrees. So now let us look at how you could plot a violin plot in RStudio. So what we need to do is, it's very simple. We just need to say that we need to plot a violin plot. So we could say, instead of box plot, we need a violin, and we save it, we run it, we get our violin plot. Now it's time to look at what is ridgeline plots. What is ridgeline plots and how you could plot it. Now it's time to see what is ridgeline plot. So ridgeline plot is similar to kernel density plot, and in group kernel density plot we plot all the plots all together, but in ridgeline plot we plot it side by side. One more point we need to know, that ridgeline plot is also known as joy plot. Now let us see how we could plot this. So basically we remove all the code, we remove the environment variables, we clear our console. Now save our file, and let us first, we need to import our packages that is known as ggridge for ridgeways plot. So if you have not installed, but basically in first lecture, if you remember, we have installed the packages known as ggridges. So basically it is used for to plot gridge plot, and we will press enter. It will take few seconds to install it, and let us press enter. So it goes to the CRAN module and asks, hey, you could provide me ggridge library, and we already have, so it didn't take too much time. Let us import our favorite library, that is ggplot. Then we import our next favorite library, that is ggridge library, that we have imported now, gridges. And now what we need to do is, we need to import the data. So for this, let us see which data set we are going to use. For this ggridge plot, we are going to use fuel economic data once again. So we already familiar with data set. We have manufacturer, model name, displacement, year, number of cylinder, driveway, like which it's front wheel or back wheel drive, city mileage per gallon, and it's we have already a documentation of this data set. So what we are going to do is, basically we are going to RStudio, and we are going to say gg import our data first, data mpg, and then we know this is from the data car data. So we say package car data, and let's say press enter, and we are not getting the mpg package data. So let us see which package is this is in. So it's inside the ggplot2. How you could say this, because it's inside this package I have inside the ggplot2 package. So now let us import our data to ggplot2, and then what we need to do is, we basically need to say ggplot, then we pass our data to be mpg, and then we say aesthetics for the mapping. So x here would be our city from the mpg data set. We say y is our class, basically which type of car it is, sedan or sedan, SUV, etc. So we say class, then we say fill it by the class volume, so class. And then what we need to do is, basically call our geom density ridges. This will import our library, and let us run it. Here we get our data set. We could see the density for two-seater we could see that for two-seater, it's mostly highest city mile is for subcompact and city mileage. And then we could see next we have SUV, max city mileage, and then we have also similar to close, or you could say more than mid-size and compact. And then we get minivan, pickup, and two-seater. Basically it's more of speed rather than mileage, so it's very less. So we get our data set. What we could do is we could use theme bridges. Let us use theme bridges to improvise it. And let's say basically it's for spacing and spacing of the data set. So let us save it, run it. We get our beautiful chart. Now let us look at what is strip plot. So basically in quantitative versus quantitative data, we looked how you could plot a scatter plot, and this could be also done for the categorical data and a quantitative data. And if you could plot this, we get a strip plot. So if we zoom in this plot, basically it is a scatter plot in which we pointing all the points here. And here you could go through the definition. Basically it's saying the relationship between a grouping, which is a categorical data variable, and a numerical, which is a quantitative data, can be also displayed with a scatter plot, which is known as strip plot. So basically it's very simple. Let us open our. Now first we will import our favorite library, that is ggplot2. Then we need to say ggplot2. First we need to import our salary data, and in this data we need to get our data set. So we say salaries, then package, from which package it needs to be imported, car data, and then we say ggplot. Let us first get our data set, and let's see from which we need to plot. So what we could do is we could plot rank versus salary. So one categorical data and one quantitative data. So ggplot, then we say salaries, we say then aesthetic of mapping, y is equal to rank, then we say x equal to salary, then we say geom points, pass the method, we run it, we get our geometric point. What we could do more is we could add title to it. We could say title, we could say strip plot, or any other name, salary distribution plot by rank. We could also name it like that, but for our simplicity's sake we could say strip plot, and we got our plot. Basically you could see all this are point scatter plots that have been for a numerical and a categorical variable. Now let's see how you could plot a Cleveland dot charts. So before we start doing plotting Cleveland dot charts, we need to know what is Cleveland dot chart is. Cleveland dot chart, basically it's a dot chart. Basically we plot the points, but it is useful when you want to point a large number of numerical data with respect to a large number of grouping data. So for example, if we need to plot Asian country with respect to the life expectancy, so this is a numerical data and Asian country is a categorical data. So here we have a lot of huge data set, so we could use our Cleveland dot charts. So basically Cleveland plots are useful when you want to compare each observation on a numerical variable or compare a large number of groups on a numeric statistics. So when you have a large number of category, or you have a large number of numerical data you want to compare against with categorical data, or vice versa, numerical data. So it should be alternate. If it's categorical, then you want to compare it with large number of quantitative data, similarly vice versa. So how we could do this? Basically, So what we are going to do is, first we will import our favorite library, that is ggplot2. Then we are going to import our data. So we say gapminder from package gapminder, and then we will run and see what we have. 1704 observation, you could see it's very large. So what we'll do is, we need we'll plot the life expectancy of continent Asia, and we will take year only 2007 for our Cleveland dot chart. So what we will do is, we're going to first save it, and then we need to import or another favorite library, that is dplyr. What does dplyr is used for? Data manipulation. And we create a new name, that is plot data, and we say filter plot data, which is imported from dplyr package. We pass our data gapminder, we say gapminder, and we need continent is should be Asia, and then if the continent is Asia, the year it should be for 2007. Now let us see what data gives us. It says continent is not found. So here is our spelling mistake, and we need to fix it, and continent and is missing, and then we could save it. We could get our plot data. We could see, if we want to open, we could get all the data set that is from year 2007. And to plot this, we could easily plot similarly how we plot strip plots. We need to use the similar method. We call ggplot. We say plot data, and for the aesthetics we say x, or could be, we are going to plot it against the life expectancy against the country. So we need to provide x to be our life expectancy. So we get our hint suggestion, y is equal to or country. So we say country. Now what we need to do is, we need to say geom slash point, and we save it. We get our plot. We could beautify this by using labs, and here's a challenge you could take yourself. Basically, you need to use labs method and provide a title to this plot. Here we have large number of data set, which is categorical, and then a numerical data set we are plotting against which. So that's why where Cleveland dot chart is very helpful. So with this, we could wrap up this lecture of bivariate data visualization, and in the next lecture we are going to look at the multivariate charts. And with this, I will see you on to the next lecture. Thank you everyone. Hello everyone, welcome to the R Masterclass lecture. In this lecture we are going to look at how you could plot data visualization for the maps. So basically, data sometimes contains geographical location, such as for data set, if you take data set for COVID, it contains data of, for example, it would contain data of the geographical location coordinates, and if you want to plot it, it would make bigger sense if you plot on the map, because if you plot on histogram, you could get and identify the trend, but if you directly plot on the map, you could see the trends directly onto the map, and you could visualize it way better. So basically, data often tied to a geographical location. For example, if you want to have some data regarding traffic, it would contain some geographical location. Similarly for COVID or life expectancy by a country, these would generally would contain data that is often tied to a geographical location. For example, if we want, here is a data visualization on map for the landslide in India, and here you could easily identify that this area is much more prone to landslide. Similarly here, these areas are very prone to landslide, and similarly outskirts of these area are prone to landslide. So viewing data directly imposed onto a map can help you discover important patterns, outliers, and trends, which could help you to identify patterns, trends, and etc. So it could also be an impactful way of conveying your information to the other people. Once you are in research, if you want to show your research to other people, like, it is better to show on to the graph data visualization, and if it includes uh, geographical data, it would make much more sense to show it onto the map. So in order to plot data onto map, you need to find the position information that ties to the location, and typically in position information is provided into the streets. For example, in which street it lies, or it would contain geographical coordinates, latitude and longitude, or the name of the countries or cities. So now I have lot of libraries that could help to uh, convert your data directly onto the map. Now let's see which library would help us to convert this into the map. Now we are going to look at what are the libraries that we are going to use in this lecture. So first we are going to use tidy geocoder. We are also going to use at ggmap. Then we are going to use mapview, then chloroether, then sf libraries. Mostly we are going to play with mapview, and once in so so here are the following libraries that we are going to look onto. So the first one we are going to look at is tidy geocoder to convert your um, data directly onto the geo coordinate information, which will be much more clear in few minutes that we are going to use onto. Then we are going to use ggmap, we are going to use mapview, then we are going to use chloroether, and then we are going to use sf. Basically these are the 5 popular libraries used for map, and generally there are a lot of mapping libraries, but these are the 5 that you are going to use most. So now let us see how you could use this. So now let us see use tidy geocoder. So what is tidy geocoder? Basically what it does reverse geocoding query. So what you could do is basically you could provide them your address, like where you live. For example, you live in Mumbai, India, and it will reverse geocode and provide you the latitude, longitude of that area. So now let me open my uh, R console, and here I have opened my R console. Now let us see how you could use tidy geocoder for reverse geocoding. So basically you provide the street area and you will get in response as a the location. So first we will clear our console. Control L. We will remove all the variables. So first, what we need to do is we call location as a vector, and in this we could need to provide the address. The first thing we will provide is the country, and then next thing we need to provide a city. For example, we could provide the city. So it's a column, and we create the values for it. So we'll add values for countries, for example India, and then city Delhi, and we could see what the geolocation is for that location. So now we need to create a address for this, which will contain the values for this, for above statement. So concatenate, C is for concatenate. If you remember, it concatenates the value. So for India and then city, we are going to have Delhi. And then what we need to do is we need to create a data frame. So to create a data frame, we remember the method data frame, data dot frame, and then we just need to provide the rows name and columns name. So it will create the data frame for us. So we could say location and address. So let us see if it's correct. And if we open it, we could see that the country is India and city is Delhi. So it is correct. Now what we need to do is basically we need to add the do the reverse geocoding. So basically get the geolocation for this. So basically for this we know that we need to import our library uh, that is tidy geocoder, and in tidy geocoder, and in this there is a method known as geocode that will get or do or reverse geocoding. So we'll call first we will add this value directly to our data frame, and we'll call tidy geocoder, and in this we call geocode. We provide our table that is data frame, address is our address, then in the city we don't need to add, but the method we need to add, and this method would be our OSM, and what it basically fetching all the data related to the address that we have provided. And let us see, it have completed, it is on 100%. And here if you open our data updated data, we get the latitude and longitude. Now, and if you are wondering what does method OSM is, basically it needs to get location from any service provider, and we are using OpenStreetMap for our service provider. Basically, if you go to Google, and here if you search for OpenStreetMap, and here you could get, this is the free wiki world map, and it contains all the geolocation of the country and state. So it is basically saying, hey, give me the geolocation of this area that the city and state we have provided. And you could define more, you could add your real location and get your geocoding. So this might be a task for you. So what we need to do is, now we need to do we need to do a dot density plot basically for our Houston dataset. And before that, let us see what is dot density plot and which is the Houston address is. Now let us see what is dot density plot is. Basically in dot density plot, what we do is we basically have dots to represent the concentration, and basically in dot density map, areas with many dots represents the high concentration of values for the chosen field, and fewer dots indicates the lower concentration. The higher the dot, higher the concentration, the lower the lower the concentration. And here you could see we have higher concentration here. Here we have also higher concentration. We also have higher concentration in this area, also in this area. So general rule is, the higher the concentration, the higher the value is for that area, particular area, and the lower the value, the lower the concentration for particular area. Now what data we are going to use? We are going to use ggmap data. In this we are going to use the crime data set. Basically it contains the housing crime data set from January 2010 to August 2010. So for this, let us see how, let us import this data set in R. For this, what I will do is basically clear my script, will remove our console, I will remove the environment variables, and now what I will do is I will first import the data. So to first import the data, I will call data, and here I need to call the crime data set, which is inside the package ggmap, and let's just see that what the data set contains. So if we run it, it's saying it's running. Let us see if it's available or not. So we got our data set. It contains geographical location too. So we have block, premise, offense, street type, suffix, month, date, location. So it's good for our geoplotting. So what we are going to do is we are going to plot this. So first what we could do is we could first import our library to plot this. So first we are going to use the ggmap library. And what is ggmap library? It is used to plot the data set directly onto the map. And let us see its documentation first. So basically here's the documentation, and you could see it's from the CRAN project, Comprehensive R Archive Network, and it provides the raster map tiles, basically vector tiles that contains the data details uh, of the location that where it is from. So basically it's used for mapping services. You need to use either Google Maps, which is paid, Stadia Maps you need to register and then get it. OpenStreetMap is useful. You don't require any API, so required any key for API key. So we are going to use OpenStreetMap for this. And here you could see that for Stadia Maps, if you are going to use the get the location from the Stadia Maps, it needs to require API key, and similarly for Google Maps. So basically OpenStreetMap does it for free, so we are going to use that. Now let us open our console, and what we are going to do is first we need to import our favorite library, that is ggmap. And what we need to do is we need to filter the data based on the homicides. So we are going to plot it only for the crime that is done for the, let's say, for the offense murder. And to do this, what we need to do is we will call our first library ggmap, and we will create our homicide variable, and in this we will filter it. And before that we need to import our library for to do this, that is dplyr, which contains the filter package. And then in this we will provide crime, and we'll say offense is equal to murder, and then we'll run it. We get the crime, and let us see what the data set contains. So in this, all the data set for homicide, it contains the offense murder. Now what we need to do is we need to plot it. To plot it, we need to have a library that is known as map view, that will plot this onto the map. And let us see what is map library. So for this, to plot in our data frame into interactive map, we need a map view library. That what it does, it creates a interactive visualization of spatial data with or without background maps. So this library we are going to use to map our data set, and we are going to use also SF. So SF stands for simple feature for R. Basically what we need it for, currently our data set is in data frame. So if you look onto our data sets, it is in type of a data frame, and this is not accepted by the MapView library as parameter, so it needs to be converted into simple features. And which is what it does, it's a way of encoding data into a spatial vector data, that it what we are going to use it for. So now let us import our library first for this library, and then we are going to use MapView. Then we are going to use library such as SF, and then what we are going to do is my map, and then from SF we are going to call a method st as SF. Here you could convert foreign object to an SF object. Why we need it? Because to convert our homicide data into SF object. So what we will gonna do is we call homicide. Then we are going to say coordinates, and in this, what we are going to do is we are going to provide our coordinate, which is a vector of lat and longitude, basically longitude and uh, yeah, and latitude. Then coordinates is of latitude. Then we need to provide coordination reference system, which is basically the standard way of notation of the spatial data set. Basically, you don't need to worry about this. Only general method to the represent the coordination space. And if you search for in the internet for CRS4326, it's basically a general way of representing the data set for the globe. So what does CRS means? Use latitude and longitude to specify a location on the surface of Earth. And what we need to do is we will call map view, and here we will call my map, and here is a typo, and then we call map view map, and then let us see our map. So viewer, and here we get our data set for the house. Then that these plot you could see here are the density plot representing the value. You could see here the density in this area is way bigger. Let's see, here you could see 129.65, and basically it's only for the data set contains the location for Houston data set. That's why it is only for Houston. And you could see these all dot plot is for criminal crime rate, and you could see in the Houston middle part the most of the crime scenario is in there. Basically in this street also, in village, we could say that most of the uh, criminal activity is there, which is a type of a murder, and it's on the main street. Now we have seen the plot. Now it's time how you could use other method, how you could beautify this plot. Now let us see what parameters does my map accept. So my map needs to get the data in the SF format, and what other parameter we could do. So color, what is basically is for basically the outline color of this dot, and we could say let us keep it as black only. And now what we could do is for color dot region, we could set our color, let us say red, and it should be of type string. And then we need to provide the transparency level, which is called by alpha dot regions, and then we could add it to be 0.7. We could also change the type of map, and let us keep the type of map to be type of like OpenStreet. And to do this is we call map dot types, and here we call the or map OpenStreet map, and as it needs to be in the camel case. Let us save it, let us run. Colors matched by multiple match argument. So let us see here. This needs to be color instead of colors, and once we run it, we get our data set to be used by it's the type of map is OpenStreetMap, and here our data set is represented in OpenStreetMap, and we have better visualization than previous one. Here our transparency level is 0.7. Either we could reduce it to be 0.5 just for better view. Yeah, now it's much more better for data visualization. And here we could see most of this crime rate are inside of Houston main capital. Basically this area is whole Houston, and the outskirts also have much more crime rate, and you could deduce many much more stats from this graph. So now we have looked onto the how you could plot the dot plots. Now let us see how you could plot a chloropeth. Now it's time to look at the chloropeth maps. Basically in dot density plot, we looked at how you could plot numerical values using dots. Chloropeth maps use polygons, basically an area, and use shading color to define the numerical values of that area. Now let's look what is chloroplet maps definition is. Basically, chloroplet maps use color or shading color to define the predefined areas to indicate the values of numerical values in that area. Basically, the higher the shading is, the more the value is. And here's the graph for a life expectancy, and which we're going to create in few minutes. Basically, here you could see we used the blue color to indicate the numerical values into the area. Basically, here you could see that the Canada have higher blue shade, and the value for that blue shade is higher, like basically 79.4 to 82.6, which is a range of life expectancy in that area, average life expectancy rate. Similarly, we have for USA, then we have for other country as well, and for black, which we don't have. Now, there are numerical ways that you could create a chloroplet maps, but one of the easiest way and industry standard is to use chloroplether package, and it is created by Aaron Lamonston, and we are going to use it to create our chloroplether map. And what do we do if we want to create a lot of customization? So in the end, we are going to use SF and ggplot2 library to customize those vector files and shape files that we get the data from. Once we call this packages, what it does, it calls hey Google API or open source map, and basically it asks for uh, ask the API to give them the data of that particular area, which is a vector tile that contains the information of the road, all the area geocoordination location. And we don't need to dive into what is vector file vector data for the maps. Basically, it contains all the logic for the creating the map tile or raster tiles, which is basically a map. And to customize it, we are going to use SF and ggplot2 libraries in the end. Now, let us start by doing the data by country challenge, and let us see what data we are going to use. So for our data set, we are going to use Gapminder data, and already we have come across this data according making a lot of plots on it. So basically, we are going to use this data set to evaluate the life expectancy for the year 2007. So now let's open your RStudio to code this out. Here I have opened my RStudio. What I'm going to do is clear my console, clear all environment variables, and next what we need to do is, once we have clear our console, I will be importing the library that we need to use. First, we are going to use chloro ether, and it contains a function that is chloro country underscore chloro ether. Basically, I want to explain about this function, and once we press F1, it imports the documentation for that function, and basically it requires df, that is a data frame, and it should contain a region and a column name value, and uh, one of the other thing is in the region and all the country must be in smaller case, and it should be in standard naming. So for United States, US, it should be United States. For the Korea, it should be South Korea, and North Korea, it should be divided into. Similarly, for China, it shouldn't be Republic of China. It should be Republic of China (PRC). It should be China. So what we need to do is, in our Gapminder data, it's not like that. So when we code out, we will look for that change. So first, we will need to import our data, that is Gapminder. So we'll import the data that is Gapminder, which is inside package Gapminder and once I save it, run it, uh, I got my data Gapminder, and here you could see uh, there's 1704 observation. We are not going to do for this all year. Basically, we are going to do it for year 2007. So we need to use deployer package. So for this, we will import our deployer package. Why we need to do import deployer package? Basically for data manipulation. And now let's create a variable plot data, which is a new variable which contains gap-minded data for the year. Let's get the year to be for the year which is 2007. So now let's see what does gapminder plot data contains. So basically it's saying can't okay, so basically we need to also have a one comma that I missed. In the square brackets we need to have one comma. If we missed it, say we don't know how to, the compiler is giving error, that is logical subscript. So basically once we need to get the data manipulation, we need to add the comma. And plot data basically contains 142 observation, and here you could see some changes needs to be done based on Hong Kong. It should be changed to China, or it should be China. And let us see what changes we could do. Yeah, similarly for Korea Democratic Republic, we need to make it handle those changes as well. We need to make it for North Korea or South Korea. So let us code this out, plot data. And one more thing we need to do is we need to have the value to be in the lower case. So what we are going to say that plot data, and in this we just call a function that is known as toLower, and we get the data for our country. Now the country will be in smaller case, and now this needs to be saved in the region file, because we are creating a data frame that have a region and a column. So for region we need to add this column region, then similarly for plot data, and we need to create a value, and then in this we will add the values for the life expectancy. So we need to get the life expectancy, and let me check what's the column name for life expectancy. So life exp, and basically yeah, it says that so basically it says life expectancy uninitialized column, and basically we had a typo here, and we got our life expectancy saved for the plot data values. And now we need to handle this case for United States, Slovakia, Korea, Congress of Republic. So I have already coded this out. You could see this. Basically I will go through this at what I have done. And what I have done here is basically taken those code that is not in standard format and converted into the standard format. For example, United States should be in form of a United States of America. Congress, Democratic Republic should be named as Democratic Republic of Congress. Similarly, for Yemen, Slovakia Republic, it should be Slovakia. Serbia, it should be Republic of Serbia. And once we are done, we could hit enter, and now our data frame is ready. It contains or plot data contains a region and a value that we need to plot. And basically you could see that it requires a region value to call this function, that is country chloropret to map. Now once we have ready this, we will just give the we'll give this function country chloropret, and then we just pass the plot data, and let us save it and run it, and we get our maps. Here we have some warning message that your data frame contains this some countries you could see that have been missed. The following were missed because some data were missed because their data was no data was available. For example, for China, for Guyana, Luxembourg, Laos, Kazakhstan, because and they have been plotted black because their data wasn't available. Here we have plotted out, and in the starting of the lecture we have already seen that it is now we include with app maps. We plot based on the shading or a polygon area, and in dot density plot we use dot density to indicate the numerical values. Here we are using shading color based on blue to denote the value levels. So here we could see the Canada uh, have more life expectancy. Australia also have more life expectancy, and it's for year 2007, and now it might be changed. So what we could do one thing more is we could add a title and subtitle to it, and we could change our color too basically. And for doing this we could pass num colors and a value 0, a divergent scale used for value from. Let us open the documentation itself to get the what value does it include. So the value number using, so if we call num colors, the num color of used to use on the map. 0 uses a divergent scale useful for visualizing negative and positive numbers. A value 1 uses a continuous scale usually useful for visualizing outliners and quantiles value. So we have to use any value between 2 to 9 basically for our quantitative value which we have, that is expectancy is a quantitative value. So we could use 2 to 9. Let us use 9, and what we could do is let us see how our map is. Now let us see. Here we have no changes right now. Let us see. Let us run 2. We have now we have outliners only till 2, basically 71 to 39.6 to 71.8. Let's say what if we do the outliners for 6, and we have 6 outliners, basically 3 for this and 3 for above and rest for 9. Similarly we could do for 9, and what we could do, one more thing is to change the color of this basically, and to do this we could call a function scale fill brewer. Basically we need to provide color padding to it, and there is a standard padding color code, that is YL or O RD. Basically, this is the standard color code, and I have taken this standard color from online, and I'm just looking into it. And here it provides standard color palette, but it's not showing. So the issue was that we need to call a parameter in scale fill brewer, that is palette, and in this palette we need to provide our color code. So basically, previously we were not providing that method. That's why our code was breaking. Basically, color coding was not applied, but we need to provide a color code in the palette member, not a generalized way. So why? And then the color code is L, capital O, R, capital R, T. Then it will run. And now we could provide a title to it, labs, and the title life expectancy for the year 2007. Now let us run. We get the life expectancy. You could add a subtitle to it. You could add also caption to this plot, and you could make this plot much more descriptive. So now in our previous plot, we looked at the data by country. So basically we have the data set and we represented as a polygon area, and which is a choropleth heat maps, but we have a data which contains a data frame of a country, and we use a function that is choropleth at country function, which does all the handling for our data visualization. Now what to do if we have data by state? So for this, choropleth each bracket provide the similar kind of function. We need to call state choropleth each function, and in those we need to provide similar to country choropleth each function. In this we need to provide a region and a value. So we need to provide those things. So to plot this, we just need to provide that requires the data frame. So we need to provide them the region and the value that we need to map. And this needs to be in lowercase. Also, this needs to be in the standard format. That is, it should not be in short forms. It should be in their long forms, how they are mentioned. So country should be in their standard name. The state should be in their standard name. So for this, we are going to use df pop state, and it contains population of estimate for US states in 2010. So what we are going to do is, let us create a new file. Let us save it by the name state by choropleth. And then what we are going to do is, first we are going to clear our console, Control L. Then going to remove all the environment variables. And then what we are going to do is, we are going to first import our packages. So for this, first we need choropleth eth, and we also need our library choropleth eth maps that contains the map. So let us see what are the data that it contains. So df state, and if this we need to call pop, df pop state, that contains the data set inside this is inside the choropleth ether package. And if we look at onto it, we get 51 observation, which basically contains the region and their population. So what do we need to do for this? So basically, in this we don't have to handle the edge cases. That is, that if there is they basically already in lower case, so we didn't need to handle that condition. So we could basically call state choropleth eth, and then we could just provide our data set df pop state, and then we could say let us map this first and then see. So we get our shade, and it basically contains 9 outliers, 6 outliers, 3, 6, and then the basic one. So we have 6 outliers. So let us see if we add outliers for only for 3. And this is how it looks for outlier 3, but 6 is good. So we are going to keep it as it is. And now let us fix our color. So we are going to call scale fill as previously we called brewer in our for our country chloropeth we called this same thing. And then in palette, if you remember, we need to provide the color code, that is YLOO capital R and D basically contains, and it's saying that it doesn't find able to file scale fill brewer. So let us see is it and we import our ggplot2 library, which is inside contains the function for scale fill brewer, and we get our population heat map, you could say that. And mostly the population lies in the outliers of the water body. So here you could see Texas, California, Florida, uh, New York, Michigan. These all state contains most of the population, where the water is much more easily available rather than the inside of it. Previously, we looked at how you could use chloropeth map package to create a chloropeth map. Now, this is always not true. You want to have more control over your plot or your map plot. So you could use ggplot2 packages, but to use it with ggplot2, you need to use sf package, and sf package requires a shapefile. Basically, a shapefile is a data format that contains vector features such as point, lines, and polygons that is used to draw geographic boundaries of the map. Basically, it contains the information that how does the map look like. And for this, we are going to use this we are going to use this data set, that is United Census Bureau. It provides shape files, and we could use a 2.2 MB file. Basically, it's enough for us to do the data visualization. But if you need more data set, you could get those by adding more data to your data set. So what you need to do is just download this file. I will provide this link to the video description, so you could download the link. Now once you have downloaded it, now let us open our RStudio. Now once you have downloaded that folder, you need to change your directory. And to change your directory, you need to come to the files and where you have downloaded. So I have downloaded in files, and here's my US downloaded data, and here's a code that I have taken from online. What it basically does is it takes the shape zip file and extract it, and there from inside it there is folder that is this folder CB2023 US state, which contains a shape file and extract it. And here we have all the shape files. Basically, it all contains the shape file, also needs these other files because it contains all the other data. So once we run it, we get all the data. Now what we will do is we will use ggplot to map this. So we will call ggplot2, and then we will call ggplot, and then we have the data, that is US map. Let's say US map. Then we need to say that it's a SF plot, that is simple plot files that we are going to use. So we have shape files, so it is going to use SF plot to plot it, and then we need a theme. You could say a minimal theme, and let's see what we get. So we get our plot. Let us see if we have a better theme, but it's okay. Let's see if we could say classic theme, if it's, yeah. But here we have got the plot, and basically you could also add title to it. And here how you could, this is how you could plot a using ggplot, sfplot, and based on your plot, your sf other plot would be shown. With this, in our next lecture, I will see you with the time series plot. With this, thank you everyone. Hello everyone, welcome to the R Masterclass Data Visualization lecture. In this lecture, we are going to look at the time dependent graphs. So previously, we looked at the map graphs, in which we looked at the data frames, and in that one data frame should contain a map location or some data about location, so that we could plot map graphs. In this lecture, we are going to look at the time dependent graphs. So what is time dependent graphs? So the data you want to plot should contain a time dependent data frame, and this is a very powerful way to display the change over a time period. So for example, if you want to show the market capitalization or stock price of a stock based on the time period, the time dependent graph is one of the most suitable ways, and in this a line graph method is very suitable method. So in this lecture we are going to look at some time dependent graphs, how we are going to plot time dependent graphs, and in this we are going to look at first time series, then we are going to look at dumbbell graphs. And if you are thinking if the spelling is wrong, no, it is also particularly called dumbbell graph with double M and double B. And then we are going to look at slope graphs, then area charts and stream graphs. So let's take an example of time dependent series. Here is stock price for Nvidia, and here you could see time dependent graph. So you could see that over the period of 2024, the Nvidia stock have gained a lot of traction in its stock market, and you could see that over the period it have grown over 2,628.4% over the period. Why? And it's you could visualize this by a time dependent graphs. So now let us see how you could plot this. So the first one that we are going to look for the time dependent graph is time series. So for the time series, basically what a time series is basically we have values, quantitative values at certain interval of a time. Basically it could be hours, days, years, week, months or years. Basically here you could see for the population we have these the time dependent graphs, and it's a little complex if you see, because this is for Europe and this is, and for to map this you need to look for here, and for population of Ireland, look at the population, you need to look at here the x intervals. And basically for the you could see that generally for Europe the population is increasing, and basically in time series you need two things. You need a quantitative values for a particular successive time. So for this, for the example of time series, we are going to use a data set from the ggplot2, that is US economic time series. It have 574 rows and 6 variables. Basically data, personal consumption, expenditure, and median and unemployed. So what we are going to do is we are going to calculate personal saving rates, and basically we have the data month of data collection, total population we have personal saving rate, and then we have unemployed, number of unemployed in 1000, and this data is from 1975 to 2015. So we are going to map this. So now let us open our RStudio to plot. What we are going to do is, first we are going to create a new file name. So let me select it, Control Shift N for new file. Let us save it and let us name it to be time series. And then what we need to do is so first we will clear our console, Control L. Then we'll remove all the environment variables that we don't need, and then we are good to code. Now once we have cleared our console and increased our script menu, what we are going to do is we are going to call our favorite library, that is ggplot2. We are going to import it first. So to import this, we need to call method library, and then we call ggplot2. And we have now you should be comfortable with importing all the libraries, because we have already imported lot of libraries. And then we need to import data, and in this we need to call economics, if I spell correct, economics. So it should be economics, and then it should be imported from the package ggplot2. And then once we have imported it, what we could do is we could test run it. Now sometimes the issue with R is that once it imports data, it have promise, if you click it, it automatically gets all the data. So here we have got the data, and we will see the data. So we have got our date. That's good. So we are going to plot this against the personal saving rate. So for the personal saving rate, we have to go to the personal saving rate, that is this. So let us see how we could plot this. So to plot this, what we need to do is, we remember that we need to call method ggplot, and in this we need to first provide our data, that is economics, and then in the aesthetics we need to provide x is equal to, which x would be axis would be our date line. So in this we could provide the date, and in the y thing we could provide our personal saving rate, which is personal saving rate. Yeah, this is correct, we got the hint. Now what we need to do is, to have a time series line, we need to call a method, that is geom line, which will plot our line plot for this. And once it's done, let us see how our plot look like. So it's saying that gmo plot does not found because there is a spelling mistake. Let us see now. So we have got our plot, and we could see that it is generally a downtrend, and then there is some uptrend in 2000 from 7 to 10. So what we could do is, basically we could also improvise this. So what we could do is, first any plot should have its title, like what does x-axis shows, what does y-axis mean. So if we look at the first thing, date is generally understandable, and PS Abbott, if we show this to the third person, he would definitely not understand. So for this we always need to have a title for our plots, and to do this we call labs and we call title, and this we could name this plot as a personal saving rate, and rate. Then in the X we could say it's date with capital casing. Now for the Y, it's personal saving rate, we could name it as personal saving rate. Once we could save it, our graph is much more describable. If we show it to third person, he could much more betterly understand. Now let's see how we could improvise this graph. Now let's see how we could improvise this. So the first thing I have issue with this is my x-axis. So if you look, I have hard time difficulty like that it is break into like 10 years. I need it to be at least by 5 years. So how we could break down the x-axis into 5 years interval. So to do this, we need to call a method for this, that is scale x date, which will break this into a particular time period. So to do this, we call scale x and date. And if you need to go about the documentation, let us go through its documentation. So that we need to provide is date breaks, that what when we need to break the date, and then we need to also provide labels, that how the data should be formatted. Else, other thing we could also provide, but it's going to take all the default values for those. So for for the breaking of this, we need to provide date breaks, and the date breaks, you could see that it needs to be a string in which it needs to be break into two parts. That is, first one is a numeric part, and second part is the week, month, year, the interval part. So for us, we need to break down it into 5 years. We need to get it for the 5 years. So how we are going to break this? Date breaks, and then we say 5 years. And for the labels, we are going to have uh, it by month and then year. So for doing this, we need to have a format that we need to call labels, and the format needs to be called date slash format. And basically in this, you need to provide a regex expression, that what it does, it provides the breaking of the month and year. So basically slash b is for the month and percent y is for the year. And then we could save it and see if our code is working or not. So basically it's saying that date format is not found, and basically it's inside the package name scales. So we are going to import that package scales, and here our plot have been broken down into 5 years. And personally, I don't like the black color. I could do it in a much more we could use a much more better color. Let's say we could use our favorite color, cornflower blue, cornflower blue. And then what we need to do is, so now it's correct, and now what we need to do is we need to provide the size of the point. So it would be a standard point, and let us see how it's now. Now it's uh, now it's looking okay. Now what a general method is to have to draw a smooth line, so that we could get some representation out of it. Basically a smooth line to denote what's the trend is about. So for this, basically it smooth out all the value for the particular period, and it draws the curved line. So we could call smooth, and then we have our line. And basically we could change this blue color to, let's say, Indian red, and we have now much more better representation of overall trend what is happening. So now we have looked onto the time series plot. Now there's an assignment for you. You need to plot this plot against, let's say you need to plot against this unemployed, this column. And once you posted this, you could post the result onto the question section or onto the comment section of this channel. With this, let's move on to the second series of plot, that is dumbbell series. Now it's time to learn about dumbbell charts. So what exactly is dumbbell chart? So basically in dumbbell charts we have the difference to plot it. So basically we have 1 point, and that is extreme point, and then the latest current point, which for the current distance. And this difference shows the difference. So if it's the larger the line, the larger the difference. The shorter the line, the shorter the difference is. So basically, dumbbell charts are useful for displaying change between two time points for several groups or observation. And to use this, we use Geom dumbbell, which is inside the GG guard package. So using the gap-minded data, we could, like for example, in this data set, if we need to predict that, we could see that for Haiti from the year 1952, there is not generally increase of the life expectancy. You could see that still after 2007, it's still around less for uh, compared to all this country. The Haiti have less life expectancy, whereas you could compare of like Ecuador, like El Salvador, it was less, but after that in year 2007, the it's have generally improved compared to the other countries as well, which was very less in 1952. So, which data we are going to use for this example? So, for this example, we are going to use gap-minded data. It contains following data, that is country, continent, year, life expectancy, and population. The one reason we have to change we are going to change the year into wide format. Basically, each year will have their own data frame, that what is wide format, because to plot dumbbell plot, we need to basically transform the large format of the year, basically month year, into a wide format. Basically each data row for each year. So basically it will be once cleared once we transform it. So now let's open our RStudio to do this. Let's look at the dumbbell charts. So basically we are going to use dumbbell charts for basically to show the change between 2 points. So basically in dumbbell plot we have 2 points, that is this first point, we called it male, and this called it female, and the line basically indicates the difference. The larger the line, the higher the difference. The shorter the line, the shorter the difference is. And third, geom, to plot this, we need to have a library package, that is geom dumbbell, which is inside the GG guard package. So dumbbell charts are useful for displaying change between two time points. So basically we have 2 points and in certain interval, and we have a lot of several groups. We could display a lot of groups. For example, we could have different countries. Based on it, we could do this for similarly continents and so on. And to use this, we need to have geom dumbbell package, which is inside GG alt package. So basically here you could see change in life expectancy, and it's for continent America. And you could see, for example, here you could see the Haiti in the year 1957, it's have lowest life expectancy from compared to all other, but still it haven't improved. Whereas if you could look for El Salvador, you could see that it also have less life expectancy, but generally it tend to increase compared to the other countries. So for this, we are going to use gap-minded data set, and it's from 1952 to 2007. And here is our data set, which is inside the ggplot2 package. So sorry, it's inside the gapminder package. So if we want to import, it's inside the gapminder. Now the year which is lies is from 1952 to 2000. Basically this year needs to be changed into wide format. Why? Because what is wide format first? Basically each year would have its separate column, and it would be better visualized once we code it out. So we are going to transform into the wide format, and then we are going to use our dumbbell plot. So now let's open our RStudio, and let me clear all. And now first let us import our library, and here first library is GG alt library that we need to import. Then we need to import our library, that is we need to import dplyr package for data manipulation, and also tdir package for converting into the wide format that we are going to look into. Yeah. Now once we have imported it, let's just save and import all the data. And now it's time to import the package data, that is Gapminder, which is inside the package Gapminder. And now let us save it, run it. It's saying that it's not able to find Gapminder data because there is a typo. And now we have got all Gapminder data. There is sometime issue with the RStudio that this data, once it retrieve it, it might get you showing the promise, but once you click on this data set, it will fetch all the data. Now once we have imported our data, now let us see what are the data we have basically. Now here we have got all the data. We have country, we have continent, we have year, life expectancy, population, GDP per capita. So what we need to do is we basically need to map life expectancy versus year. For dumbbell, we need 2 points. Basically, first point we are going to take as a lower extreme, that is 1952, and the upper extreme we are going to take it as 2007. And then we are going to format this into byte format. So first we have imported our data, and then we are going to create a name plot data, which is basically contain all the data, and the year would be in the long format, so plot data long. And then we are going to use filter to get the continent Asia and the year in 1952 to 2007. So first we need to provide the data in the filter. Then what we need to do is continent, where the continent is Asia and the year is in lies between 1952 to 2007. Save this, run it. Continent have been not found, so let us check the spelling once. Here we have a typo. This should be include one more n. So continent, and then we run it. We get our data, plot data long. So basically we have 66 observation, which is okay. Now what we need to do is we need to select only the relevant data, that is country, year and life expectancy. So what we could do is basically take all that data in it. So we are going to provide plot data, and we just need to select from plot data only country. We will take country, we will take year, we take life expectancy. That's all we need. So rest we don't need. So plot data is not found, so that is plot data long. So let us fix the typos, and we have got our plot data, which includes 3-way columns. Now once we have got, the issue here is that it's in the year is in the wrong format. So we need to improvise this into the wide format. To make it in wide format, we need to pivot this data so that each year is a column. So we will need to use dplyr tidyr package for this, and let's see how the expression is for this. So plot data wide, that we are going to use, and then we call pivot wider. We need to provide the data plot data long, and then in this, which column we need to add from is from year, and then values is taken as life expectancy. So if we look at plot data wide, we have got 2 new variables, that it includes the year for the long format, wide format, sorry. Now once we have this data, what we are going to do is we are going to fix the naming convention, that is plot data. So this was some naming error. We'll save it, run it. What we are going to do next is, once we have got the plot data long, we need to change the variable name. So for this, so for what we could do is called plot data wide, basically plot data wide, and in this what we need to do is change the column name to country, and the extreme point will be, let's say, year 1950. We are taking extreme point is from 1952. It should be a string, and year till year 2007. Now save it. We have renamed the plot data wide name. Now we just need to plot it. So what we are going to do is we are going to call ggplot, and we provide our data, that is plot data plot data wide, in this which we need to provide. Then in the aesthetics we provide our y axis to be country, and the x axis would be our time, and the x end should be our ending variable name. So y is our country, the x part would be our 1952, the x end part would be the ending part of the year 2007. And then we could say that we need to plot using the geom dumbbell, and here we got the plot for this. So basically here is from 1952, and you could see that there is generally not very good increase from Afghanistan to from till 2007. Now what we need to do is, let's beautify this plot so we could understand it betterly. So what we are going to do is we are going to add this into new line, geom dumbbell. What we are going to do is we need to add size for the dumbbell ending size, for size x and size end, and then we could add the color, we could add x color, we could add x end color. So let's add the size, and let's the geom dumbbell size, let it be, let's say 1.2. Then size x, the size of the start point, let it be, let's say 3. Then size x end, which is the size end, make it same size end. We provide color, which would be, let's say the line color should be gray, and it should be a string. Now color x would be our starting point, let it make red, and the ending would be your blue. Let's see our graphs, how it's look like. So now it's much more identifiable. What we could do is we could add theme minimal to remove those gray background, so that we don't need anymore. Theme minimal, and here we add it, and here is our plot. So here we could see for country, for example India, you could see there is generally tendency of increase in the life expectancy. For Afghanistan, there is there is still the last one. For Yemen, there is a lot of increase. Let us see for the country China. So if you look, we could see that there is generally increase in the life expectancy, and which is 70 plus and more than in country India. And for the highest one, we could see that it's for country Japan. And it's true that technology advancement have been there, so we could deduce a lot of facts from this also. Now we have got an idea. Now it's time to look at the next graph, that is slope graphs. Now let us look at what is slope graphs. So basically there might be some time you need to plot, instead of pointing to plot two data points, two data time points. In the dumbbell case, we have the two time points, that was x start and x end. There could be several points. So to map this, we use slope graphs. So when there are several groups and several time plots, a slope graph could be helpful. To plot this, we need call a new slope graph, which is inside CGP function package. And if you remember, in the starting of this lecture, we have in the starting of this course, we have already installed this package. So in order to use the new GG slope graph, we need to provide following parameter: data frame. Then we need to provide a time variable, which should be a numerical variable to be plotted and must be a factor. What do I mean by a factor? Which controls, it should not be the independent case. It should be dependent on some data. And a grouping variable, this could be country, this could be other plot that we need to plot on the axis. So now let's see how we are going to plot this. Now here is my RStudio open. I will clear all my environment variables. I will clear my console, remove all the environment tabs, plots, and now what I need to do is, basically we are going to use gap-minded data set, in which we will going to plot it against 1992, 1997, 2002 and 2007. So basically from extreme end and some midpoints. So we first import library, and then we call CGP function, and so we need to filter out our data. So first we will import our gap-minded data, which is inside the package gapminder. Let me save it first. I will save it by name. Let me think. Slope graphs would be a better naming. Let us save it. And we get our data variable gapminder. Now what I need to do is create a data frame. In this, from this gapminder, I need to get I need to filter this by year. So I need to get the data for year in 1992, 1997, 2002 and 2007, and country. We could do random countries. So we are going to take 2 to 3 countries for this, basically. So for this we have enter or get our data. I will call filter year percent in. Basically this is a regex expression to get the data for that years: 1992, 1997, 2002 and 2007. We got our data, and then we need to filter it one more thing by country should include. We don't need to do it for all country. We will only include in this vector. Country should include in this vector, let us say India, let's say China, and we could do one more, let's say Brazil. Now we have got our data set. Let me check if the data set for the country name Brazil is correct. So I'm just checking. Yeah, so it's Brazil name is correct, because there is some time for their capital state is in S. So we have got our data, we have created a filter statement. Let us see if we are able to get our data set. Basically, one more thing I have to add is, basically we need to add a mutate statement. Let me add it, and what it does is, basically it mutates year by factor. Now let me run this, and I have got my data frame for the year 19 to this year's particular year for all the country that we mentioned it. So basically we have only 12 observation. That's okay. Now what we need to do is basically call news logger function. So what we will say is new GG slope graph df, that's our year, then we provide life expectancy, then we say country, and we'll check if it's running or not. So we get our life expectancy factor. Also, you could see we have not provided any labels, so we need to provide labels also. Labels title could be life expectancy, and we could run it. So we could also provide subtitle to it, and the subtitle could be for Asia and South America life expectancy. Asia and South America life expectancy, and let me save it, and it's saying that it needs a comma. Fix it, we run it, we get our. So we could see that China have highest life expectancy. As for all the country, all the country are still increasing. So here's we got the life expectancy. Now let us move on to the next one, that is area charts. Let us look at what is area charts. Basically, area charts are a simple line graph with the fill of the. Basically, we fill the area under it. Now let us see how you could plot this. So first, what we are going to do is clear the console, remove the data variables remove the plots, and clear our console. Now let us first we need to import our library, that is ggplot2, and then from inside this we call the we get our economics data, and we call ggplot line geom line, basically that which plots our line. So we call data, and from it we need economics data, and from which is inside the data. Sorry, it's inside the package ggplot2. Sorry, ggplot2. So okay, basically there was some string error. What happened is this needs not to be a string, it needs to be a statement basically, and this needs to be a string. And then once we run it, say ggplot2 actually, which is inside it, we get our economics. Once you see this thing like it's saying it's promised, basically it's trying to retrieve it. Once you click it, it's fixed it. I don't know, it's a bug of RStudio. Now once we have got our data, what we are going to do is we are going to call ggplot and going to do the same thing that we have done for our line time series plot. So basically geom plot, we provide the data to be economics. In this we need to provide aesthetics, and this x is equal to our date, in which our x axis would be our date and y would be our personal saving rate, and y is our PS award, personal saving rate. And then what we need to do is we need to call geom/area to plot it, and let us see. So Basically this needs a method, let us see, and we got our area under plot. Here's a challenge for you. You need to update the date and the PS award into suitable name. Basically date and PS award could be converted into personal saving rate. Now once we have completed this area graph, now it's time to look at the stream graphs. Now let us look at what is stream graph. So stream graphs are basically variation of stacked area chart. Remember, if you remember our data visualization series, we created a stacked area graph. Basically we also have stream area graph. Basically it's similar to it. We have age groups here and different age groups are stacked upon each other, and this is mirrored over the x-axis for other data sets. So for less than 5-year age group, you could see the US population by age. Now, I also want to show you the data set that we are going to use. So the data set we are going to use is US population by age. Basically, it contains 3 variables: year, age group, and number of people. And this we are going to plot on a stream graph. Let's see how we could plot it. So first, basically, we need to open our RStudio, clear all the details, clear all the environment variables. I usually clear all environment variable because it would sometimes it would create some interfere on your graphs. Basically, you define some variable, and if that variable already exists, then your graph won't be there because it will create some variable. So first we need to import our favorite library, that is ggplot, and then what we are going to do is we going to import ggstream, which this library resides in, and we need to basically use ggstream function to get this. So we call library ggstream, and now once we have done this, we call ggplot. Then we are going to get our data US population by age, and let us see if we are able to get the first data first. Let's see. So first we call US population age, and then we say package. It's inside the package gcookbook, and if we enter it, there is no package name as ggstream. So what we are going to do is install dot package, and then in the string we provide ggstream. We save it, run it. We run it here, and once it's installed, it will be get installed. We run it again, we get all US population by age. Sometimes there is always a glitch in the RStudio that it shows prompts once the data is loaded, but once you click the data, it gets shown. And also once the library saw that I didn't have ggstream, the RStudio itself is asking whether I should install or not. Because we know the command, and knowing about command how to install it, it's very easy to do it. Basically you have a lot of grip over your command. So here we could see the age groups, thousands, number of people inside that age group, and now it's time to plot it. So basically what we are going to do is we are going to see ggplot, and we are going to provide US population by age, and then in this aesthetics, in the x-axis we need year, and we need in the x-axis we will add year because it's a time dependent graph. In the y we will add the age number. So basically we are going to divide it by 1000. So basically number of people inside this, and it's a huge number, so we are going to take one more divided by, once again, 1000 by 1000. Why? Because we don't need to get those big chunks of data. So aesthetics, x is equal to years, y is equal to 1000 divided by 1000, and then we are going to fill it with the function that is forecast, 4 cards, and then in this, from this we call FCT reverb. In this there is method called FCT reverb. This reverse the order of factor levels. Once we do it for the age groups, we need to reverse it by the age group factors, and then we just add our command groups. We are good. Let us save it, run it. Okay, now we have no issues. Here is not found. So basically y should be capital, and then in the end we call geom stream function. So we save it. Age groups not found. So basically here also we have a typo, which is age. So there is a lot of time you got typo, but the best method is to just go through the error and try to debug it, try to understand what the compiler is trying to say. So here we have got our data. There is one challenge for you. You need to use lab method to add the title to the y-axis and the x-axis. Also, you need to change the label for the legends. And once, let us see how we could do this. So first, we need to add labels. Lab, in this title, we provide US population by age, and then the x-axis is the year. You need to add this in strings. So basically, if remember that the labels should be in the string, then y could be or peoples in thousands, and then what we could do is we could add also fill, which is our legend, to be named as age group. Let us save it. Here's our stream graph. So in this lecture you have learned how to draw time series graph, how to draw dumbbell graphs, how to draw area graph, how to draw slope graphs, how to draw stream graphs, and now you have been very efficient in the data visualization thing. So in the next lecture we are going to look at how you could train models, and I'm very excited to see you at the next lecture. Thank you everyone. Hey everyone, welcome to the R Masterclass lecture. In this lecture we are going to look at the statistical modeling in R. So in this lecture we are going to look at what is linear model, what is statistical model, and what is generalized linear model, and we are going to look at some codes, that how you could run this code in R for modeling. And then we are going to look at why we need to use statistical model, and then we are going to look what is the privilege of using statistical model in our language. Once that we are done with it, we are going to look at how you could use linear model formulas and generalized model, linear model to create your models and train your data onto it. So let's dive into the first thing, that is introduction to statistical modeling in R. So in simple terms, statistical model is just creating a simple representation of your mathematical model that explains that how each other variable is related. So basically, if you have a data of area of price, right? Suppose you have a land and you have a price. So what are the factors that affect the price? So basically, it might be the location that which location that it is. It might fall into the criteria that in which area it is. So if you want to create some formula for it, so suppose we could say that, suppose this is let us first me erase this. So let's say you have P, which is the price, and you want to create some formula that in which factor this price depends. So suppose this is let me erase. Basically this is denoted by y, which is our independent value, and we say this is our price, and we want to get an idea in what factors it is related. So this could be related on to alpha factor, uh, which could be valuing from 0 to 1. Its range is would be 0 from 1, and it is multiplied by x1, and this x1 could be your price, your area, which is similarly, it might also depend on alpha 2. This could be is also range lies in between 0 to 1, and into uh, the other area could be like area, then it could be like uh, the other factors could be like condition of like land area, land area, like what the land area is in, then nearby places, all those things could be added. So this is a generalized linear model, and the value of alpha generally lies between 0 to 1. So what is mean by 0 to 1? It defines the number of like how much dependent it is. So if it's 1, so only area factor is deciding the price ratio. So this all other factor would be 0. So your alpha plus alpha 2, alpha 3 should be 1. This should be 1. The number of factors, that is number alphas are this number of factors, and this addition would be the summation of these alpha would be 1, and the alpha defines the number of dependence on the uh, like how much it's varying the price. So if it's 1, so it's wholly dependent on area factor, and if it's 0.5, it's like half of this uh, dependent on area factor, and it's dependent other half on the rest factors. So you get an idea like how much alpha provides, like it's provide the importance for the formulas. Now we have got an idea. Let's look on to the definition. Statistical model is the process of applying statistical analysis, basically mathematical formula, to data into the order to describe, understand, or predict a phenomenon. So we generally apply this model to get an idea, okay, how this uh, trend is happening, or is our hypothesis is correct. Like if we are predicting that price depends on the area and all those factors, and in this the area factor is the much more dependent case. Is this hypothesis correct? So we could use those um, phenomenon to describe your statistical model, and basically this allows statistical modeling allows us to to check or test our hypothesis. So in simple terms, it involves creating a mathematical representation, which is generally like a linear formula, that is y is equal to x1 plus x2 plus x3, and then you have alpha 1, alpha 2, alpha 3 basically. And here the y is known as your dependent value, and x is known as independent value. So y is your dv, which is dependent value, and your x is known as independent value. So you got an idea, okay, what is statistical models? Basically, it helps us to explain how other variables relate to each other. So how these variables relate to each other, that is why your price. These model allows us to analyze trends. So if we use price, remember you got an idea, okay. So we created a data visualization for price stocks ratio, like the we have a time, and then we have a price for the stocks, and then we got an idea, okay, that we try to predict those trends. Now what we will do is we will use linear model to predict furthermore, like okay, on day 7, like on next day, will it be upward or will it be downward? We could use or these model to predict or analyze its trends you could use this for COVID modeling. And in our data lecture, like in your building a project lecture, we are going to use this uh, formula to analyze this trend. Then we make prediction and test hypothesis about our data. So now it's time to look at why use statistical models. So basically, the first reason is to use statistical model is data understanding. So you could uh, statistical modeling will help you understand the relationship between the variables. So basically, y is equal to your equation x1 plus alpha x2 will help you to understand the relationship between the variable each other. So for example, if you uh, we have the exam score, the y variable as exam score, then these parameter is equal to would be the number of our studies, number of our studies, then number of sleep taken, number of hours played. These could be the factors that help us to determine the exam score. And using the relationship between these variable, we could try to model a equation and try to understand, okay, which influences more. And for generally speaking, you might get able to find out that the number of our studies may be directly proportional to the exam score, and through statistical model you could able to prove this logic. Now let's look at the next one, that is prediction. So statistical model help you to predict the future values. So once you have your model determined, and remember we let me clear this. So if you remember those plots, we were able to plot till the data we have. So once we got an idea, okay, how the data lies. Suppose we have a equation like that follows this path, and we have data till this point only, that is x1 and y1. And what to do if we need to have a uh, plot more, like we need to plot for suppose x n and y n. So what we do is we could create a or statistical model. We'll try to figure out, okay, which parameter follows this line, and then we generally the through statistical model we could able to predict the future values, that is x n and y n. So suppose you want to determine the future stocks value, you want to determine the forecasting of sales or estimating risk or number of sales, or your sales prediction. Generally, the statistical model is used in real life also, or and in industry level as well. Next, we have hypothesis testing. So you created a model and you want to suppose you want to find, say that, okay, exercise is good for your heart rate and it reduces the uh, heart disease. So you have created a hypothesis, and to prove your hypothesis testing, the statistical model could help you. So if you able to know, like you able to get the data for your heart rate and number of exercise taken, and then you plot a diagram over it, you might able to find out there is a downtrend in when you exercise and the number of heart rate, and your statistical model would be able to justify this reason. So if for example, does an increase in exercise reduce cholesterol? So this is a hypothesis, and how you could prove this? Using statistical model. Now, statistical model help us to assume to assumption or theories about the data. Example: does an increase in exercise reduce cholesterol? And you know that through statistical model, if you have the data, you could prove this hypothesis testing. So we have got an idea. Okay, what is hypothesis testing? And now let us look at the next one, simplification. So what do I mean by it? So by using models, we could reduce complex data into a simplified mathematical form. So basically, we have a very complex data like a heart rate or some suppose we have the data of number of uh, COVID data. Using these complex data, like we have those data in huge number, and these complex data can be simplified using mathematical form, and then we could make interpretation using data visualization. So we have uh, in real life we have data in billions. So how you could do this? So basically using mathematical equations, we are able to compose this data. Basically, there are some more things that are involved. That is basically PCA and LCA, just to remove combine those features. That is the suppose for number of for example, we have scores scored by a student in an exam, and the features are involved is study, the number of hours study, the number of hours you sleep, the number of hours you played. These are the features involved in directly to your number of scores. And this table is very complex, and suppose this data you have very huge data, so calculating for a statistical model for each variable features would be very tough. So there are mathematical formula that is known as PCA, principal component analysis, which help you combine those two or three features into a single feature. So this uh, we don't have to deep dive into it, but just have to know about okay what is PC and else thing and what it does. Now we have got an idea okay what is statistical models. Now let us learn what are the benefits of using statistical models in R. Now let us look at why R is mostly used for statistical modeling. Why not use other languages for statistical modeling? So the main reason for R is used for statistical modeling because it already provides you built-in functions and libraries to train on this, and the flexibility of R for the implementation of various model, that is it's range from simple linear regression to more complex model. You could easily do this in R language. Now let us look at some key concept in our language. Now let us look at some key concepts in statistical modeling. So basically, there are two main concepts that is known as dependent and independent variables in modeling. Basically, what it is suppose if you have come across this equation, right? Y is equal to ax plus bx. So hey, now it's time to learn about key concept in statistical modeling. So basically, in statistical modeling, there are two terms that we are need to know. That is dependent, and then there is independent variable. What it is basically we have equation something like this, right? Y is equal to ax1 plus bx2 plus cx3, like those all those terms till xn, and it could be any numerical value ranging from 0 to 1. And basically here this is dependent on these terms, so this is known as dependent value variable. Why? Because this is dependent on these values ax plus bx plus xyz, and x1 plus x2 x3 x till xn is known as independent values. Why? Because these values do not depend on any other criteria. So these do not depend on this value. This value does not depend on x3 value. This value x3 does not depend on any other criteria. So it's known as independent variable. So the let's just look at the definition. The outcome variable we are trying to explain or predict. So basically, this is variable is the generally the outcome variable that we are trying to predict. Whether this is Boolean, might be your result would be a true or false condition. So this might could be those case, or you are trying to predict some numerical values that could be salary. All those stuff is for the dependent variable. This is the which is independent, dependent on the independent terms. Now let us look at the definition of independent variables. variables that potentially influence the dependent variable. For example, for salary, your one of the independent variable could be age, because there is no relationship, but there might could be age is independent of salary, because you every year you go, but salary is dependent on age by a factor x1 that we will able to calculate through statistical modeling. Similarly, for salary, the education level is a independent variable, but for salary this is dependent on this factor, and to get the idea of how much it is dependent on, we will use statistical modeling to find out. Now, in R, there are two types of generally model, basically three types, but we are going to look at those two types model. The first is linear model. Basically, linear model assumes the statement to be straight line. So basically, the values are basically expected to be the straight line, and the linear model is, and the values should be in this curve only. So if your data set is look like this, the linear model is best way to go. So here is your values, and this is your linear model that is trying to predict this values. So these assume a straight line relationship between predictors and the response variable. So predicting a salary based on years of experience. So basically, this could be your uh, one of the linear model line for your salary. Next, we have generalized linear model, which is extension of linear model, but it is for like if you have count data variable or some outcome to be a binary, either 0 1, then the generalized linear model is helpful. So these are the extension of linear model that handle non-normal data, basically binary data. Generally, we use for binary data, that is if the result is 0 or 1. So, for example, it could be used in predicting whether a patient has a disease on symptoms. So, the outcome could be yes, the there will be the patient might have a disease or might not have a disease. So, this is a binary outcome, and the best way to use is generalized nonlinear model (GLM). Generalized linear model. Other case scenario could be, for example, whether will it going to be rain or not. So what model going are you going to use? Yes, generalized linear model. Now there are um, we live in very in a world where everything can't be on the linear thing. So for non-linear model, basically there might be special case scenario that you might be able to find linear model, but most of the times there are chances that you might encounter with non-linear model. Basically, they might be like suppose this might be your scenario for the data set. So it might be like y is equal to x square, like curve for your data set. So these capture more complex relation that can't be expressed. So this in this case scenario we need to use non-linear models, and we are going to look at the code how to use this non-linear model. So predicting a population growth over time period with a curve. Next, we need to look at how to fit a model. The basic idea behind a fitting model is to estimate the relationship in the predictors. So in R, it is often done using the LM, which is a linear model. So once we have the data set, we need to fit it onto a model. We use linear model or GLM for if you want to have a generalized linear model. If your data output is like output of the result is yes or no condition, in that case you could use generalized linear model. These function take a formula and a data set and input output of a model that estimates the parameter like coefficient and predictor. That best explains the data. So for model, next we come to the model assumption. So while building, we have certain assumption we make while building this model. The first is uh, the relationship between the response and the predictors are linear. So basically they don't depend on each other, and this is known as linearity. So the relationship between the response, that is uh, y, and the predictor, that is x, are linear in condition. So a1, x1, b2. So these in the case they are linear. So they follow linearity. Next, independence. Observation are independent of each other. So this variable x1 is not dependent on the dependent variable. So these are the assumption made while building the your model. Now, now let us look at the process involved in statistical modeling in R. So before uh, directly fitting onto the model, the data are not clean. Like some values might be null. So you might need to handle those. Then there might be, you need to encode the data, that is like some names like Abhijeet. Like for animals, it could be the names. So you might need to encode those data, because the coding, basically the mathematics way to do is just give some node name to that variable, and basically it's encoding coding. We call that encoding and decoding categorical variables. So uh, first thing, we need to clean the data, right? So because we don't want any data to have null values, because if it have some null values and we are trying to fit those null values and it doesn't have, suppose, some missing data, so the model will not perform very well. So what is the first thing we need to do is basically data preparation. So basically we get the data, and then we do what is basically we just clean the data. So what here is, we are getting the age list is NA. If the data have any NA, so then replace this by mean. So one method is you just replace it with the mean. You could Another is to remove whole data. It's up to you. If you want to replace it with the mean, you could replace it, or you could just remove that data. Next, we have the model selection. So this is the next main important thing. Once you have the data clean and transform, you need to select um, which model you need to use. So basically, if you need to use linear model, you could use linear model, or you need to have some binary outcomes like yes or no, you could use GLM. And if the data is non-linear, you could use NLS model. But this is very important step. So suppose if there is a data of classification regression thing, like whether it is going to be a rain or not. So what you if it's going, then this is a yes or no type of question. So if someone asks you which model you want to use, so which model you will preferably recommend to use, basically you would prefer them to use the GLM model. Why? Because its outcome is yes or no. Suppose will the student will pass or not, which model you will use? Yes, you will use GLM model, because it's a yes or no type question. Next, suppose here we have a linear model. We draw some lines. Here is our variables, and suppose which model here you want to use. Basically, you will use linear model. Suppose there is some equation. Your model is like this. So you might want to use a linear model, which, because by looking at the data plot, you could see that you are able to visualize this data. It's better to use a linear model, because it's following a linear path. Next, this is always not the case. There might be times that the data is on the shape of like this, and say like it's making a curve like sinusoidal curve. So which curve you might want to use? So at this time you want to use non-linear models, because it will use the function fit the model, and it will provide us the value. Now we have got an idea. Okay, we have used the model, we have selected the model, we have cleaned our model, then we have to do is the model fitting. So we what do we do in this is we use our built-in function and adjust the parameter to best fit in the data. So basically what we do is we basically write this line of code, basically use linear model from the data set salary, experience plus education level and data, and the data fits into the linear regression model. And don't need to be scared, we are going to look, so you don't need, so for this, you don't need to be scared. We are in the next upcoming data visualization of linear model. We are going to look at how you could use the linear model. Now, after this is model evaluation. After fitting a model, we evaluate how it explains the data. So after we have fitted the model, we want to explain how it fits the rest of the data. So this is done through the metrics known as R square, or like standard error. Basically, it's a graph, and if it's less than 1, it shows that the data is not have been uh, properly fit. So provides a comprehensive view of model fitting and significance of predicators. Then once we have looked onto the model fitting, then we look at the model diagnostic. Okay, whether it's uh, model is fitted or not, is correct or not. So it's crucial to check that model assumption hold. So we plot all the data variable, we check all other curves like AIC to compare different models and their values. So once everything is validated, you don't need to worry about this model diagnostics, because very few people do that, and it just basically compares doing the all thing again but with different models. Once we have got an idea, we do the prediction. So once model is used, we need to predict the values for the latest value. So suppose we have built our model till here, our graph is we have built. So what will we do is we will create one more straight line that will be called our linear model, which will help us to predict our latest value. This is also done for the other values as well. So suppose if you have a curve polynomial graph, you could use those, and basically you will get an idea. So you got an idea, okay, how does the prediction is used. Now with this we could wrap up our lecture. So for example, let us look at one more example, that is predict model new data def generates. What it does is basically our line of a code that is used to predict the values, generates predicted value based on the fitted volume. Once the validator can be used to make prediction on new data. Once you have got an idea how to make prediction for the new data, then your model is done. So your statistical analysis is completed. Now in the next lecture, we are going to use how to use this code line of a code in R and how to build a data visualization. So with this, I hope you have gotten understand, okay, what is statistical modeling is, what are the type of model available in this, and what are the steps we follow, what are the assumptions we made in our language. And with this, I will see you on to the next lecture. Thank you, everyone. Hey everyone, welcome to the R Masterclass project building session. In this session, we are going to build two projects, and our first project is COVID-19 dashboard. So if you remember right, in 2019 COVID was high on its peak, and in the news there were a lot of data visualization there. So one example you could see that there is Zoho Analytics, and they have this bar plots and this map plot, and you already remember how to build this plot. So what we are going to do is, we have already the data set that we need from this website, and what I will recommend you, I will add this link to in the end of the lecture course material, so that you could download this data set. But basically this data set have the time series data for confirmed deaths and confirmed recovery. So what we are going to do is, we are going to take this data set, clean it, and use it for all for our prospect. And now let us come back to the context. So on 31st December, right? Let's look at what is COVID-19. So before you build a data visualization plot, there needs to be added. The first thing you need to add is some context. So here we are adding some context. So uh, World Health Organization on 31st December 2019 alerted several cases of pneumonia in Wuhan city, which is a city lies in China. The virus did not match any other known virus, and because it does not match any other known virus, this raised concern that it's a new virus and we don't know how it will affect the people, and this causes panic in the people. So daily life, so what it was, it's a very communicable disease. So if you come in contact with any other person, you might have got a chance that you might get affected. So daily level information on the affected people can give some interesting insights when it is made available to the broader data science community. So what people did was, the data set was available publicly and they were trying to build some data visualization onto that, and which was helpful for other people to look, okay, the cases are going up, now it's coming down or not. So that was the prospect idea. So here John Hopkins University made an excellent dashboard using the affected data cases, and they made it available to us, that the data set we look onto. So what I want to show you now is the John Hopkins University made a website. So now let us look at and get inspired from this. So if you come to the provided link, this is the dashboard they made, and this is, you could easily made this based on time series plot, bar plots, stacked bar plots, and you could easily create this one. And then we have a map plot, and then we have daily cases and number and incidents. So what we are going to do is, we are going to make a simple dashboard which will have this map world and weekly cases, weekly deaths, weekly dose administrator. We will see what we could plot in the dashboard, but you could take inspiration from this plot, and now in the lecture we are going to look at how we could plot this. So if you are curious how I download this video dataset, here's the button to download it, and it's you need to download a zip, and once it's downloaded you need to keep it, and in upcoming few seconds I will tell you to extract it and keep it in where. So now let's look at the data visualization process. Now let us look at some data visualization process that is involved during your building your data visualization. So basically in any data science thing there are four parts. First part is your data, getting the data. So first part is, where do you get the data from? So once you have collected all the data, remember we have collected our data from the given link, and once we are getting the data, what we need to do is data wrangling. And data wrangling is the similar term used for just for cleaning, transformation, and or reorganizing. So we do to call all this term means data wrangling. Then we use analysis and visualization process to determine general trend in COVID-19, like your given data, and we try to find some trend based on the visualization. So now let us look at the code and how you could code this out together. So now I have opened my R console. Now what I have to do is basically, remember we have downloaded the code previously, so we just need to the downloaded, what I mean. So now I have opened my RStudio, and if you remember we have already downloaded our dataset. We just need to extract and set our working directory there. So what I will do is basically I will take that downloaded file and put it onto the same folder. Now what I will do is basically I will set my working directory to this code. So either you could type a command or you could directly use GUI. So this is my project that I have saved onto, and this is my downloaded file that I have saved where the data asset is, and this is my working directory where is my code is. So why we have done this? Basically to get the data set, it will be easy for us to get those data set. So here you could see what I'm trying to do is basically trying to import those files, and here this code what is doing is just saying, hey, go to this file location and update, get the code. So here there's something needs to be updated, that is this is should be inside. So now what we need to do is we need to tell where the file is. So it's inside the or archive folder, and here you could see it. So go inside the archive folder. So what I will do is basically I will cut those code and basically update this code, and this is inside archive, and let us check if this is correctly working or not, and we will run the rest of code again. So it's saying that it cannot able to find read.csv. Why? Because we haven't imported those package. So now what we need to do is basically import the CSV method that in which the package is. So before we import the data set, we need to import the libraries, remember. So basically we weren't able to use read CSV method. So what we need to do is first we will import our library and then run it. So if you are getting something like there is no package installed tidyverse, so you could directly install it or you could run a command. So we also need one more package that I will show you how to import it. So once it's here is your time lapse, and this is basically how you use GUI. So basically if you haven't any library, the RStudio will always ask to whether to install or not. So once you have imported it, what we will do is we will import another library. So library, and then we will need to call the method that we need to import is ggdark, and you could see that this is there is no package called ggdark, and to install it through command prompt is install dot packages, and you just need to add those. So either you could run directly use GUI or you could directly enter here, and it's saying install dot packages not found. So let's see if install dot, there is typo. So let us look why it's not installing. So the reason why it's not installing is because there is some typo. So install dot packages, and this needs to be inside a string, and we haven't put this inside the string, so it's giving us a error. So now hopefully this should work, and it's going to our screen where our packages reside. It's similar to pip for Python, if you remember familiar with Python. And once it's ready, so we could now run our code, and let us first do the following thing: remove all the environment variables, and it's saying confirm.csv does not exist. So we'll try to see where is the missing link. So there was a typo that this needs to be confirmed _us, and the issue was we need to set a working directory. So I have here you have to come to the gear icon and come here and just click on set as working directory. Basically it will set up your working directory, and then what's done, you just need to update the time file location, which is time series COVID-19, which is this file. And once we enter it, Control Shift Enter, we are able to get the TS confirmed. Now we need to do this for similarly for other plot as well, that is for recovered, for deaths, and we need to have one more file, that is read.csv, that we will look into. So what I will do is basically replicate this code for other as well. So I will just copy this and then I will replicate this code for TS recovered, and here we just need to change for recovered cases. Then what we need to do is we need to import for death as well, deaths, and then we just need to just replicate this similar code here. And if you are looking at this code and you might wonder what this end line means, basically here this what is this is basically, if you look at what does this code do, provide state is equal to call characters, but basically what it is basically we have this code, right? And if we able to import data set, and if we see here that the country region is a character data set, so we need to tell the read CSV method that this country region and province state is a character data type. So you need to import it as a character, not as any other data type. So here, for example, if our code include this and it uses other data type for this, for example string, it would be difficult because this is numerical value and we can't treat it as a string. So that's why we are telling our code to just maintain those. And if you looking at this is just a CSV file, comma separated values that you don't need to scare off. So we have imported deaths and all those things. Now what we need to do is we need to get the country code. So basically, if your country code is +91, so like it's for India, so it should be able to map those to the your province area. So for this, there is already data set available, that is from Plotly data world GDP with codes, that I will show you in here below. And let me go to the new line and let me paste it. And basically what it is basically, if you look at go to this code, is basically it's world GDP with codes that we need, and basically GDP and code we need from this. So that's why we importing this data. And if you need to look at what this data set is, either you could look it from here or you could go to the link that I have provided. So you get the code, right? AFG, Alabama, and all those code we need to get those. So we have got their GDP as well. So we will have some idea related to, okay, some country have this much GDP and their annual spent on vaccines or any other thing, we could get those. So now it's time to move on to the next part, that is or pre-processing. Let us type pre-processed data, and it's a very good way of habit to have comments on the code. So we will type pre-processing data. So if any other user see this code, they will know, okay, we are pre-processing it. And what we do is basically, if you look onto our code, right, TS covered, and you might find this thing, the date column. For each date we have separate rows, and we don't need separate columns for each date. So what we will do is we will create only single column for dates, and we will add those into. So what we have done is basically gather date and from the recovered, for instance, and add a column that is date column, and similarly for TS recovered and deaths. So basically we are saying call the gather method, and we provide the data to be the date, and the key is the confirmed values, and then the C, where is the column province, state, country, large, region, latitude, and then we have said mutate the data, which is consider or date as a new column and create one. So once I enter those, you could see our data must have been verified, and now we have only 6 variable with dates added onto it. Now we have got an idea, okay, those are done. Now we need to do one more thing, is that we need to get the total cases. So to get the total cases, it's basically total date, total confirmed plus total recovered plus total deaths, right? Because that will give us the whole total cases. So what will I do is basically run a total code, basically gives us the total cases. So basically total cases, and I have already written this code. Basically I will just give you an idea what we are going to. So TS confirmed, TS total is total confirmed plus left join deaths, and left join it's recovered. So if I open confirmed data, deaths, and we have the TS recovered. So what is left join? So left join is basically the data set that is common between TS confirmed and TS dates. So let me go through the Excel draw, and I will explain you this in very much briefly. So here is the basically a join statement, and there are 4 types of join statement, basically inner join, outer join, left join, and right join. So basically let us look at the inner join. So in inner join, what happen is, suppose you have two data set 1 and data set 2. The inner join is considered to be the common of both, that is known as inner join. Full outer join is known as the combination of table A and the combination of table B and the common part also. Left outer join means you have suppose data set A, B, and you have data table A, then the table A with the commonality between table B also. And right outer join is similarly, but for opposite, table B, but the commonality of table A also. So joins, where are joins basically used? And this is basically similar to discrete mathematics, if you remember. In your 12th, I think the discrete mathematics is there, but we don't need to dive deep into that formula thing. But basically joins are used in SQL lot, because we have lot of data set, and from those data set we need to get some few data set, suppose commonality thing, then we use join table. Let's say we need to get the common data, we use inner join. Suppose we need to get the combined data, we use right join. And suppose we need to get the table A, but we need to get the commonality of table B also, then we use left join, and similarly right joins. Now we have got an idea, okay, what left, right, and inner outer join is. We could now move on to the code and understand what we have done there. Now once you have got an idea, okay, what is left join is, we will look on to what is TS total and other code is. So TS confirmed is basically the left join of TS deaths, that is the commonality of between the TS confirmed and TS recovered, and then we mutate into and create another variable that is recovered, and replace any values with 0. So if there is any values that is 0, then we replace it. And then what we have done is, the another cleaning step that we have done is the TS total. So we have removed any nonsensical country region. So for example, that there is following values, that is Diamond Princess and MS Zandam, which is basically a cruise ship in which COVID was also detected, and but in the data set it's where there, so we need to remove that as well. And then in the last, what we need to do is basically, if you look onto this code, what is saying is that we need to remove any death value have any values with 0. So let's look onto the code that how we are doing. So ts total, get the death column, and if is na, that is if it contains any na values, then replace the total deaths value by 0. So if I enter this, control shift enter to run the program, we will be able to get all the na values for death to be removed. So if I open ts total, you will be able to see that there is no na values here, and you could do similarly for other as well, that is recovered and confirmed as well. Now we need to get the cases latest, and to get the cases latest we need to create a command. Basically it's a type of SQL command, and what we need to do is we need to get the latest by any date which is the date which is recent. We need to get that latest at the top of the trend. So now let us look at how we could code this. So I have got this code to get the latest code, basically latest cases, and I will give you an explanation. Basically, lot of this command is based on SQL, and you might wonder what is SQL is. It's a coding programming language for manipulating data set. So a group by command in SQL is basically get the country region by the dates, and then we summarize the content, that is confirmed deaths. We sum the data, we get sum the data for the recovered, and we sum the data for the deaths, and then we create a new variable method, that is mutate new case is equal to confirmed and minus lag confirmed by percentage. So what it does is basically shifts the value by 1 day. So this calculates the number of new cases by subtracting the day from the previous current day. So we get the new cases by shifting the one column by 1 day. Basically we adding a lag, so we could get the new cases previously to the 1 day, and then we trying to get this thing by max date. Basically it's for the date which is maximum in the data set, so which is basically means only the latest data set. So in here max data means basically we are getting this data set for the latest date, and then in the last we are saving the max cases in the day latest variable. So if I run this, you'll be able to see the latest date that is available in the data set, and you get an idea. Okay, so here's the latest data set that is available, that is for 2021 5th of month and 29th date, and here we have cases latest based on those. So here is the latest data based on that particular date. So we have 191 observation out of total. We have something about 135k, and you get a whole idea that how much data set we include. So if I run this, I got the latest data. Now we have cleaned our data set, we have covered up all the latest data set. Now we are going to see how we could code out the plotting thing. Now let us code out the rest of the thing. So we need to get the codes, and we have already get the codes from this. So we will get this code and basically create a world visualization plot, which will be more understand once we are done with it. So we'll get the codes data set, and in this we need to get the or country and the code. So we will select country, and then we will select the code, and then from this what we need to do is basically create a rename or region with country code as well. So region, and this is will be set to country, and then we need to rename the code. Sorry, we need to rename the code from our code thing. So we will create a code, and this will be our codes, and then we will map this to the column ID. So row names to column, and then if we able to see it, then we just need to map to the ID. So let us save it, and it's saying that unexpected input. And whenever you have some kind of a bug, it's a good chance that you try to figure out yourself, because it's opportunity to grow. So basically we have a typo, and there are chances that that you might get lot of uh, lot of uh, lot of typo in R, basically because of its odd structure in coding language. But here we are able to get the country codes based on the data set we have and the region. So what will I do next is basically uh, create a region based and replace the string from our total case. So here in the code region, if you get this latest, we this have this all this code, but these some of this country region doesn't have standard name. So basically uh, uh, for for example West Bank, so it should be replaced by with West Bank and Gaza. It's including Gaza. There are some cases that we need to consider. For example, United States, but its standard region code is US, so we need to replace that as well. So I will just copy this code and show you that what I'm doing. Basically, this is what I'm doing is code ID is a integer part that we have done is. So this thing code latest, sorry, in our codes we are representing the ID as an integer part. So that what we are doing through this, and then what we are making is that making sure the country region are properly aligned with the standard name. So basically we are going to replace United States with US, with Macedonia with North Macedonia, Czech Republic with Czechia, and then all those things. So basically we are doing this because once we create a global plot, we need to get the standard name. And here with the cases latest codes, what we need to do is join left join, that we have the latest case with the codes that we have created. So we are casing latest cases latest with the codes we have created by the country and the region name. So here our common column is country region, and then we are arranging it with the descending form of the confirmed. So if I run enter, we'll be able to get the whole idea. So now we have got our latest case based on the case code, and here we have with latest code cases with their standard name. And here you could see the top 3 region lies with this latest COVID confirmed cases: US, India, Brazil, and then top 10 we have France as well. But you could see the number rising for both. For US, India, Brazil are very higher. Now let us plot a data visualization plot, that is a globe plot. Basically for this we are going to use geo map method that will plot our geometry 3D plot. So if I look at plot geo, and it instantly plot a geo object, and if I run F1, we'll be able to provide the data frame, and we need to provide some standard data set. Now let us see how we could code this out together. Now here I have wrote down some code that I will explain you what it does. So basically what we are trying to do is basically plotting a world COVID-19 test total case by day, and here we are trying to plot total number of recovered versus death. So here what we have done is we are getting all cases from our total data that we have created. So if we look at our environment variable tab here, you could get all those data from our case latest date variable, in which we have all the data regarding the confirmed deaths and recovered. So we are going to plot those thing, and what we are going to do is basically we are going to plot deaths and recovered data. So we, for this, to plot this, the first thing in your mind should come is the bar chart plot. And if you remember, in the bivariant plot, we plotted stacked charts that we are going to use to plot it. So basically here we use our deployer package to get the total confirmed cases and new cases from the cases total date, and then we called bar chart, and then we called our geoplot function to plot the total cases based on aesthetics x, which would be our date, and for other plot we are plotting is in which or would be a y would be our confirmed values would be a, and it would be stacked upon each other and denoted by red color. And similarly we are doing for the bar chart for all cases, and in this we are plotting for the recovered cases, and then we provide our title to be a GG title World COVID-19 total case by day, and then we let our legend to be at the orientation of horizontal, and we passed our ggplotly method directly to the bar chart variable. So we called ggplotly method, in which we passed our bar chart plot. You could see here that it needs to provide a ggplot method which includes a plot, and here we are providing the ggplot created a ggplot function, and in this variable we it is stored in bar chart, and then we are passing it to the ggplot method. And once we call this function, sorry, this is a function, and once we call this function we could get this plot. And looking at this plot, what you could infer is basically you could see that the number of deaths precedes the number of recovered. So if you look at the number of deaths, you could see that it is more than the number of confirmed plus number of deaths. So it's the highest thing. So the number of recovering was very less in COVID-19 than the like more people were dying instead of recovering. So that's, we get an idea from COVID-19 total cases by confirmed, and now we have got an idea, okay, total number of deaths is more than the total number of recovered. Through this data set we have plot. Now what we could do is we could plot more visualization plot. What we could do is the next we are going to plot is the mortality rate and recovery rate. Now we need to see, okay, what's the recovery rate for this and what's the mortality rate for this plots. Now what I have done is basically created a mortality rate graph, and what we are going to look at onto is basically I have created a bar chart one variable, and in this I have selected a date and recovery rate as my data parameter to select from the case total data data set, and from those I have selected the date and the recovery rate variable, and then from those I have gathered the ratio date, and then I have plot the aesthetics of this. And basically it's a geometrical bar plot that we have plot, and we have added some theme color to it. But we once and then I have laid out the passed this variable into ggplot function, and in this I have also called the layout method. Basically what it is basically for to get the legend into the ratio, so in horizontal orientation. So we have this recovery rate legend which is on the horizontal orientation, and then we are able to see that the recovery rate ratio is very less. So what is recovery rate ratio? Basically total number of case and the number of people recovered at that particular day. And you could see that it's very unstable, that it's increased, that was good, and then it decreased, and then it increased again, and then it decreased. So it's very unstable, and this is not very good for a country that have, like for us, because the recovery rate was not increasing. It was very absurd, like it was increasing for few days, and then it decreased. So it was very challenging, and then people were trying to find vaccines, because at that time vaccine was not also there. But what we could do is we could also check the mortality rate. So I will select only the mortality rate and try to find out. So I have changed only one part of the code, that is, let us calculate the mortality rate, and let's try to find out the other plot. So here we have the mortality rate also, but it's very much similar to the recovery rate. It's very also unstable, that it increased for few time, and then it decreased, and then it increased. So it's also absurd that mortality rate was also what basically mortality rate is basically the number of deaths per by total number of total case. So it's good if the mortality rate is increasing and the recovery rate is the mortality rate is decreasing and the recovery rate is increasing. So that way you are able to find out, okay, we are recovering from the mortality from COVID-19 cases, but in this that wasn't the case. The mortality rate was also absurd, and the recovery rate is also little bit absurd, because it was increasing and then it decreased for few times. Now we have got an idea, okay, what was the mortality rate and recovery rate. Now let us try to plot some representation, okay, by top 10 regions that which country have. So what we'll do is basically we'll now plot top 10 region with confirmed deaths and recovered. I have written the code for the top 10 confirmed cases based on the country region. So what we are going to do is basically top 10 confirmed cases all over the world, and we know that top 3 was US, India, Brazil. So what we are going to do is we are going to plot it. So top 10 confirmed cases, the latest cases, and then we are selecting the country region confirmed, and then we arrange it by descending order, basically by the number of highest most would be on the top. Once done, we create a bar chart variable. In this we get the top 10 confirmed, and from that we get the top 10 values of it. So here we use a slice operator that get us the top 10, and once we get the top 10 we reorder by it country region, and then we get the confirmed value, and then we plot a geometrical bar. We provide all the data to it, and then we use minimal theme and create a continuous scale so that it does not break, and then we provide labels to it. So once you run it, you will be able to see that the most confirmed cases were from US, India and Brazil, and we could already see this in our first plot. If you remember, right, the first plot that we made, we were able to see that most were from US, India and Brazil, which already depicts in this. So if I give you a challenge, now I have created top 10, what you need to do is you need to create a top 20. So how will you be able to do this? So basically to do this you need to first add the top, instead of using the top 10, the slice operator, we are able to get the top 20. And here we also need to update our title, and you might be thinking what does we have to do with the title. But when you make the plots, it's necessary to add the titles, because other person could easily understand your plots. So here we have the top 20 plots, and in the top 20 we could also see the most of the countries were from Europe that were added to this plot. So now our next thing is, this is based on the top 10 confirmed cases. What do we need to do what if we need to make this for our top 10 most death case? So how will you be able to do this? So what we need to do is basically I will increase my editor, So here's my editor, and what we need to do is we need to get the top 10 by deaths. So similarly we I will code it out. So top 10, and then we need to get it by death. So we will create a death variable, deaths, and then in this we will store the top 10. We get this value by top 10. First we need to get the death number of deaths in particular in each country. So we will call cases, and we call latest, and then we call this operator, percent operator, to select by country region that we need to do it. And then basically once you select it by country region, then we need to select it by deaths. And once we selected it by deaths, you could easily add this symbol to this operator to basically get arrange this based on the descending format by deaths. So if we run this, we should be able to get our code run, and we should be able to get top 10 confirmed deaths. So here we are able to get all those data. Now what we need to do is we need to create a bar chart variable, so that will create have all most of the data into it. So it's similar to this code also, above code, that in which we create top 10 most confirmed case. The code is basically similar. So top 10 confirmed, top 10 deaths. In this we'll use this operator. Basically what we could do is basically create a bar chart operator, and in this we let's say we make it for deaths, and in this we create a operator. In this we select deaths, and in this we need to have only top 10, and we select a deployer package that should also satisfy this condition, that it should be the a ggplot. So now here we'll add ggplot case to draw our ggplot, and in this aesthetics we could say that x is or will be reorder on the number of cases by the country. So either we could easily copy this code line. That we need to do is, so I will copy this code of line and just update it, and instead of confirmed we need to do it for the death. So I will change it for deaths, and let me check if the deaths by the deaths. So if it's singular or plural, so it's by deaths. So once we are done with it, we just need to create a minimal graphics, like minimal visualization thing. So that's what we are doing with the theme minimal, and then we tell to create the geom bar plot method. We create a geom bar method, and thus we provide stats to be our identity, and it filled it with the red color. Next we call this method basically to plot our graph, and basically in this we will call the bar chart method, bar chart deaths basically, which is a type of a ggplot. And let us wait to see the top 10 most confirmed cases. But here's some error that we need to look out for. So I will say that can't subsist column by the location 349. There are only 2 columns. So let me fix this error and come back to it. And now we are able to plot it, but basically there was few typos that I want to show you. The first typo was this needs to be ggplotly, and the next typo was we need to add a plus operator. Now we are able to get the top 10, but what we need to do is basically call a method called coordinate flip to flip this plot to make more sense of it. So we will flip this plot, and we'll also need to add the titles and as well as the uh, scale for this. So what I will do is basically copy this line of code and paste it again here. So and top 10 most confirmed most death cases, and here we are able to get the most death cases plot, and here we could see India ranks on top, then Brazil, Turkey, and luckily US does not lies in this, which is very much surprising. But we got an idea, okay, which country lies on the most top of this deaths. And now what we are going to do is basically got an idea. Now it's your time to do this similar thing basically for the most recovered cases. So what I will do is basically re-replicate this code again, and what I will do is basically copy it again, this line of code, and we'll do it for recovered case. So for the recovered case, what we need to do is we need to first update the variables, and in this we need to get this variable by recovered. So we'll change this by recovered, and here this needs not should be death, it should be recovered, and in the last we need to arrange it by recovered. So here we say recovered, and once we get this we need to create a bar chart recovered method and top 10 recovered method, and here we are slicing it by top 10 recovered country region, and here it should be recovered, and let us change the fill color to be green to be changed with this other plots. Now it's okay. So top 10 most recovered cases, the recovered cases, and basically this needs to be bar chart recovered. So hopefully I'm thinking this should be the code now needs to be worked on first attempt. Let's see, if not we will fix the error. So let us run it and see if there is any error or not. So I think the recovered cases would be also on the top 3 would be India, Brazil and Turkey. Basically you could see that most of the cases that have been recovered is from also India, Brazil, Turkey. And if you are running late like previous version of this code, like on previous version of data, basically this code would be different for you, the plot would be different. Why? Because the number of cases were from the latest cases from like if we check the latest cases date, and it's the latest case date is from like, if we need to 2021 5th or 29. So if you are from getting the data from previous latest date, this might data set be different for you, so the plot might be different for you are getting it. So you could see the Brazil, India, Brazil have most of the recovered cases, and you might not able to see US because the US data set was not available. I checked that and it was for previous as well, which is little bit absurd that for we have total cases but not for the recovered and most death cases. We don't have that data set. Now we have got all the idea. Let's just see last plots, that is further analysis with most affected region or places. Look at the next plot, that is what we are going to do is now, once we have plotted all the data for top 10, top 6, now we are going to do it for particular regions, such as for France. Italy, Russia, Spain, and United Kingdom. So basically, we are going to do this for 6 countries. And what we have done is basically we take those country and try to plot those uh, total confirmed deaths and recovered. So here what we have done is we selected the country region, and then we called a filter that filters out the country region based on this uh, vector variable if on that data set. So it selects only this country from that particular data set. So we only have data set available for only top 6 affected countries. So if we look at the variable thing, you will be able to get top 6 affected, and based on this we have only 6 region data set available, that is for US, Spain, India, United Kingdom, Russia, and France. So I have changed Italy from India to check what's the change in the trend. So basically in first try I did it with Italy. Now I want to check it with the India parameter. Then we grouped it by country region. We tried to get the summarized confirmed cases and recovered total cases, and then we changed the name, that is we passed new cases, just change to get the latest date. We change the date by date 1, and then we get the recovered cases by recovered by total cases. Then we get the mortality rate by number of deaths. Then we created a new cases. We get the recovery rate and mortality rate based on this, and we then handle some any values. If there is any values in new cases recovery rate or in the mortality rate, we just replace it with by 0. That's what we have done. And then we have called the ggplot method. So what we have done is here is we created a plot ggplot and plot name variable, and in this we passed the top 6 affected data set we have created. In this we want to get the filter out the data before the 7th of 14th 2014 date, and then we wanted to get all the following variables data. So country, region, date, confirmed, recovered, and deaths that we need to plot. So we gather all those data, cases, names, and then we created a bar plot with the color red color, and the aesthetics x would be your date and y would be your cases, and then we filled out the latest names, and we created a facet of grid type, and legend position we added to the bottom, direction bottom, and all those data to it. And once let us see run it, because this time it would be different because I have added India as another parameter instead of Italy. Let's see what changes we see. There's no change, but there is slightly increase in the all three things. So mostly recovered death and confirmed case were increasing, deaths were increasing, and recovered was also increasing. So there is sharp increase in recovered, but then generally there was a sharp decrease also. The confirmed cases were similar itself. The confirmed cases were increasing in trend, and here we could see that the number of confirmed cases, deaths, and recovered were increasing. Both three were increasing, but there was some ambiguity in death and recovered. Basically it increased and then decreased and then increased. So it was not a general way that it was only decreasing and then increasing, but it was we wanted it deaths to be decreased and recovered we wanted to be increased. So that was a good trend, but it did not follow that trend. So now let's look at few more graphs that we are going to look onto. Now what we are going to do is we are going to create a recovery rate graph like this. In this we have this points that we will do this, and to create this plot we need to first create a, let us say, interactive plot that we are going to create. So we will name it to be interactive plot, and here we are going to plot the recovery rate. And to get the recovery rate, from where we will be able to get the recovery rate? So we are going to get this recovery rate from the total 6 affected data. So from here that we have created above, we are going to get this data from this total 6 affected area. top 6 affected area that we have. So we'll get this data, and then we will call percentage and get method. So to rename the names, which should be country region, and then what we are going to do is basically call the ggplot method. So here we call this function, and then we call ggplot, and then we called aesthetic method, in which we provide x to be our date, y will be our recovery rate, and then where y is our recovery rate, we pass it by the groups. Basically we have like renamed this group names to be name. Now once we have done this, let us see our plot, and then we will improvise it. So okay, so the plot is not showing because we need to call a ggplotly method to show the graph. And if you remember in our previous lecture, we don't need to call this, but we are using ggplotly, so it's having some issue with ggplot, so that's why we need to call ggplotly method. If this code is working for you, like without need to call ggplotly method, this should be working, like you don't need to call the use ggplotly method. So basically I have some issue with ggplot. When I use plotly, it doesn't work with ggplot, so you need to explicitly call ggplotly method and call it. So basically here we have this basically have the typo here, in which we need to fix it. It should be plotly, that I fixed it. And then what we need to do is we need to add the data to it. Basically the data have not been added, and that's why our graph is showing us empty. So what I will do is basically call geom line method, and in this aesthetics I will call the color to be by names, and alpha to be about 0.9. And then let us see how our graph look like if there is any plot. We also need to add point size, and here we could see that names does not found because it's by name, and we also have to add the point, geom point based on the line, so geom /point, and here we need to provide aesthetics and size. So we will provide the size to be like the size of 0.5. 6 is also good, no issue. And the alpha is just basically the color ratio. So basically if your needs to be have more color, you could add like its value is from 0 to 1. If the more it close to 1, it's more opaque it is. So that's the idea. And now we'll just add few more line of code, that is basically scale color and the title to it. So and whenever you build a data visualization code, you try to run it one like in between of your code instead of directly coding out in one go. Basically it gives you idea. So here it's saying some error, could not find plus comma function, and if we try to debug this, we could find out. So the issue was that we have a typo. Instead of name, it should be names. Remember that we name into the names, and here we have the recovery rate. Now once you have got this plot, you try to interpret things. So if you look at the recovery rate, since the case was more, the recovery rate was India was also too high. In Russia it was the similar condition, but you could see the recovery rate was similar to India, and for the rest of the country they did not have that much great recovery rate. and also they have very less case. So basically you could see that recovery rate is increasing, and also we saw that their case was also low, so that the chance of this thing is that the recovery rate was decreasing as well, and all the confirmed cases was also decreasing. Now we have got an idea of how to plot all those things. So currently you could see we already have lot of plots here, and we have looked at each plots in very much depth and detail. And what you could do is, I will post this code into my GitHub. You could clone this code and try to play with it, and try to get the idea of it, that what is happening in this code. So what you could do is, once you create a code, I will create this code. I will what I need to do you to do is, you need to change these colors, and you need to create your own kind of graphs. Remember stack graph, you could create those plots in between India and Brazil, and create a pull request to my GitHub repo. So the GitHub code repo would be in the course material section of this course, and you could use this code to build your, like, create a pull request, and I will check your code and see how far you have come. So with this, the first project is completed, and in the next lecture we are going to look at the next project that we are going to build. And with this, thank you for following till now, and I'm happy you have come till come this far to the course, and I will see you on to the next lecture. Hey everyone, welcome to the R Masterclass last project that we are going to build. So our last project is Iris dataset visualization and statistical modeling. So in this, what we are going to do is, we have Iris dataset, and what we are going to do is basically do some visualization. We are going to look at some bivariate plots. We are going to look at some multivariate plots, and we are going to do some box plots onto this histogram plots, and then some violin plots. And once we are done with it, what we are going to do is, we are going to create a statistical model, and try to run on those data sets. So once we are done with it, the next thing we have to know about is, what is Iris dataset. So basically, Iris dataset is a dataset which contains the data of this flower. So Iris have dataset basically have three flowers, basically, uh, that is Setosa, uh, versicolor, and Virginia. So let me grab my pen and I could denote. So basically, what happened is, uh, the Iris dataset, basically Iris data is a flower species which have three categories, that is Setosa, versicolor, and Virginia. So these three are the species of this flower, and basically, uh, this versicolor and Virginia have some overlap in their stem length and stem petal length. So and Setosa is, you could almost is lesser than this versicolor and Virginia. So what we are going to do is, we are going to create a plot, data visualization plot, in which we are going to look at some histogram plots of this plant's length, petal and sepal length. We are going to look at onto those, and we are going to figure out, okay, what are the differentiators between those Setosa, versicolor, and Virginia. So once we are done, once we have got an idea, okay, what is Iris? Basically, I will repeat through. Iris is a flower species. Basically, it contains three species: Setosa, versicolor, and Virginia. And versicolor and Virginia have some overlap in their petal length and sepal length. That's make it a little bit hard to detect which is versicolor or Virginia. So, what are we going to do is? So, we have this Iris data set, and for lucky us that our studio comes with pre-built installed library. and it already have iris dataset. So if you open your RStudio and type command data iris, that we are going to look into in just few seconds, you will be able to get those data set. So we don't have to load any data set, and basically if you wonder how what are other data set RStudio come with, it have motorway vehicles also it comes with, and lot of other data it also comes with. But we have to look onto only the iris, and basically it contains 150 observation of iris flower from three species, that is Setosa, versicolor and Virginia. And these each features observation includes four features, that are sepal length, sepal width, petal length and petal width. So these are the four observation we have that we are going to look. And for each data set, for example Setosa, there would be sepal length, sepal width, petal length and petal width. For versicolor it would be, we have sepal length, sepal width, petal length and petal width. And similarly for Virginica, we also have sepal length, sepal width, petal length and petal width. So we have got an idea. Okay, iris data set contains 150 observation. In this we have three iris species, which include we have three flowers that iris species include, that are Setosa, versicolor and Virginia. Now we have got an idea. So what is our goal? So our goal is to create a visualization that help us to understand the relationship between these features and species. And next we need to create a statistical model that will help us determine which is Setosa, which is Virginia and which is versicolor. Now what I will do is, I will open my RStudio, and before that I want to show you the data set. So now I am here at iris dataset. So here you could see I'm inside the R documentation, and basically I'm inside their dataset they provide in version 3.6.2 and in the topics iris. So in this you could see the famous Fisher of Anderson's iris dataset set. So it's data set from the Fisher's or Anderson's iris data set. They might be the researcher who have created those data set. The measurement in centimeter of the variable sepal length and width length and petal length and width length respectively for 50 flowers from each three species of iris. The species are iris setosa, versicolor and virginica. And from this we total have data frame of 150 cases, 5 variables: sepal length, sepal width, petal width and petal width. Iris 3 gave the same in the three-dimensional array of size 50 by 4, that we are not going to look into 3, and they have this, the how to use the they have like some example code, but we don't have to use that one, which is not for all use. What we are going to do is, we are going to run the RStudio. So I am opening RStudio, and here I have opened my RStudio, and it says update available. So I am going to say remind me later on. Basically, I don't want to update right now. I will update it later on after this lecture. So I will create a new script, and if you know the shortcut keys, basically it's Control Shift N, and I will save it to my desktop, and in the R project I will save it and basically name it R iris, in which we are going to do the visualization. So the first thing is we need to do is to import those data set. And to import those data set, I already told you that this data set is already available. So if you want to get this data set, let us say let us say DDoS, and basically it's a flowering name condition variable, and if we call data method and we name iris, here you could see that iris data set is available. And here you could see the documentation. This is famous iris data set, given the measurement in centimeter and variable. and basically if you will open click F1, you will be redirected to the same page that I was on in the first thing. That is similar to this page, you will be redirected. So here you get the documentation for this, and we are going to first import those data set, and it should be in string. So iris in double quote it should be in, and once it's there, let us save it. And we have iris and it's in promise, and we have got our data set. So here I have done some changes in this code. What basically happen is, in this, if you get this error, is basically saying that filter and lag package is getting conflict because they both have the same name. That's why they are getting some conflicts. That is mask co-plot is getting masked from this object because they have the same method function inside those libraries. Basically, both they have is same naming functions, and that's why what we need to do is we either we could handle those changes or we could leave it. So basically we don't want to go deep dive into it and change those package name and in the library. But what we are going to do is now is we are going to do some visualization. So what I'm going to do is going to call create a variable name that was, which is basically iris dataset name, and we are uh, going to allocate that name to going to provide that to the iris. So if you look at the exploration and global environment tab, you could see that my iris and DDoS have those both same variables, and you could also see uh, one of the advantages of RStudios compared to our other console is that you could able to get inside the variable thing. So you know that iris contains 150 observation and 5 variables, and also you could look at that which variable it is containing. That gives you you might be thinking, okay, so what's the benefit? The benefit is that when you have some error, right, uh, you need to know, okay, which variable is holding which value. And we run debugger a lot of time onto those. When if you are on into programming, you might want to use debugger. Basically that gives you the value of each variable, but at this RStudio you already have all those value variable, and you could see, okay, which value it is holding. So DDoS is holding 150 observation of 5 variables. So I know that, okay, now the iris is containing the correct data that I need for the visualization. Now what I will do is basically run a head command to get let's say 6. Basically head is basically to get the data set, what else the data set contains, and it's saying object dado is not found, it should be contain a typo, and here is the top 5 of the data set. And if you want more, we could add 7, 6, all those things, and we get the and you if you look on the console, you will be able to see those value here. Now what I'm going to do is basically I'm going to get the summary of this data set, like what the values it contains, and it's generally in data visualization you want to know the summary of your data set. It's the thumb rule, like you first see the data set, okay, what are the values it's holding, what is this. So like you could see that it's sepal length, what it is, sepal width it is, what is petal length, what is petal width, and what is species it is. And one advantage of our studio is you directly could see it from here. But anyhow, that's a general rule in our like if you are going to do some visualization in Kaggle, people always do this stuff first to get idea about what data set it contains. So summary, and then this we need to provide the data set. So we need to look at the data set, and basically you get idea, okay, so the minimum length the sepal length, you could see that it's 4.3, and the max is 7.9, and for sepal width you could see that the minimum is 2, And the one thing, like I have already done the distribution, so I will give you the spoilers first. That the setosa have lower sepal width, length, and height, like petal width and petal length. It have lower kind of length, like it's have lower sepal length, sepal width, lower petal width compared to versicolor and virginica. And versicolor next is the second most in the after then we have lower second lowest is versicolor, and then the highest one is petal length. So if you look at this, the minimum, I'm pretty sure that this might be coming from this setosa tablet, and the max that is contributing most is coming from this virginica. And then you have the median, that where the most range lies in, that is 1.3. The mean is like the average is about 1.19, 3.37. The the petal sepal length is also about mean is about 5.83, and sepal width is about 3.057. It's better to check and try to get an idea, okay, what the uh, doc what this visualization is trying to tell us. Now what we are going to do is we are going to do some ggplot, and for those we need to import our library, that is ggplot. We are going to import ggplot2. So it's inside ggplot is inside the ggplot2. Now what we are going to do is we are going to create a histogram plot. So let us see how we could create those. So here I have already written down some codes, and in the next of this code we are going to code together for sepal width and petal length, petal width. We are going to do it together, but basically I want to give you what we have done. So basically we created a sepal length. We created the ggplot method. In this we need to provide, first thing is the data we need to provide. So we have provided our data to be DADOS. Then we did the mapping thing, in which we called our x plot would be our sepal length. So this is our if you look at this plot, this is in the end, this is our sepal length, is our x-axis. We called a geohistogram. We then say petal length, histogram to consider bins to be 30, which is directly a default value. If you say if we remove this, it could always take 30, I suppose. And so it's saying using bin 30, pick a better value with bin width, and we have to add 30 basically. It's saying we need to use. So we have added bins 30. You could also play with it, like how many bins you need to provide. I usually play and love it. Like this is 10 bins, how it would look like. But 30 is the correct way to denote. And then what we have done is basically used the theme WSJ, which is black, and our background is black, and our font of our title is little bit dark. We provided a GG title. You could also provide use xlab to provide the x heading. There might some issue, I don't know why, but it's not showing the x title. And then we have done, what we have done is called plot grid. Basically it calls the sepal length to show the plot. Now what you need to do is you need to give a try and try to attempt yourself for the sepal width, petal length, and petal width. So in this you could pause this video and try to attempt by yourself. So what I will do is try to attempt by myself. So what I will call is sepal. Then we need to I'm going to solve this, so I hope you are able to do it. If you have able to do it, you could skip this part. So basically ggplot, and then we provide data. This, or the data would be DDoS, and then what we are going to do is mapping aesthetics. X is equal to or sepal length, sorry, sepal width, which is or the data value. So if you look at the columns, this is our width we are going to map for, and the rest of the things are same, pretty much same. So histogram, and we are going to say bins 30, bins 30, fill it with red color, fill it with red. The outline color could be the black. The size could be 1.3 as per our like. Then we need to define the alpha. The alpha is basically the transparency which lies between 0 to 1, and you could either keep it 8, 9, but I think 0.87 are the best values for this. This provide little bit transparency and have better theme. And if you are in very much hurry, you could see your graph as well now, because we have coded out that thing. And now the rest of the thing would be just call the plot grid method and provide our sepal width. And here is our sepal width. And what we could do is basically copy the theme WSJ. Then what we need to do is we need to also copy this title labs. Either you could code it either you could write it down yourself or just copy paste, because both are the same thing. That we need to do is Control Z X labs title, and then sepal, instead of sepal length we need to say it's for sepal width, and sepal length histogram instead we need to correct it with sepal width histogram, and save it, and let's run it. So here is our histogram for sepal length and sepal width. And now what we could do is basically do for similarly for other, and if you want to show it together like sepal length and sepal width, we have got this theme already. And you might be wondering why there is the difference in the theme, because we forgot to add the plus append method to get the same theme. Now we have got our petal and petal width, and you might be able to see it here in much more clear way, the sepal length and petal width. And here the sepal width is the 3.1 have largest range that lies into this, and if you look at the for sepal length, the highest values range lies for lies about 7, but we don't need to uh, have to always look into this. We could also look into this, and we could know that the most of the range lies in median and 5.8 range. So if we look for sepal length in the 5.8 range, this would be the one 5.8 range. So most of the thing lies here. And if we look at the mean, so if we look at the mean, and basically the issue here is that we are doing for all the things for Satosa, Versinica and Virginica, but that's why this variance is lying, it's not exact 5.8, it lying before that and after those as well. So it's combination of those things as well. So 5.8 and then if you look at 3.7, 1.9, those are the median value range. And for sepal width, you could see that 3.01 is the highest one that have most of the values lying in. And I'm going to shorten this graph, and basically I will click my environment variable, and what I will do is I will create the rest of the plot, and I will remove this plot grid method and do the same for plot length. Petal length. So what we need to do is similar thing. Just need to copy this code and do do the same thing again, and sepal length, instead we need petal length. And then what we could do is, instead of sepal dot length, we could do by petal dot length, and pretty sure it's in the camel case. Sorry, it's in the first is in capital, and then this should be sepal. Also, sepal should be petal, and this is based on length, so we don't need to change that part, and petal length. And in the last, we need to call last method that we need to call is plot grid method, which will have our graph plot grid, and we pass the petal length, and we save it and run it. We get the petal length, and we could see that most of the values lies around 0 to 1 range, and other this is most of the setosa, and then the other are the virginica and versicolor. So that makes sense. And if you not are able to plot by get a clear idea why I'm saying this, that this lies in the setosa range. Once I will get into multivariate plot, we could plot each in different ways. What we are trying to do is going into the stepwise, like first the one plot altogether, then we do multivariant, bivariant, then multivariant plots. So it will be easy for us to understand. Now what we could do is, similarly for second, we could do it for petal width. So instead of petal length, petal width, and here we could call petal width, and instead petal length, we could say petal width histogram, and here petal length, instead we could do petal width, petal sepal length, sepal width, and save it. And we have got our 4 plots together. If I just increase my screen width to show you how it looks like. So here is petal length. So we have looked this one. So this one is new one. You could see there is some kind of breakage through that 0 to 0.03 in petal width histogram. If my cursor is I hope this cursor is available to. Are you able to see this? But in petal width histogram plot, in this fourth one, second one plot, you could see in the x-axis, it's there are like how much breakage is this, like 1, 2, 3, 4, 5, 6, like some about 6 breakage. So what if we could see there is some for each species there might be some criteria for each petal length and petal width. So we will try to use, and at the end we will create a statistical model. So help us out. So these are the 4 model, 4 data visualization plot together. Now what we are going to do is, a good method is, one of the best method I will suggest you is to change each plot color. So I will leave up to you, because it's very easy. You just need to provide the color name and just need to change the color thing. So for each this color you need to change the color. So I will do the rest one more, and then you need to do for the other things. So maybe you could make it red, green, blue, yellow. You could make those. The primary colors would be complete. So this is done. So we have completed our sepal length and sepal width. Now let us look at some density histogram plot. What that we are going to look at, basically box plot that is known as, and try to interpret something from it. Now let us look at the next plot that we are going to look at is sepal length and density plot, which is density plot and the blocks plot. And if you remember, this line shows the I'm just going to repeat through it. Basically, the middle line shows the median, the lowest values, the highest values, and the range it lies in. So that's the how the sepal length is basically. This is the median lowest value, the highest values in that range, and the upper to most point are the lowest and the highest point it lies in. So now we have looked at the sepal length box plot. Now what we are going to do is we are going to see how to plot this. So I have already wrote down this code, and this would be a basic code. And next, for the other two, sepal length, sepal width, petal length, petal width, we are going to plot it. But basically this code is a guide through how you could do this. So here what I have done is basically I have called ggplot, and I have provided our data, the DOS mapping aesthetics sepal dot length similarly to above, and instead of geom histogram we have called geom density, and then we have called fill is equal to red color, basically fill the other inside our plot to be red color. Then we have used color black and the size to be 1.6. Alpha we use 0.7. I usually use between 0.7 to 0.8. Then the theme I have used is economics theme. The X lab is basically the title. I have used sepal length, and the GD title is sepal length histogram, and this should be density plot histogram. Sorry. So yeah, just need to update those. Then what we have done is basically called our sepal length box plot, and we have said did the similar thing ggplot data DDoS and mapping aesthetics in which sepal x is our length, and then we have created our box plot, fill it with red color, black basic, and size 1.2, and the alpha is 0.7 similar to the above. And to call the box plot we need to use the stack box plot method, and here once we have used stack box plot method, geom is equal to error bar, like what's the geometry is, and it's not necessary you need to call the geom, and if we run we basically get the box plot without color. So basically it is for our color, and the theme is economics theme, xlab is our sepal length, we have provided our title, and then we have told or called a plot grid method to plot it. So here's once we have plotted, we could plot it for the rest of the thing, that is sepal width box plot, petal length box plot, petal width box plot. So what we are going to do is we are going to do, let's say you try to attempt those three, and if you have any issue you could if you are able to solve it you could skip this part or you could watch it. So what I'm going to do is code again this thing for other three. So in this I'm going to go very fast because it's similar thing that we don't need to do much, basically sepal length. Instead what we need to use is, yes, sepal width we need to use, and yeah, sepal width is correct. And then what we need to do is, instead aesthetic x is equal to sepal dot length, instead we call sepal dot width, and then in this geometry density we fill it with red color, we have outlined black color, size 1.6, alpha 0.7, and theme economist xlab is sepal length, and we provide the title to it, sepal, it should be sepal width, and then sepal width density histogram. And similarly for this we need to update this for sepal width, and or sepal width here too, and sepal width box plot. And then what we need to do is basically here also you need to update those by sepal width and box 1 is correct. So let us run it. and here you could see the width in very much shorter range. And for width density, you could see the in 3.0 the highest density is there. Basically, if we look at the density sepal width histogram, we could see there is a peak, and which signifies that here is also the peak. So most of the values in that range is the highest lies in. And in the density plot, it's very much clear. And this, if you look at this, there is some outclass values that does not lies in this range, that are shown by dots, these three dot in box plot. Here, if I zoom in, you might be able to see clearly. So here is the value lies in the half range, in the 3 point range. Now what we need to do is next for the petal width and petal length. Similarly for petal width and petal length. So what I'm going to do is, it's basically similar steps, and instead of sepal we need to do it for petal, and this time we need to get the petal length. So I'll change the width to length, and here aesthetic is needs to be petal, and our first petal P should be capital, it's in capital casing. And petal length spelling, there is also a typo. I have seen the typo in the starting variable, and it's better to fix it first, because later you might get some issues. Because when you try to declare some variables and you see it's not uh, uh, that correct naming, so it might be not a clean code. Basically, there are rules for clean code. Variables should be always in small casing. Camel casing should be followed for the functions, and the variable names should be in, like, the data frame needs column needs to be in camel casing. All those terms needs to be followed. But basically, which is next in the X lab, we need to update the petal length, and here also we need to update the petal length. And here we also have to update it with the petal length, and then here also we need to update it with the petal length. Petal length, petal length. And you might be wondering why to waste too much time on naming. Trust me, when someone sees your code and sees too much, it will be not, other person sees your code and he sees this plot, and if there is no naming, right, if there is no name for petal length, petal width, he might not able to understand those things. So it's better to name it first than to name it last. So sepal width. So here we have a typo. Instead, this needs to be a petal width. So sorry. Let me check once. Petal length, and here we need to show the, instead of sepal width, we need to show petal length. And here you could see some trend that there is some local maxima, and then there is minimum, and then there is again maxima. So if we look at the plot for petal length, and this is true, like here is some maxima and then there is minimum there, and this signifies there. And here we could see most of the values lies before in the range of the median, and then the most of the median values, and the rest of the values lies after the median. Like, it could be 80 to 20%, that thing could be. Now you could do the similar thing for uh, petal width, and to do for petal width, it's similar thing. And if you know how to do it, you could skip this part. Basically, it's just for your sake that how I'm pulling this petal width and economics petal density histogram petal, and here petal width. Yeah, naming needs to be updated. So petal width, petal density histogram, that's correct. So here needs to be petal width. And now let us save and see the what we are going to infer from this. So okay, so here we also need to update the naming petal width, and in the plot grid you need to update the variable that which needs it to be mapped. So now it's correct, and it's similar to petal length also, like it's have some increased maximum and then minimum, and petal width also follows the same thing, some high and lows and high and lows. So that's what we are getting, and the minimum lies around 1.5, below 1.5 might be 1.4. If you look at 1.4, somewhere here for petal width. Now we have got an idea, okay, how to create the histogram plots. Uh, what I need to do, challenge you next is to create the same plot similar to this, where all fours are there. And I will give you the hint. Basically, it's similar thing. Instead of box 1, you need to change the variable name for other variables to be box 1, 2, 3, 4, and you need to change the color, and then you need to add all those variables here, similar to the or this plot grid method that way we have added. So I will show you the answer basically instead of guiding you. So basically, here in sepal length, box 1 is there, sepal width, box 2 we could name, and I'm leaving the color up to you. It's very simple. I hope you are able to change it. Box 3, petal width, and here we have called box 4. So now we just need to do the similar thing, petal length, and then box. Uh, Petal length is box 3. Yeah, yes, box 3, and then petal width is box 2, and petal length is box 1. So let us save it and run it. We get all the plot, and basically it's not looking too tidy because we have lot less space. But if I increase those space, you are able to get those. So here you get all this plot, petal width, petal density plot, petal density plot, and I see here the typo in the density. You could fix those, and I will challenge you to change the color for each those plot to be same. So petal density and this to be same. So it's more intuitive that what lies with it. Now what I'm going to do is I'm going have seen some, there is some header variable is there. I don't like extra variable though that we haven't used, so I will remove this, and you don't need to worry about those. Now what we are going to do is use, if you remember, this is we will use multivariate plots to plot or plots again, so get an idea, okay, which values rises where, and by next plot you will be able to clear, okay, why I was saying in the start that it was size smaller than all other three, then petal length, then other two. So let us see in this next plot. Now it's time to build a model, right? So here I have wrote down some code which I will explain you that what we have done. So basically we have done is basically trying to predict the sepal length, and we have created a linear model, and in this we have provided sepal width, petal length, petal width, species, and data is equal to iris. And iris predicted sepal length is by uh, directly predicting the model. And then what we have done is, let me just run this code, and it will take some time. But once we have done, you could see the iris. We also here you could see the predicted sepal length. So if we look at predicted sepal length and petal length, it's somewhat very close. So it's 5.0 to 4.7, right? So it's almost uh, exact. Let us see in graph like how much it's close. So let me just go through this again. So if you look at sepal length 5.1 and predicted sepal length is coming out to be 5.0. Similarly, the predicted sepal length is 4.9 and predicted sepal length is coming out to be 4.7. Similarly, 4.7, 4.7, this is exactly correct. 4.6, 4.8. So there are some off and on, but it tries to predict nearest to the value. And let us show our actual versus actual sepal length versus predicted sepal length. So uh, here the line is the or linear model, that is or linear model, and all the other thing are just the predicted sepal length. So how do you create a linear model? You just draw a straight line that connects all. Try to connect all. So whenever models try to do is basically it tries to create a line that covers all those. But in general, you can't create a model that exactly defines the correct value. So what it does, it gets the average value from here. So its value is somewhere here for predictive. Some model have, like, you could see that some predicted sepal length value is way down the line. So uh, it averages out and draws those lines, and it try to fit those lines into the data set. Once they are done, what we have done is ggplot iris that we have. Then what we are doing is aesthetics. X is our actual sepal length, y is our predicted sepal length that we have created. The colors are species based on that, and then geometric species, which is point size, that 3 species are there, so that we are doing it. And we are drawing a line based on this dash line, and then we add actual sepal length, we add y predicted length, we created minimal theme and added plot title and created our graph. Now here we have looked on to the how you create a predicted actual sepal length and predict actual sepal length and predicted sepal length. Now, with this end of this project, I want to congratulate you all that you have come so far. I hope you are able to now understand how data visualization works and you are able to create some beautiful graphs. And you could tag us in the group, in our channel, that what plot you have created. And I'm so proud that you have come so far and learned so much in this course. This is one bit of the course. The next bit of our course is also there. So next is our SQL, and then after this we go on to the AI/ML, and after this you will truly master the data science in Python and R. So with this, I will see you on to the next part of this course, that is SQL. With this, I Abhijeet sign off.